Hello everyone, welcome to Intellipaat. Data has become the new oil of the 21st century. Any company which wants to succeed, the key factor which takes place in the success of their product is data. With the advancement in technologies, companies have now figured out how they can basically make the product better by looking at the past data of how a user basically behaves. Now with this, the amount of data which is being generated every day is around 2.5 quintillions bytes of data. Now, how do you process this much amount of data? What's the problem? And this is exactly what the big data problem is. So to solve the big data problem, we basically came up with a lot of tools. One of them is basically Hadoop. So today in this session, we are going to talk more about Hadoop and how you can use it to solve the big data problem. But before we move on, guys, if you haven't already, please subscribe to the Intellipaat channel and also click on that bell icon to never miss out on any updates from us. So now let's go ahead and understand the agenda. So guys, first of all, we'll understand what is big data and what is Hadoop. Once you've understood it, we'll move on and understand what is HDFS and what is MapReduce. Once we're done with that, we'll move on and talk about how we can process data using Hive. And after that, we'll talk about Apache Pig, its features, and the different data types that can be used in Apache Pig. Alright guys, after that, we'll be understanding more about Hive, where we'll be discussing the different types of Hive and indexing and partitioning. Once we're done with that, we'll talk about Spark, where we'll talk about Spark Architecture, Spark RDD, Spark Components, and then we'll discuss about what is Kafka. Once we're done with that, we'll talk about what is Spark Streaming, and finally we'll end this session by basically talking about a Hadoop project, which we are going to implement end to end. So guys, this is the agenda for this session. I hope it's clear to you. Now let's move on and talk about our first topic, which is what is big data.
Why choose big data as a career option? So there are a lot of fields in which you can expand your career in, but why should you choose big data? The answer for that is quite simple. Data is the most valuable commodity in today's world. All successful companies like Amazon, Facebook, Google, all of these companies keep their commercial data hidden. It is a secret, it is confidential, and it is quite frankly the key to their success. If somebody external gets their hands on that data, they could replicate their success formula. But why is that? Why is data such a commodity? The answer for that is quite simple as well. We create multiple accounts on these websites like Amazon and Facebook, millions of users every day generating terabytes and terabytes to petabytes of data every day. So data is being generated in a fast and continuous manner, which means on an everyday basis. And the data is extremely large in nature as well. Like I said, petabytes at times, the data could be extremely large. So the companies on which these users are creating their accounts on, performing these transactions upon, the company has two choices. Either they could keep the data as it is, discard the data, or use that data for their own commercial success. So that is what data analytics essentially is. And when the data is extremely fast and continuous in nature, it's being constantly generated, and the data is extremely large in nature as well, coming from various sources, then that data is termed as big data. And the terminology we use to define the analytics of big data is big data analytics. So if we look at the trends on Google Trends, if we look at the search term data analytics, we can see that since 2004, there has been a gradual increase in the number of times this particular term has been searched. This indicates the increase in popularity in today's day and age of the term data analytics and the field and domain in general. So there was an article by Gartner which said by 2020, augmented analytics, which is a subfield of data analytics, will be the dominant drivers of new purchases of analytics and business intelligence. And we can see the left-hand side, the top 10 technology trends in data and analytics. So it involves a lot of artificial intelligence and machine learning. Because naturally, when you have a large amount of data available to you, you can create a lot of models. You can increase the accuracy of your machine learning models. You can increase the efficiency of your artificially intelligent systems. And this is precisely why data is so valuable. Once you've accumulated the data, once you've collected the data, there are a lot of branches you can go about. You can go into machine learning, you can go into artificial intelligence, you can just be doing simple data analytics, you can go into data science, you can go into data visualization. There are a lot of fields and scopes available to you once you've collected the data. So, business intelligence is mandatory for commercial success, and especially in today's world where every company is going online. If you want to compete with these companies who are going online and using these technologies like data analytics, like data science, like machine learning and artificial intelligence, if you want to compete with them, you have to come on the same platform as well. And what is business intelligence? It is simply a branch that arises out of the data analytics domain. Then competitive customer satisfaction is driven by analytics as well. So this is especially true, for example, for e-commerce companies like Amazon. The reason Amazon is at the top of the food chain today and not eBay or any other company or any other e-commerce organization is because Amazon uses its customer data, Amazon uses its transactional data in the most efficient way possible, in the most profitable way possible. They've created the best models, the best recommendation engines, the best customer service, the customer experience that they provide. So all of these things have attributed essentially to their immense success today. And customers are naturally driven to better experiences. Since Amazon provides them that experience, that is why Amazon is at the top today. Then large amounts of data. So the big data part of it comes when we're dealing with extremely large amounts of continuous data. So that comes under big data analytics, yet another branch of data analytics that we're discussing about today. And organizations like Facebook, like Amazon, like Google, the data that they generate is in such a large amount that it definitely qualifies for a big data case as well. And then the optional artificial intelligence and machine learning. So once you've created your models, once you've extracted the data, collected and cleaned it, then you can implement artificial intelligence and machine learning on it. It's not the most widely adopted tool today. A lot of companies are getting into it by seeing the success that it brings to other organizations. So these are fields that are arising out of data analytics that can be expanded upon once you get proficient in normal data analytics. And once you're able to create successful AI ML models out of this data, there is no doubt about it, you will be able to arrive at your output at a much faster and much more accurate way. So here are some major organizations that use big data analytics today. So Google, Bank of America, Tesla, Apple, Amazon, Netflix, Facebook, IBM, so all of the big corporations, these big companies, they are successful today, and they're successful exactly because they've kept up with the times. And they've implemented big data, they've implemented data science, and they've implemented AI and ML in their workflows. And make no mistake about it, these organizations are continuously looking for talent. And that brings me to the average salary of a big data developer. So in the United States, the average salary is about $107,000. In India, it's about 10 lakhs per annum. And in the UK, it's about 67,000 pounds per annum. So that is a lot for an average worker in the big data developer industry. So that competes with a lot of popular fields today. But that's not it. The reason why this amount of salary is lucrative is because this field is ever evolving. This field is the future. Data analytics, data science, and AI ML are the future technologies, and these technologies are going to stay. So if you learn these technologies, you will be able to be viable in the market for a much larger time. And that in turn brings me to the importance of a certification. So a certification is a stamp of excellence. So it basically says to the employer that you've completed a course in the set amount of time, with a set required amount of percentage or grade, whatever the course is offering you. So that naturally helps you get hired because the company now knows that you can be vouched for, that you've actually had some experience because you've been certified. There's also a substantial increase in pay if you're looking to expand or change your job profile. If you're coming from a simple data analytics role, if you're coming from a simple relational database role and you want to expand your role to a big data analytics expert, so there is a substantial increase in pay because those two fields are vastly different. And you have clear corporate requirements. So because these fields are so lucrative, they obviously want the best talent because there is a lot of talent out there in the world. So they've set their requirements at a set standard, and you need to succeed in those standards to be hired in those organizations. So what helps in that? Knowledge plus projects. And the certification basically tells the employer that you have both of those. So let us look at the learning path that is involved in this particular technology. So if you're getting into big data, if you're getting into data analytics in general, firstly, you need to have a basic and minimum understanding. So I'm emphasizing on the word minimum because that's all you need. Basics of mathematics and statistics, like averages, like graphs, how to read graphs and all of those things. You need to understand just a little bit of that. And then basic programming. So if you're getting into big data, then you need to know some programming. A basic amount would do. You don't need to know a lot. You need to be accustomed with database technologies like MySQL and NoSQL and all of these other relational database tools. So you can get proficient at one of those and that would suffice. And then we have the big data technologies. So in order to implement data analytics in a big data environment, you need to be accustomed with the big data architecture. And those are essentially your big data technologies. And then once you've understood how the data analysis works, how the data collection, cleaning, and processing works, then you need to be able to present your information, your insights to higher management to in presentations. So for that, you need to have really good data visualization tools. So there are tools for that available as well, inbuilt in the technologies that you would be working with in big data. And then let us look at the job profiles. Now that we've looked at the learning path, let us look at some of the job profiles, sample job profiles that are available for you to apply in the field of big data. So this is the summary of what would be asked of you in a big data role. So the first point is the usage of advanced computerized models for data extraction. So when you have raw data, you need to be able to extract that data and be able to implement it in your tools. So you would be using some advanced computerized models for that. And that is exactly what is taught to you and what you learn when you start getting into big data. So the first step is data extraction. Then you need to be well aware with the cleaning of data because the data will have inconsistencies. The data will not be accurate always. The data will have missing values. So you need to be able to deal with that. And that comes under the art of cleaning of data. And then the art of analysis comes in. So you have to analyze the quality of data. You have to analyze whether the data holds true for every condition or not, and whether the data is usable. So that process of analysis is called the quality assessment. That is also a step involved in big data. And then you have to further analyze that data to extract some meaning out of it, or just to extract whether the data would have meaning when the models are created or not. So further analysis is required for that. And then the final analysis comes in where you've confirmed that the data has meaning. So you need to see whether the data fits accurately to the model that you've created or not. So that is done via creating some testing models and some training models. You do that, you create your models, and then you see whether there's a fitting, there's a match involved in that to determine whether your analysis is correct. And then whatever you've determined, you need to prepare reports for it. So you need to have good communication and you need to be able to visualize that results, those insights that you've derived from your data to upper management. So data visualizations comes in there. So the typical sectors where there's big data is used is banking, software development, consultancy, telecom, social media, very obvious use case, social media, academic, and pharmaceutical. So these organizations that are in these domains, they are generating a lot of data, and they need to be able to perform these analysis on that data to be able to have some viable insights in their user bases, in the work that they do, in the jobs that they are doing. So if we look at Spotify's big data analyst job profile, we can see that you need to be able to scope and solve loosely defined problems. So the problem statements will not be very specifically designed to you. Upper management will just instruct you with a set of guidelines as to what you have to do. And you need to be able to innovate and get to the solution yourself. You need to have deep understanding of statistics. So once you are familiar with the field of big data, once you are experienced with it, you naturally develop the deep understanding that you need to develop in statistics when you're dealing with big data. And you need to be able to understand real world data, because that's what you're going to be dealing with. You need to have the technical competence to perform advanced analytics with tools such as Python or Scala, and tools such as Pandas or SQL as well. And the experience should be with large data sets, because naturally you're dealing with the field of big data. So you need to have that experience with extremely large data sets. You need to possess the statistical competence such as regression modeling, alpha beta testing, and significance testing. So those are some additional requirements that you would gain as you go along in the field. And you need to have some demonstrated experience for that, for those talents like statistical modeling. And if you're dwelling further into the field of big data analytics, as you move further into the career, then you need to possess a certain amount of knowledge about machine learning, so that you're able to expand your insights into something that is much more efficient and accurate. Then we can also look at Nike. And the responsibilities that are involved with Nike include the use of contemporary data science and analytics methods to derive actionable business insights. So Nike has an extremely large customer base, and you need to be able to use that data in order to derive some business insights as to which products might be a tad more popular than the other products, and which products are not selling, and all of those things. So the queries get complex, but you get the idea. Master big data fundamentals, gather, clean, and validate large amounts of data on Nike's cloud platform. So you would be provided with a platform where you would be able to implement all of your big data knowledge, create foundational pipelines and repeatable production queries in the data warehouse that Nike provides to you to analyze these large data sets. So Nike will have this data, and you need to be able to data warehouse that data and perform your queries on it to basically solve Nike's use case. Develop process and continuous improvement of core projects through automation and process enhancements. So there would be some automation involved with your process, and creates the reports and visualizations. So in order to show upper management and the marketing campaigns, in order to improve the marketing campaigns that Nike has, you need to be able to sum up all of your insights, wrap it up nicely with a bow, and be able to visualize it in front of upper management.
So guys, Hadoop is basically an open source technology which was developed first by Google. So it was not called Google Hadoop back then. So what basically happened was that Google, since it had to deal with such a large user base, and it had to do web crawling for so many web pages which are available on the internet, it had to devise a system which can basically process large amount of data in the shortest time possible. Now, when it had to do that, it basically made us to basically develop a new system which we can basically implement and use, which can basically make or solve the big data problem, which is data at large scale. Now, when we wanted to do that, so some Google engineers came up with an architecture, came up with an infrastructure through which we could solve that problem. And once Google implemented that technology and was able to solve everything using that technology, Google basically rolled out a white paper right? And then this white paper was taken up by a lot of companies who were facing the similar kind of problems, that is the data problem or the processing problem of such huge data, right? They implemented that infrastructure, they implemented all the properties which are mentioned in that white paper, and this finished product was called as Hadoop. Later, Hadoop was basically made open source, and that's how now each and every company who's dealing with data, which is most of the companies these days, is basically they're making use of big data, right? And for solving the big data problem, the software which the people developed using that white paper is called Hadoop, right? Now, Hadoop is basically having a lot of other softwares as well, which when combined together, they basically solve the big data problem. Okay, now people who work on this technology, those are called Hadoop professionals or big data professionals, and there are a lot of profiles out there which are basically related to Hadoop, which we are going to talk about in this session. Moving forward, but why should you learn Hadoop? I just told you guys Hadoop is a software solution to a problem where when you had a huge amount of data or you have huge data to be processed, right? How to do that on using the traditional systems or the systems that we have, right? The server capacity that we have, how to solve that huge amount of data using the server capacity that we have is basically what Hadoop is, right? So why should we use Hadoop? Let's go ahead and understand that. So guys, now this basically the reason of using Hadoop, I'm going to tell you with respect to why you should basically change your job domain to Hadoop. Right, I'm going to talk about professionally why you should basically go ahead and learn Hadoop and implement the technology. Right, so the Hadoop market is basically seen or is going to see a staggering growth in the coming years according to Cloudera, which is basically one of the major companies who are working on the big data technologies, right? And they also happen to give custom software with respect to Hadoop, and they also the Cloudera framework. So the Cloudera company basically has devised a framework which is basically implemented on top of Hadoop, right? And according to them, Hadoop has seen a staggering growth in the past and is going to see staggering growth in the coming future as well, right? The second point is, according to Forbes, the average salary of a Hadoop professional is $115,000 in the US, and in India it's around $615,000, 1,615,000 rupees per annum, right? Now this is an average salary, guys, and a person who is shifting to the Hadoop domain based on his experience, he can gather a lot more, right? For example, I know people who are big data professionals and are also earning around 25 to 30 lakhs, right? So it all depends on your experience, it all depends on your skill set, which you bring to the table, because of which you will be getting a job as a Hadoop professional, right? Third point is, according to Glassdoor, in the last month alone, there were 5,765 jobs which are posted in India with respect to Hadoop, and currently there are 33,000 jobs in the US which are vacant for a Hadoop professional. Right, so if you were thinking, is there demand for Hadoop? Yes, there's a lot of demand, and according to big companies, this demand is going to grow in the future as well. So the future looks bright for Hadoop, in the sense that a lot of companies are going to implement the Hadoop technology to solve their day-to-day needs. And also, if you think logically, guys, if we are dealing with data, right, you must have heard about this term that data is the new oil in the 21st century, which basically means the more data that you have, the better your product would become, right? You would have heard about data science, you would have heard about machine learning algorithms, you would have heard about a lot of other things. So what companies these days are doing is they're basically reading how the user behavior is, right? Or they're reading how the trends have been in the past to basically predict what the user behavior or what the trends are going to be in the future, right? And since, when we talk about a company at scale, if we talk about a company like Google, who is literally basically serving the needs of almost 60 to 70% of the world population, right? having a company of this scale and this size, and obviously when people are relying on you, you would have seen that businesses these days, they're using Google products like anything. They rely on that Google product. They don't ever think whether that Google product is going to be down, right? So that is the kind of that is the kind of relevancy, or that is the kind of that much we are dependent on Google these days. And now when you're dealing with a company like this, that company has to come up with products which are world class, right? And that company has to come up with response times which are world class. Now, when I say response time, when you do a Google search, it gives you, in a matter of fraction of seconds, it gives you the search results. Now, how do you think it is able to crunch so much of data for your particular search query? That is because they are able to solve the big data problem. They are able to solve the problem of solving or indexing data, even though every day every user is contributing around GBs of data on the internet, right? So that's how your click streams, your personal data, your any website that you go to, they log cookies, right? They log sessions. So every data, if you basically talk about in a gist, or if you were to take an average, you basically are uploading GBs of data every day onto internet. With respect, if you are if you're a internet user, or if you are a user who is there on the internet throughout the day, right? So when you're basically uploading this much amount of data, and then Google has to process this much amount of data for you, let's assume, right? They're able to do that in a fraction of seconds. And how they're able to do that? Because of the big data technology that they are implementing, right? Similarly, other companies, let's take the example of Amazon. Now, Amazon, what it does is, you would have seen that they recommend you products when you buy a certain product. How is that possible? Using machine learning. And how is machine learning able to predict? By looking at how other users reacted to certain products. And this basically is possible when you have data with respect to what a user choice is, and how they should be basically saved, how they should basically be processed. And all this is possible using the big data technologies that we use in our day-to-day life. Okay, so this is just about what Hadoop is doing in the world today. Now let's talk about the Hadoop developer role, or the Hadoop job role in general. So what are the requirements and skills for a Hadoop developer? Let's go ahead and discuss that. So guys, these are the roles and responsibilities of a Hadoop developer in his day-to-day life, right? Or when he's applying for a job, these are the responsibilities, or these are the skills which are basically expected from a Hadoop developer. So your Hadoop developer should know how to develop and implement Hadoop architectures. He should know how to set up Hadoop architectures. He should know about Hive and Pig, which are nothing but sub components of the Hadoop ecosystem. Then you should know how to deploy edge-based clusters. You should know about how to query data at high speeds. What kind of queries would be able to query data at high speeds. We need to know about data privacy. We need to know about security maintenance. We need to know how to basically translate functional requirements or requirements from our stakeholders into requirements which other Hadoop developers will be able to understand. This basically requirement would be majorly when you would want to become Hadoop architect. I'll talk about more roles as we move along. Right? He should know how to write MapReduce codes. He should know about data warehousing, databases, Hadoop ecosystem in general, Apache Spark, Scala, etc. Right? Now, I basically told a lot of things on this particular slide that you need to know in order to basically get into a Hadoop job. Don't get scared with all the things which I mentioned over here, right? With all the good things which come in life, you actually have to put in some effort. And don't worry, I'll tell you how you can basically channel that effort so that in the shortest time possible, you can basically, if you are interested, you can basically shift your domain to Hadoop. Okay, having said that, let's now look at some of the skill sets which basically your Hadoop developer should know. So he should basically have proven skills in HBase, Hive, Pig, and Hadoop. he should know how to write pig scripts, he should know how to basically handle data with respect to tools like Scoop and Flume, how to use Hive query language, MapReduce jobs, and this he should basically have good knowledge on Hadoop as well. Now, apart from these, you would have also heard that a lot of companies have now shifted to cloud, right? So a good Hadoop developer or a Hadoop professional should also be able to know cloud platforms like AWS, should be knowing cloud platforms like Azure, should be knowing cloud platforms like Google Cloud. And this knowledge will also help you, because nowadays all these cloud platforms, they are basically also releasing big data services. For example, if I talk about Google Cloud, it has a service called BigQuery, right, which is nothing but a data store for big data through which you can query data fast. Similarly, in AWS, you also have some big data services. In in Azure also, you have a lot of big data services which you can use and basically implement them to solve problems in day-to-day life which companies face. Okay, so apart from knowing the Hadoop ecosystem, it has also become advantageous to basically know about clouds such as AWS, Azure, and Google Cloud, right? Having said that, what is the average salary? This we have just discussed. Just to summarize, in the US, it's around $130,000 per annum. In India, it's around £680,000 per annum. And in the UK, it's around £60,000 per annum. This is the salary of a Hadoop developer in the United States, in India, and in the UK. Okay. Now, your next question would be, then how do we go ahead and become a Hadoop developer or a professional? Now, before we go ahead with this, let me talk about the 3 profiles which are there in the Hadoop ecosystem, right? And then I'll also tell you which profile would suit you in order to basically shift your domain to the Hadoop domain. Okay, so the 3 profiles are Hadoop admin, Hadoop architect, and Hadoop developer. Now, what is the difference between these 3 profiles? Now, if you are a Hadoop admin, your basic job would be to manage the Hadoop infrastructure which will be deployed by a particular company, right? For example, the regular maintenance of the servers, if any storage node has to be added, if any data node has to be added. A Hadoop admin's job would be to basically maintain the cluster which is already running. And at the same time, if there's any need of adding any infrastructure, etc., that should also be handled by a Hadoop administrator, right? Then there is Hadoop architect. Now, what does a Hadoop architect do? A Hadoop architect's job is to basically solve problems using the Hadoop software. Now, what does that mean? Let's say I'm a customer and I come to your company and I say, this is the problem statement that I'm facing. For example, you would have seen in cricket, with every ball which is basically delivered, it basically gives you facts about what happened 10 years ago in this over at this particular point in time. What happened when this particular batsman, or how has this particular batsman performed in this particular stadium in the past 3 or 4 matches that he has played entire his career in that particular stadium, right? So all these kind of analysis are possible because of big data. And let's say I'm a customer who come to you and say, I'm basically from a cricket association and we want this kind of a solution for us wherein we have all the data. What we want is this data should be used to do all these kind of predictions on the go. So can you help me with that? So this conversation will basically be done with the Hadoop architect. The Hadoop architect will basically understand, okay, so these are the requirements. He will basically convert them into requirements which his team of Hadoop admins and developers can understand, and they will then go ahead and create a solution for them. Okay, so a Hadoop architect role is basically a very senior role. Then comes the Hadoop admin role. So when the Hadoop architect basically tells which kind of an infrastructure they need, what kind of nodes they need, what kind of softwares they need, the Hadoop admins go ahead and implement them, right? And the applications which basically are developed onto the Hadoop ecosystem, which work on the Hadoop software, these applications are basically then done by the then created by the Hadoop developer. Okay. So these are the three profiles. Today in this session, we are basically focusing on how to become a Hadoop developer, right? But if you were to think of which profile is more suitable to you, if you are from the admin background, if you know about Linux, if you know about clouds, then I would suggest you go to the Hadoop admin profile. If you are a person who is from the development background, who basically wants to go ahead and pursue his career in development, I would basically suggest you should go ahead and become a Hadoop developer. And if you are a person who has a lot of experience under his belt, he understands how architectures are deployed, but he still wants to shift to Hadoop to understand how architectures are deployed in Hadoop, you should go ahead and become a Hadoop architect. Right now, with this thing cleared, let's go ahead and talk about how you should become a Hadoop developer today. So guys, a Hadoop developer can play a lot of roles when he's working in a company based on what kind of company he's working for. For example, if he is working for a startup, he would be expected to do the job of a Hadoop admin and a Hadoop architect as well, and he will be paid very well for that particular job role. So that job role would basically involve planning, it will involve architecting, it will involve managing, and at the same time it will also include monitoring and support. But since the Hadoop developer job profile only will be handling so many things which most of the companies are expecting a Hadoop developer to do, they pay a very good scale for that kind of job as well. Now the average salary that we basically discussed, that will not be relevant to this kind of a job role where they expect you to do planning, architecting, managing and monitoring and support as well. You can easily expect your salary to be between 10 to 16 lakhs per annum in India. And in the US, you can expect your salary to be between $130,000 to $150,000, given you have this much skill set that you can play multiple roles inside that company. Okay, so what all do you would want to know if you want to have a successful career as a Hadoop developer? You should know planning, you should know architecting, managing, and monitoring and support. Okay, now what are the different things that you would need as a skill set when you want to become a Hadoop developer? You would not want to know about cloud such as Amazon Web Services, which is the biggest cloud provider in the world. You would want to know about a programming language such as Python so that you can do scripting more easier. You would want to know about Linux as an operating system because Hadoop primarily works on the Linux operating system and most of the other softwares in the IT industry too, right? Most of the servers that are deployed on the cloud are also based on Linux, right? And you should also be good with shell scripting, that is the Unix or Linux shell scripting. That should also be a skill set that you should be knowing. Okay, and knowing about an additional cloud provider such as Microsoft Azure would also help you in understanding how things work.
So a little bit of background history on Hadoop if you guys are interested. So Apache Nutch was a software that was created by Doug Cutting and Mike Caffarella in 2002. Then the Nutch distributed file system was established. This is essentially the first iteration of the HDFS. And then the MapReduce was established out of Nutch to be clubbed into a new project. The NFDS and the MapReduce was extracted out of the Nutch software to be put under a new project called Hadoop, and that is the Hadoop that we know today. That updated and upgraded in versions to the Hadoop, the 3.2, the latest version of Hadoop that we know today. So Yarn was introduced somewhere in between HBase, Hive, all of these components on top of Hadoop, and finally the Cloudera was incorporated, and the final release that we have in Hadoop is Apache Hadoop 3.2. So that was a little bit of background history of Hadoop, although not very relevant today, but it's important to understand the history of how certain component softwares have come to the point that they have. So what is HDFS? We discussed HDFS before, so what is HDFS in specific? HDFS is a file system designed for storing very large files with streaming data access patterns running on a cluster of commodity hardware. So the most important revelation that Hadoop brought to the scene was the usage of commodity hardware. Up until Hadoop came into the scene, what was happening was we were using these expensive servers to store big data. We were using expensive servers and processors to basically store big data and store it in distributed file systems or single file systems, running all these operations in parallel. Hadoop basically gave us the benefit of being able to use commodity hardware. Commodity hardware means regular use hardware. It could be your PC or my PC that we use personally at home or at our offices. The specifications of these computers don't need to be that high, because what HDFS essentially does is connects all of these computers that we would call nodes in parallel across the distributed file system, and all of the operations, all of the storage that is being implemented in these file systems are stored uniformly, equally across all of these nodes that are present in the cluster. So commodity hardware, basically we don't need to go out and buy very expensive server hardware for this. We can just use the clusters, the nodes that we have in the office already present, and we can store large files with it. Basically, the storage of big data problem is solved. We can process this big data using the processing components of these components of these nodes that we have across the cluster, and basically this reduces the cost a lot, helps us increase fault tolerance, and overall increase the efficiency of things, because Hadoop manages all of this in the background. We don't need to manually interfere with anything other than the configurations. So, what are the design factors? What are the advantages essentially? What was Hadoop distributed file system designed with the aim of? So, the first is high throughput, basically high efficiency, and the second is handling large data sets. Obviously, if we have large amounts of commodity hardware present inside the cluster, we can store data in a quantity that is directly proportional to the cluster size. Then we have hundreds and thousands of nodes, so we can keep adding nodes in this cluster. The more devices that come inside the organization or the workplace that we're working in, or more servers that come in, we can keep adding that. So basically, thousands of nodes can be managed and maintained in uniformity using the HDFS, and then portability across heterogeneous hardware software. So say your nodes are not of the same operating system or don't have the same hardware in them. It doesn't matter. You don't need to have compatible hardware or compatible software across the cluster. One person can have a Mac PC, the other person can have a Windows PC, and the Mac PC and the Windows PC can still be part of the same Hadoop cluster. So these are the things that the HDFS achieves, and these are the design qualities of it. Then we discuss the architecture. Firstly, we'll look at the architecture just in diagram form. Firstly, the primary two components of the HDFS are the name node and the data node. The name node is essentially, if you've studied linked lists before, the name node is the node that provides us with the addresses of the data nodes. So say if you have a large text file, it's a 3 terabyte text file. So it's divided into three 1 terabyte files to store across various nodes. So it's distributed uniformly across all the nodes present in your cluster. So what the name node contains is the information of the start of the first file and the end of the first file, and start of the second file and the end of the second file and third file, so on and so forth. So the name node contains that information. It basically points to where the data begins and where the data ends. So whenever the data is being read or whenever the data is being processed in the data nodes, from the data nodes, the name node can easily access that amount of data, whichever is required, because it has all the information stored in it regarding where the data is stored. So the client wants a write or the client wants a read. So the name node manages all of that depending on the file location in the data node. So we will be discussing an example in diagram form. What happens? What is the exact process which occurs when we are writing a data into the HDFS? So basically, what does writing a data into HDFS mean? We can look at this from a Google Drive point of view. Say you're on a Windows PC, you're uploading a file from your local system to your Google Drive. So in a similar way, you are working in a workplace which uses a Hadoop cluster. You have a local system. You want to upload something on this Hadoop cluster. So when you upload a file from your local Windows system or your local Ubuntu system to the Hadoop system, that is essentially the writing of data into the HDFS, because you are storing that data into HDFS. Rather, I would say the HDFS is automatically storing that data uniformly across its nodes. So the first step is the client requests to create a file. Obviously, you're sitting on the client end and you connect to this large Hadoop cluster. You request to create a file. The name node is connected once a block of data is accumulated. When you upload it, when you put the data through for writing inside a file, writing inside the cluster, the name node essentially communicates to the data nodes, the list of data nodes. The name node responds to the client with the list of data nodes, basically the information of where the data is stored so that the client is able to see it. The data nodes receive data after the client, the name node and the client have approved the storage of data, the writing of data. So essentially, we write the data inside the data nodes when the data nodes receive it from the HDFS client. Then the data node forwards the file to a second data node for replication and to a third. So this is where the fault tolerance aspect of it comes in. So say if it's a relatively smaller file, you don't need to divide it into various subfiles. So basically what the data node would do is create copies of that file and store it across different data nodes so that even if one data node fails, we can still access that file. So however, doesn't matter how many parts of that file have been created, all parts of that file are replicated to enhance fault tolerance of an HDFS. So then what happens is the name node commits the file creation into persistent store. It receives heartbeat and block reports. So the name node in its own information storage area, it stores the data, stores the information of the data, where it has been replicated and where the original data is. It stores all of those information, all of that information, and the name node also manages the monitoring of the health of these data nodes. So it keeps monitoring the heartbeat. So essentially, it keeps pinging them. The name node keeps pinging the data nodes to wait for a response, and the data node responds. Then that means the heartbeat is healthy. If the data node doesn't respond, then that means that the data node is not functioning. So the name node can use another neighboring data node to pick up the file if the client asks for it. So the core component, the second core component that we discussed just a while before is MapReduce. So MapReduce also acts as a core component for the Hadoop ecosystem. It is a completely a software framework, so it doesn't involve any of the node logic in it. But yes, it is coded in Java, so it is essentially used to leverage the HDFS and perform much better than traditional processing frameworks for big data analysis. So what does MapReduce do? So basically, when you have a file, a large file, it may be divided into subfiles and present and stored across various data nodes. So the mapper, when you push your programming logic inside the HDFS inside your Hadoop system, so the code is pushed into it. The mapper then starts running. Now, what the mapper does is, according to the code, it would run parallelly as an instance for every part of the file across various data nodes, so that we don't have to perform that processing sequentially, and it all happens at the same time essentially. So it speeds up the process. So when all of the processes have executed in parallel, the output is then sent into the reducer. So reducer might be a common place where all of the mapping output is sent to, and the reducer gives us the final output, and which is stored in the output file essentially. So two aspects to it: the map and the reduce. So that is why it's called the map reduce. The mapping deals with the parallel processing of data, and the reducing means the aggregation of data. The aggregation of data might also happen in parallel, and we might create multiple files for it, and those multiple files may be merged into one so that we can see it as a common file. So that is how the MapReduce component of Hadoop works. Then we discussed the advantages of Hadoop. So why do we use Hadoop in general? What benefits does it have? So why don't we use legacy systems to do this? Why don't we use traditional distributed file systems to do all of these things and just run the code parallelly on all of them? The problem of scalability, process only structured data. So legacy systems only process structured data. They are expensive, as I told you. If you're buying specifically for maintaining a cluster of distributed file systems, the server component parts, the hardware parts might be a tad bit expensive. Cannot process huge amounts of data. So since there is no software framework involved with these legacy systems, there is no efficient method to process this large amount of data. So it might not go in the most appropriate manner for possible when we execute analytic operations on these large amounts of data. So cannot process huge amounts of data. and cannot process heterogeneous data. Heterogeneous data means if the data has some sort of variety, as we discussed, that for a data to be classified as a big data, it should have variety. If the data has a lot of variety, legacy systems are not capable of handling that data. So why Hadoop? It is flexible. A major challenge for any company or organization is the handling of structured and unstructured data available in big data. Hadoop is flexible and handles structured and unstructured data efficiently. So whatever you put into Hadoop, whether it is unstructured or structured, Hadoop is able to manage it flexibly with the use of software. Hadoop can also manage encoded data. Basically depends on what the company needs. If the company is dealing with encoded data, Hadoop, inside a Hadoop framework, we can program it in such a way that we can deprocess that encoded data and take out some information out of it. Then we have scalable. Obviously, Hadoop is scalable, which means we can add as many nodes as we want and remove as many nodes as we want. We don't have to do anything complex to add the new configuration. Hadoop does it automatically for us. Once we just set up a new node inside the HDFS, Hadoop automatically detects that there is a new node and it distributes the files accordingly. It balances the weightage of files present across the various nodes inside the cluster accordingly. So we don't need to deal with that. Hadoop does it for us. That is why it's scalable. And the nodes are independent of each other. So if you're using systems present across a workplace, even if one PC goes down and one server goes down, the other servers are still functioning. The data has been replicated. So there's no loss of data and the nodes are independent of each other. So if one node goes down, that doesn't mean that any of the other nodes should go down. Fault tolerant, as we said before, we replicate data, and high speed data processing. So because the processing is running parallelly across various nodes, that means we are achieving high speed data processing and doing things much faster than we would be able to if we were doing it sequentially. So Hadoop versus RDBMS, what are the advantages of Hadoop over RDBMS for storage? If we are using traditional relational database management systems, they only contain structured data. We obviously need to add attributes to it, and that is how we can store data. Hadoop can be used for all three types of data: structured, semi-structured, and unstructured. It can be used for large data sets, while in RDBMS we cannot use it for very large data sets. It would be a lot of overhead on the server, and then Hadoop can read and write data quickly, and whereas in RDBMS we might have to implement certain methodologies to write data quickly, but we can access the data. We can only read the data as we desire. We cannot actually write as much as we want in a huge amount of time, in a small amount of time. Then we move on to the hands-on section of the tutorial. The MapReduce that we have right here, we have three components. The first is the word count. It is the driver class. We are doing a word count operation using MapReduce. We have the driver class over here. The driver class first calls the mapper. The mapper basically acts upon all the files that have been divided inside the HDFS in parallel. So it creates what we call as key value commented over here. Key value pairs. That is what the mapper creates. So basically, if you have a file which is I am a good person I. This is the content of the text file that you have. What the mapper would do is create files like create an array, create a list essentially with I, comma 1. I would map to 1. M would map to 1. A would map to 1, and so on until again we come with I would map to 1. So this is what the mapper would generate, and once this has been generated, we can see that we have two I's over here. This all could be executing in parallel. So say you have two different mapping operations that are going on, and this file had been divided like so into two parts already across different nodes on the same Hadoop cluster. So the first mapper would be operating on this, and the other mapper, which would be running in parallel, would be operating on this. So this would generate this output, the A and I, and this would generate this output. So as we can see, there is a similarity between these. There are two similar key values, which are I's. So the special logic that the MapReduce would follow is that it would send these two I's to the same reducer. So the final output that all of the reducers all of the mappers after running in parallel for at least the I key element, in the case of I, it would generate something like this. after all the mappers have executed in parallel, we now know that there have been two instances of I with the value 1 mapped to them, as you can see here. The int writable for the key is 1, so every time 1 has been mapped whenever a key is occurring. So this would be sent to one reducer instance. So essentially I'll copy this from over here and paste it over here so you guys can have a reference. So it has been sent to the reducer now. So this is what the reducer gets as an input, one reducer instance. So here we can see we're initializing the word count with 0. So initially the word count for I is 0, and while there are new values in this list, values has next, so it will keep incrementing it with values.get. The values.get would give us 1, and it could give us anything, but in this case, since we are only writing 1 inside the mapper, it is giving us 1. So we would get that, and once this has finished executing, the final value that word count would have after the loop has ended is 2. Since there are two occurrences of 1, so it would add 1 and 1, and we would get 2, and when it would reach the final position on this list, and when it would check what has next, it would give us null, so the loop would exit control, and we would finally do the output for collect. That's just the word count. For the key I, we would get the word count, which is 2. So the final output would contain I. So this is how basically the reducer works. So from that example, we know that things can happen really fast if all the mappers are executing in parallel and all the mappers are independent of each other in their processing. So they don't need to communicate with each other before performing their respective tasks. It is only in the end where their works are being aggregated by the reducer. So that is where the sequence sort of matters. While the mappers are executing in parallel, any of the parts of the text file can execute first. It wouldn't matter the final output. So once this has been executed, I'll simply create a jar file out of this and show you how easy it is to run MapReduce operations in big data analytics. Simply create a new file called word count yt.jar and paste it over here. Finish. I haven't saved one file. Save it before we execute. I've saved it. So export jar word count. Finish. Yes, there's already a file that exists on desktop, word count yt. I'll replace that and click finish. Once we've finished, we already know that there's a word count yt.jar. So before we begin, we have to create a directory to store our source document inside the input document. We write Hadoop FS mkdir. We create a directory and call it input ytt. Let's enter and create a new directory. Not create a new directory, actually we'll upload the file from our Linux system to the Hadoop server. Put Shakespeare.txt. This is a text file that is present in my home directory, by the way, don't be confused by that. And we'll simply, let's not type this, I'll just copy the input directory that I just created and paste it over here. Once we have done that, we can be sure that our file has been uploaded inside the Hadoop server. Now we will simply run the Hadoop jar operation that we have on the new file that we just created, which would be under home training desktop. As you can see, it's on the desktop, word count yt, and the file name, which is word count yt.jar, and we would use the class name, which is word count, the driver class name, the main class name basically, and then we would use the input directory for our file where we've stored our Shakespeare.txt. We'll copy that and paste it over here, and then we would create a new output directory to store our output into. So we use the training, and we would call this output ytt, and we'll press enter. As you can see, the job has started, the MapReduce job, and it will take some time before it executes. basically counting every word that is present inside that data set. The first, the mapper has successfully executed, and the reducer has executed as well. We will now check the output Hadoop FS and use CAT for that. We will use the output directory that we just created for this. And paste it over here. We'll add part 5 zeros. And this would be the traditional naming system that Hadoop uses to inside the HDFS to create output files. So Shakespeare.txt is a smaller file, smaller data set, so it generally generates only one part file. So we don't need to concern ourselves with the other ones. So we'll basically look at this. And here we have our word count, basically count of every word present inside the Shakespeare.txt. That is a little bit of hands-on how MapReduce works and how easy it is to use Hadoop, and that is about it in the hands-on. So basically what you need to gather from this is you can write simple Java code as long as you're importing Hadoop libraries inside. You can perform those simple Java operations on very large data sets as well without having to learn any newer technologies or whatnot. So that is the one of the biggest advantages of becoming a big data developer, understanding big data, because the possibilities are endless, and once you have access to a big cluster, you can execute that same sort of logic using the same methodologies as you would use for smaller data sets. So if you're intimidated by the phrase big data, you shouldn't be, because it is basically same coding logic. You just need to implement it inside a Hadoop cluster. So now that the hands-on is done, we can now discuss about the other elements that run on top of Hadoop or alongside Hadoop, the components that we can use that complement Hadoop, basically the Hadoop ecosystem. We have a figure for it. So up until now, we discussed what the HDFS is and what MapReduce is. So MapReduce essentially deals with the processing aspect of Hadoop, and HDFS deals with the storage aspect. So one step by step, we will now be discussing everything that is present inside the Hadoop system. First, we have Yarn. Yarn is resource management. So how does Hadoop operate? How are jobs allocated inside Hadoop? As you just now saw, I executed a MapReduce job. So how are those jobs allocated efficiently across various nodes present inside a Hadoop cluster? So we use Yarn for that. So what Yarn does is it assigns jobs to the various nodes present inside your Hadoop cluster in a manner efficient enough that there is no imbalance created anywhere. So basically, a resource management system. We have Hive. Hive is a data warehouse software. Basically, it's a warehousing tool. It is used to take the larger data set present inside a Hadoop file system, and we can basically warehouse it and view it according to however we need it to view. So, what is Spark essentially? Spark is a computational engine which is 100 times faster than Hadoop. It uses Hadoop as the storage unit. So basically, all the files that Spark picks, all the is stored inside the HDFS. But it doesn't use the MapReduce implementation that Hadoop has. Spark uses own computational engine. It processes the data, and it could use libraries like mlib to further create models, machine learning models out of that data. Spark works with Python and Scala, so these are the two languages you can use to basically take advantage of Spark. Then you have Pig. Pig is used for processing large amounts of log files. So log files fulfill the criteria of big data because they are continuously generated. They are of extreme sizes when we are talking about large websites, large commercial organizations. A huge amount of log is created in those entities. Then we have HBase. HBase is a NoSQL database. So with your storage place set in the HDFS, the database set in the HDFS, if it is a NoSQL format database, you can basically query it with HBase, And then we have Zookeeper, and Zookeeper is basically used to coordinate the various nodes that we have present across the various present across the cluster essentially, and it is used to coordinate all of those nodes to perform a single task or multiple tasks, basically scheduling the tasks. That's what Zookeeper does, management and coordination. We've already discussed Spark. Kafka is used to attain data in a real-time environment, creates a pipeline between system and applications to ensure a fluent flow of data between the system and application in real time. Then we have something like Uzi, which is used for scheduling inside a cluster. It's used to schedule jobs just as well as Zookeeper. Then at the bottom we can see something like Flume and Scoop. What Flume does is it takes real-time data from websites and it transfers it and stores it inside the HDFS. As you can see, there are a lot of logos near Flume, like Facebook and WhatsApp, and the unstructured and semi-structured data that is generated from these websites that is accessible by Flume, that is publicly accessible or accessible within an organization. It takes that data and puts it into the HDFS so that we can further process it using Hive, any of the tools that we have on top of the Hadoop architecture. On the right hand side, we have Scoop. So if you want to transfer data to and fro between a traditional relational database management system and the Hadoop distributed file system, if you want to transfer data in between those two entities, you can use Scoop for that. So it acts as a bridge for transfer of databases between the two.
How does MapReduce really work? Okay guys, so it's a very simple concept. Books, a lot of people around, when you read a lot of blogs, would try to complicate it. Well, it's important to complicate because that's how people make money, right? So it's very simple. So just focus on the example, focus on the story, and we are done. Just focus on the story and MapReduce will be done. It is one of the simplest things that you would have heard or you would be learning today. People would make big things about MapReduce, but it is that simple. So just focus on the example, my friends, and we are done. Just focus on the example. Focus. Tighten your seatbelts and focus. MapReduce is processing, but if I was a student, I would ask one thing to myself. What nonsense. Blocks are broken. Data is individually getting processed, but somewhere it has to consolidate, right? How will that work? Who will do that? That is where you have to understand the concept of MapReduce. That somewhere data is broken, but boss, somebody has to consolidate. How will that work? And that's what we are going to see right now. So it's going to be very simple. Just pay attention, it will be done. Okay. All I need is your attention for next 25-30 minutes and we are done with this topic. So let's say we have 4 guys. We have 4 guys. Ajay, Abhay, Amit, Abu. So these are 4 friends who work for an organization. Ajay, Abhay, Amit and Abul, 4 guys are there who work for this organization, and their manager has told them that for next 1 year they are supposed to work on every Saturday and submit a report. Oh man, this is bad for them, right? So 4 guys, Ajay, Abhay, Amit and Abul, 4 guys. These 4 guys are supposed to be in office for the next 1 year. Every Saturday they are supposed to come and they are supposed to do some job, whatever, some report they have to generate, some XYZ report we don't care about, but they have to come to office. Now Saturday is a weekend and you don't want everybody to waste the weekend. So these 4 friends, Ajay, Abhay, Amit and Abul, what they do is they say that let's have a small deal that let's come at 8 o'clock in the morning, let's work till 10 o'clock. Let's work from 8 o'clock to 10 o'clock, and 10 o'clock one guy will stay back and consolidate the whole thing. One guy will stay back and consolidate the whole thing so that not everybody is wasting the whole weekend, right? I mean, we'll come for 2 hours and then every week we will take turns. Like week 1 Ajay will stay back, week 2 Abhay will stay back, week 3 Amit will stay back, week 4 Abul will stay back. So that's fine. Let's do that. So it is this Saturday Early morning 8 o'clock, Ajay, Abhay, Amit and Abul, all four are in office, and from 8 o'clock they start working. 8, 9, 10, everybody is done with their work. 8, 9, 10, 10 o'clock everybody is done with his work, and this week Amit is supposed to stay back. This week Amit is supposed to stay back. Okay. So all of them will hand over work to Amit. Amit will consolidate and give the output. My friends, this is MapReduce. Nothing big. MapReduce is so very near real to what our life looks like, how consolidation looks like. 8 o'clock to 10 o'clock, when people are minding their own business, that phase is called as map phase. Whenever you hear map, that means mind your business. That means you are not looking at the left how many people are there, you're not looking at right how many people are there. You are just doing your job. That is map. At 10 o'clock, everybody is done with the work. And when you push everything to Amit, that is called shuffle. And Amit will consolidate everything. Don't worry how that works. That is sort. And finally, Amit will do the whole thing. We will see what is sort, and that is called reduce. So my friends, all I want you to remember one thing about MapReduce is, MapReduce people will make it very, very tough, but it is divide and conquer. All you should know is map means divide, reduce means conquer. Map, divide, reduce, conquer. Map, divide, reduce, conquer. Okay. All right. Let's take one more example and we will really simplify it. Okay. Let's take one example. So I want a number of students from each country. Okay. Now let's say all student details are in a file of 189 MB. That's fine. I don't know the size. You also don't know the size. Let's have it 189. So I'm putting 189. You're free to choose your number. That's fine. One thing is sure that with 189 MB, there'll be 2 HDFS blocks. How many blocks? 2 HDFS blocks. 128 MB and 61 MB. Now in map phase, we will have 2 mappers. How many mappers? 2 mappers. Now the way map works is, it will take one student at a time and basically process it. I'm supposed to find students by country. So the mapper output will look like some students will be here, some students will be here. Because mapper will take one record at a time and process it and give the output. So our mind your business phase is over, where 2 blocks were minding their business without knowing what is happening on the other machine. They were only interested in what is happening on their machine. They were looking at one record at a time. That's how mapper is coded. Okay, life is good. After this is done, there is a reduce machine and everything should go here. So the act of throwing data here, oh, this is called shuffle. But my friends, before reduce can start, we need to create something called as groups or bags. And here there will be 5 groups created. Let's see how the groups will look like. China, C, D, okay, so it will be India, Malaysia, RST. Sorry, I'm not good at ABCD. This phase of creating bags is called as sort. And finally, reducer will take one bag at a time and say China 30, India 30, Malaysia 20, Singapore 10, Thailand 10. This is MapReduce for you. Simple stuff. Divide and conquer. Divide and conquer. Divide and conquer. Simple stuff. Now, it's possible that it may still appear to be, no man, it's pretty complicated. Well, you have been doing MapReduce since the very beginning of your career. Let's look at this. Now, the previous example that I saw, can I say this was nothing but select country, comma, count of star from students table, group by country. If you really see there were 3 students or there were 100 students, how will it go through? The RDBMS will find a way to go through each and every record. Okay, so eventually there is loop where scans each and every record. Then if the bag is created, if the group is created, insert in the group, else create the group. Don't worry, it's simple. And finally, for each group, perform count. Is not created. Think of it this way now. Even RDBMS will go through each and every record. Now, let's say first it finds India. First it finds India. Is India group created? No. Sorry. If the group is created, insert, create the group and insert it. Okay. So scan each and every record. If the group is created, insert in the group, else create the group and insert it. So let's see how it looks like now. First it looks at India. Is India group created? No. So create a group and insert within India. Okay. So like this it will insert, finally have India, China and all. So the bags will eventually look like, here each and every record is scanned, and here the bags will look like, the groups will look like China, India, and finally here for each bag you will say China 30, India 30, blah blah blah. Now let's phase it out. Going through each and every record, it's called map phase. Going through each and every record, it's called map phase. Putting everything in group, creating bags, it's shuffle and sort. And finally, performing the count or performing the aggregation. Reducer. This is MapReduce for you. It is that simple. It is that simple. So if you're clear with this, we are done with MapReduce. There are two more small details which I will add, and we will be looking at the code, but that's MapReduce for you. So just two more small things here, and we will. So MapReduce, everything is clear. Only problem is, man, that this diagram somehow has serious limitation that all the data should go to the same reducer. What if that reducer does not have enough storage? Then we are in deep trouble. Then we are in a serious trouble. See, this diagram is excellent diagram, but with a limitation that all the data should go to the same reducer. Man, if in big data, if you're talking of a diagram like this, there are thousands of machines running, everything going to one reducer, everything will be dead, correct? So the point is, by default, the number of reducers in MapReduce program is 1, and you can change it, but you can change it. So if I wanted to have a load balancing, I could go for should go for 2 reducers. But then if there are 2 reducers, my whole thing goes in a mess. Why it's a mess? How will I know what should go where? How will I know what should go where? And that is where a component just below the mapper is running, and that's called partitioner. Partitioner will decide which data should go where. So partitioner will ensure some data goes here and some data goes here. How it will decide, we'll see. So relax out. So partitioner may decide that, okay, China and India will go to reducer 1 and remaining 3 will go to reducer 2. Okay. And then here we will get China 30, India 30. And here I'll get Malaysia 20. Sorry. This auto suggest can really ruin your relationships. Singapore is 10, so it's 3080, yeah, and Thailand is 10. And then the developer can easily just run a merge command, which will just merge these 2 files, but the files are complete right now. So that is possible because of partitioner. Partitioner is the guy who load balances, but on what formula? Let's understand that. Partitioner uses a generic formula which says key dot hash code. Now hash code is, just don't worry, it's some integer. It is generated by JVM, Java Virtual Machine. So key dot hash code divide by, or modulo, not divide by, modulo number of reducers. Key dot hash code modulo number of reducers. So think of it this way. Let's say India dot hash code. Let's say it's not in my hand, it's not in your hand, so let's put any number. Let's say 80. China dot hash code 86. Malaysia dot hash code 71. Singapore dot hash code again 71. Who knows? Nobody knows, right? So neither am I in a position to tell what it is, and neither are you in a position. Thailand 79. So if you see, modulo 2 is 0, modulo 2 is 0, modulo 2, because the number of reducers are 2, modulo 2 is 1, modulo 2 is 1. That's how it gets decided who will go where. That's what is done by hash code partitioner. So partitioner by default works this way, and it is a guy who will basically load balance the whole thing. It will simply load balance the whole thing. It is as simple as that. Now, neither do you know hash code, neither do I know hash code. If everybody was having an even number, then everything would have gone to one reducer. That would have been a problem. Okay, so that's where a developer can come in and he can change this logic. He can write Java code to change this logic and say that, oh, I don't like this partitioner, I would like to have a different partitioner. So a developer can do that also. A developer can do that also. Okay. All right. So this is partitioner. Now there is one more last topic, combiner. Okay, let's do one more topic quickly, small topic. Load that. So partitioner is basically a load balancer. Let's do one small thing. Now, what comes out of mapper? So what comes out of mapper is India 1, China 1, Malaysia 1 and all that, and we are consolidating China and India. Why can't we do something like this? That we add everything up and we directly send India 22, China 22, Malaysia 6, Singapore 6, Thailand 6, let's say. And here itself we consolidate India to be 8, China 8, we know India, Malaysia 14, Singapore 6, and Thailand 4, Singapore 4. Now, instead of China and India like this, with combiner, we will get China 22,8, India 22,8, and here we'll get Malaysia to be 6,4, sorry, 6,14, 6,4, 6,4, and we get the consolidation. This is done by one guy sitting before the partitioner called as combiner. So that is combiner and partitioner. So that is combiner and partitioner. So now this kind of consolidates the entire MapReduce for us. We understand map, that is one record at a time. Then we understand partitioner, which is load balancer. But before load balancing, if we want to combine something, we can run a combiner, and then we do the reduce part. Okay. So let's understand, guys, carefully. As a programmer, how do I predict my number of reducers? Now, actually, there are no royal ways, but there will be a couple of tips out here. So let's understand. Okay. And in 30 seconds, I'll put the answer and check if your answer is confirming. Answer should be 12 reducers. Why you should go for 12 reducers? Because here your use case is very clearly telling you that, listen, for Bank of America 2016, I want monthly revenue where I would like to have 12 output files, each file having 1 month's data. That means your use case is very, very clearly telling you how many reducers are required. In a year, you cannot have 13 months at all. That's not possible. So for most use cases, this is what will be the pattern. Now some cases, when we don't know, like say word count, there is no classification, well, then it's trial and error. Okay, so, and here knowledge of data will also be required. There is absolutely no magic on this one. It's trial, error, and okay, so that's the answer. Unfortunately, if your use case does not tell you what is required, then you are in trouble. Not trouble, but yeah, you will have to do trial and error, and there is no royal way for it, because that will also need a lot of understanding of your data. Okay, okay, what kind of data it is, probably what kind of bifurcation we are looking at. You will have to do multiple runs to really settle down on a number that looks good for you, and there is no other way, because if your nature of the data changes, you are back to square one, but that's how it is going to be. So for example, in one of the places, right, what we really do is, let's say we do number of reducers to be 72. Now we just add, okay, this is the amount of RAM we have, and did some calculations that this is the RAM we have. Probably each reducer will take 1 GB RAM. Based on that, we choose, okay, let's have 144 GB RAM is there. Let's have 72 reducers for all the jobs where we don't know what it is. But that's always going to be changing. So there is no one royal way where I can say, no, this is how it has to be. But when your use case is perfect, like it clearly tells you, your manager comes and says, listen, I want monthly revenue of BOA for 2016. And even if he tells you that, you kind of know that, okay, man, I can bifurcate by month and maybe have 12 reducers. That's the idea. Okay. Okay, guys. So now here we come to MapReduce, and let's understand this. So this is, okay, guys. So this is like the final diagram of the day. So let's take up this diagram, and this will complete our MapReduce explanation. Okay, guys. So first, I submit my job data, which is 640 MB. That means there are 5 blocks. When I submit my job, automatically my number of mappers, because the blocks are 5, will typically be 5, and I can specify number of reducers. And let's say the number of reducers is, let's say it is 2. It is 2. So I submit my job. Number of mappers will be 5 because the blocks are 5, and number of reducer as a developer, I said I want 2. When I submit this job, AppMaster starts the job, and AppMaster tells so number of mappers is 5 and number of reducers is 2. When I submit my job, the AppMaster tells the yarn master that, listen, I will first start with the map phase, so please give me 5 resources. 5 resources. And now I am replacing this word resources with containers. It's called containers. So AppMaster says, hello, I will first do mapper phase. Give me 5 containers. Resource manager says, go take them, man. Take 5, go enjoy. Now, after the map phase is completing, the AppMaster will go and say, hello, I need 2 containers for reducers, and you can give me on any machine, because anyways there will be some traffic. So resource manager says, of course, take your container for reducer. So let's say one reducer will run here, other will run here. And after map is done, all the data is coming from all the machines. This is shuffle phase. And now the reducer will run, and it will generate 2 output files. Output 1, output 2. Which you can merge later. So now let's first understand how these labs are set up, how we will practice everything, and then we will basically go through the whole walkthrough. So let's jump onto it right now. Now before we jump into any of the labs, let's first understand the setup. Now I'm sure most of you will at base have a Windows laptop or a MacBook. Okay. Most of you will have. Okay, from your LMS, so Intellipaat's learning management system, you will download something called as a virtual machine. So now what happens is, there is this virtual machine which will run on top of your Windows operating system, and this is running an OS called as CentOS. Okay. So that's where CentOS is running. When you say Hadoop is already installed, following services are already running on your virtual machine. So even without, let's say, in case you've not gone deep into it, but these are 5 services which are already running on your machine. So the first service is running as name node, then you have data node, then you have secondary name node, then you have resource manager, then you have node manager, and then you have job history server. These are the 6 services that are running on your virtual machine. Okay. Now your setup is done. Windows, Mac, CentOS, Hadoop is installed. Life is good. Then you came for a theory. We did so much theory. Now it's time to practice 2 things. First thing is we should practice some HDFS commands. Okay. And second thing we will practice is MapReduce commands or MapReduce programs. So when you leave for the day today, you would be very clear that, oh, I have a virtual machine and Hadoop is properly installed. Yes, that was done. And today you practiced or basically you would see how to do it, HDFS and MapReduce. And then you can basically take your time to do that as an assignment. My Linux box that CentOS Hadoop that you've got, it actually has 2 file systems. CentOS will have something called as Unix file system, and Hadoop will have a file system called as HDFS. So hope everybody is clear that Unix is different file system, HDFS is different file system. Today when we practice HDFS, we will be dealing with Hadoop file system. Okay. So this is the setup. This slide will be important to you. I'm sure everybody knows what is name node, but I'm just reiterating this so that this slide stays with you. Name node is master for storage. Data node is slave for storage. Secondary is backup of name node. So this we've covered in detail. Okay. Resource manager is master for yarn. Okay. Node manager, he is slave for yarn. But now there is a problem. Problem is, let's go to this diagram. That yarn, that is resource manager, has to maintain multiple frameworks like MapReduce, Spark, and so on and so forth. That's why resource manager says, I will maintain your job only till it is running. After the job is done, forget about it. Find a way to archive the status of the job. What I'm saying is, oh, you ran a job on Friday, today is Saturday. You want to see how much time that job took. Resource manager says, listen, it's not my job to archive that information. Okay, because I, as a resource manager, has to handle MapReduce, Spark, and so many other things. So for archiving the MapReduce job status, okay, there is this service called as, the name itself is very self-explanatory, job history server. Okay, think of it this way. It is status archival for MapReduce job. What I'm trying to say is, as soon as your MapReduce job is done, resource manager says, okay, bye-bye, I got your output, see you, and I'll forget the status. And that gets archived in job history server. So it's like an archival service. Think of it that way. Okay, dude, how do I believe a trainer that services are working or not? I should be able to see it in real world also, right? What services are running or not. Well, there is an interesting utility, and I will paste the command because it's an interesting thing. So there's a short command called as JPS, Java process status. It will tell you all the Java processes that are running in your cluster. Okay, so this is my cluster. And yes, trainer says Hadoop is installed, but how do I verify that? Let's do that with that particular command. It's an interesting command. So the command is sudo user java latest bin jps. So basically we are running a command called JPS. JPS full form is Java Process Status. This is our way of questioning. Listen, Mr. Cluster, can you tell me which Java processes are running? So our cluster is kind enough to say that OS name node is running, OS data node is running, OS secondary name node is running, OS resource manager is running, node manager is running, and the job history server is running. Okay, and I will paste this command in Evernote. Okay, so won't be able to paste, so I'll just type it. Sudo user java latest bin jps. And by the way, this command is not married to Hadoop. This command is married to Java. That means on your server, if any other Java process is running, I mean, take an example. Okay, let's give an example. Let's say on your laptop, in that cluster, let's say Lotus Notes is also installed. Lotus Notes is an IBM product which runs on Java. You will see Lotus process is also running. So this command is not married to Hadoop. This is married to Java. Okay, Java process status, JPS. Okay, so that's a command. With that, now let's move on to our thing. So first thing is, our first agenda is, hey dude, I want to practice HDFS. So the first thing trainer keeps on talking about HDFS is that Linux file system and HDFS file system are different. How do you prove that? Okay, let's run a small command. lsltr/, or let's simplify it more, lsltr tmp. So this is my temporary directory, and I see some files keyring, jetty, virtual training, something, which is fine. Now I'm again running the same command. Okay, in front of you I'm just running the same command, but this time I'm saying Hadoop fs ls tmp. So here I was seeing tmp, here also I'm seeing tmp, but God, the content I see is different. When I see tmp for Hadoop, I see Hadoop yarn, but when I see tmp in Linux file system, I see so many other things. The reason is Linux file system is different, Hadoop file system is different. When you just run a Linux command, this is Linux command, and if you want to run a Hadoop command, you can always run it as Hadoop fs ls or HDFS DFS ls. Okay, so the idea is that this prefix will decide whether it's a Linux command or Hadoop command. This prefix will decide whether it's a Linux command and Hadoop command. So first thing is amazingly verified that yes boss, this thing is clear that they are two different file systems. How did I verify? On Linux I'm saying temp, I see something else, and when I say Hadoop fs ls temp, I am seeing something else. That means they are two different file systems. So that's good. So our hands-on has to be done on what do you call HDFS. Now the common pattern for Hadoop commands is Hadoop fs hyphen your Linux command. So most Linux commands will work like that. Hadoop fs hyphen and put the Linux command. Okay, so if Hadoop fs is not there, this is Linux command. If Hadoop fs is there, this is HDFS command. Okay, now there is one exception to this rule, and that is that we cannot do vi, that is we cannot edit a file in Hadoop. In Hadoop file system, once you write the data, the file cannot be updated. It's more like from a warehousing perspective, they never let you update. I mean, warehouses do let you update data, that's fine, but Hadoop file system will not let you update the data, So Hadoop is also called as worm. Write once, read many. Hadoop is worm. Write once, read many. That's simple as that. Okay. The second variation to this is in Linux, there is an amazing command called as cd. So I can say my pwd and I can say, let's say, cd workspace. And when I do my pwd, my present working directory changes. But my friends, in Hadoop, there is no cd command. That means, let's look at a simple example. I say Hadoop FS ls temp. Now I am tempted to say that Hadoop FS cd temp Hadoop yarn, and the cd command is not there. That means you are always supposed to give the full path and your present working directory is always, carefully look at it. If I say Hadoop FSLS, it's showing my present working directory, and that is nothing but same as user training. Aggregation, output, input, same thing. Aggregation, output, input. So what I'm trying to say about HDFS is very important. Let me note it down for you here. For most part, HDFS commands are very close to Linux commands. So there is no special practice required for you. When we run MapReduce program, you will end up practicing them. Okay. So if I just say Linux command, this runs on Unix file system. And if I say Hadoop FS Linux command, this will run on HDFS. So we are clear with this. Now, two important points for HDFS before we move to this thing. Two important points. You cannot update a file in HDFS. That is, HDFS is worm. Remember this word because this will save you a lot of trouble. Read many. Second, there is no cd command. You will always be at user, that is, in this case it's training, and for everything else please use the full path. So that brings us to the end of HDFS. Now you can just play with this. So let's quickly play with a couple of this. Hadoop FS mkdir. Okay, so I'm creating a new directory called as Apple. So what I see is Hadoop FS ls. I see a new directory called as Apple. Now Apple is a directory created in Hadoop file system. How do I put some data into it? Let's take a simple example. So in my Linux file system, I have a file called as, let's say, test.txt. So I'll say Hadoop FS put test.txt in Apple in HDFS. Wow, it goes. How do we see it? Hadoop FS ls, and we see a file text.txt. So two major commands to remember. One is put, okay, and other is get. Now if I want to get this test.txt dot outside, then I should use command called get. So get and put are two major commands. I can delete this file also. Hadoop FS rm-r apple / test.txt. Okay, so these are some of the commands. Now you will have lot of practice on it. See, by the time you complete this whole training, you will be a champion at these commands, because every hands-on that you do, you will have to use these commands. Okay, so that kind of brings us to the end of explanation of HDFS and how to play with it. We move to our next important topic, which is MapReduce. In our hands-on, we are going to look at a couple of things. So how to write a basic program and how to run it. how to basically, let's say, aggregate data, how to perform some kind of joins, and so on, so forth, so on, so forth. Now, before that, let's kind of understand the architecture of how you deploy them so that we are very, very clear with this. So pay attention. Yeah. So let's go ahead and do everything. Okay. So that the flow remains. So let's first talk of the same diagram here. Oh, I have Mac. Okay. I have CentOS. It has Unix file system. I have Hadoop file system. We already saw HDFS commands. Now it's time to run MapReduce. So let's first understand the deployment architecture. So on my CentOS, I will write this great code which is called MapReduce code. And oh, that code is written in Java. So I have code that. Good. When I submit this code, okay, it will get registered with the resource manager. So I'll be able to see on resource manager that. So leave the code part. Let's first understand the deployment. You write code on your CentOS machine. Write it. After you write it, when you submit, it goes to resource manager. Resource manager internally will call app master and say, okay, boss, do the job. App master will do the job. And after the job is done, the job will be archived at job history server. So don't worry about code. Don't worry about MapReduce program. First, let's worry about the deployment part so that we are clear with what is the flow. Writing code is easier part. Understanding the flow is pretty important. So without worrying about what I'm doing, let's submit one MapReduce program first. We will understand the deployment architecture. So we'll go step by step. Right now, you have to look at from a perspective that how will it get deployed on the cluster. Okay. So first, in HDFS, I have created a directory called word count input. I will first delete it in front of you. HDFS DFS ls or Hadoop FSLS, whatever you want to run. So there is a folder called input and there is a folder called output and apple and aggregation and aggregation out. I will delete everything in front of you so that we are very, very clear. HDFS DFS rm-r user training star. So please delete everything that is there. So it has deleted. So right now my user training directory is completely empty. And now look at it from a perspective of how it is deploying on the cluster. Don't worry about the code. We have whole day to look at the code and that's an easy part. Okay. So let's first create some sample data. So I'll say vi, okay, Intellipaat.txt. I'll say Intellipaat is one of the very first companies who got into big data. So I've actually created multiple lines, okay, who got into big data. So they have a big data COE. They are good at big data. They are very good at big data. Let's just say I'm putting something. The idea is that just mark your words that I have used big and data 4 times. So that means big is 4 times and data is 4 times. Okay, because we will run some kind of word count job. So this is my input data. You are free to put whatever you want. So this is in my Linux box. I want to put that into my Hadoop. So first what I'll do is HDFS DFS mkdir and I will create a folder which will be called as input. So I'm creating a folder called as input. Life is good. Then I say HDFS DFS. You can use HDFS DFS or Hadoop FS. Don't worry about it. It's the same command only. Okay. So call it biscuits or cookies. They are same only. Okay, so HDFS DFS put Intellipaat.txt in my input directory. So life is good. HDFS DFS ls input. So what I see is a file called as Intellipaat.txt. Okay. So now input is there. It's time to just run a code. So this is some ready-made code, word count.jar. I have written it for you. It's ready. Just leave it. It's fine. Right now we are not interested in how to write code. Hadoop jar word count.jar. The input folder I created is input, and the output that I will get is output. But right now my perspective is how does it get deployed on cluster. So we will see both of it. First, I will go to localhost and I will go to 8088. So this is my resource manager UI. Right now I have not submitted any job. This is simple. And this is my job history server. Okay, so let's just say, so this is my job history server. Okay, it's connecting. It's fine, it will come up. Okay, so right now my job history server, this was my previous runs which are there. This is 0 applications. Resource manager has no applications. Now pay attention. I'm saying Hadoop jar word count.jar input output, and I say bang. Once I say bang, you see the job has got submitted and it has got accepted. We don't know the status because resource manager has just got it. Click on that and you see the job is still running. It is not complete. It is running. Let it run. It's doing something. We are seeing that. Let it run. But pay attention to the screen right now. Okay, there is a tracking URL which is application master. 24 seconds. Job is running, it is doing word count, that's easy. But look at it, the tracking URL changed to what? History. And it takes you to the job history server. It is taking you to the job history server. You can actually refresh it from here itself and you will see that the job will get registered here. So the job was submitted, it ran successfully, and it will appear in the history. Okay, so this is the job that I ran in front of you. Now this job, okay, this is where I will see the time and everything. So this job ran, it would run certain mappers, certain reducers. This job ran one mapper, one reducer. I can see the logs for mapper and I can see logs for reducer. Okay, so now just to understand the flow, we will first reiterate the diagram again. So this is my task. I can see my logs and everything in that. So the UI is there, click on logs and you will see logs. And that's how you understand the flow of how the job is getting submitted. We will come to the code. It's important to understand the flow. So my job has run successfully. I say HDFS DFS ls. I see output directory. Life is good. Within output, I see two files, success and part R00. You know why success is required? Success is a 0-byte file which is a flag. See, in enterprise you use tools like Control M, Autosys, or your own automation. If you're using an automated tool, how will automated tool come to know whether this job was successful or not? It looks for a file called as success. So this is like a flag whether this job was successful or not. And this part R00 is your output file. So there was one reducer, so it came up with one file. HDFS DFS cat. And I say paste. And carefully look at it. Data is 4 times and big is 4 times. So that's my output. So I have successfully run my job. Yes, we have not got into the code. We have time for that. Right now, it's important to understand the logic of deployment. I wrote my MapReduce code. It was bundled as a jar file. So for guys who are not, from Java background, just to give you information, jar file is nothing but think of it like an exe file for Java. Just think of it that way. this jar file was submitted to resource manager, and resource manager showed you on a URL which was port 8088, and resource manager tells you, hey boss, yes, job is submitted and I'm running it. It's running, it's fine. After the job is done, resource manager says my job is over, and the job history server has the status. That is how your flow will work. So you code, you deploy, and you see the status. You see the status. That's how it works. Okay. Now it's time. Now the next question that will be asked is, hey man, how do I write my code, and how do I bundle my code? So two questions now which are pending to be answered now is, how do I write my code? That's the next question we'll take up. And how do I bundle my code? Simple stuff. So these are two important questions to be answered. Once we answer these two, we will see some more programs on MapReduce. That will be the agenda. So now I'm going to talk about a problem as to how do I write my code and how do I bundle my code. Think of MapReduce program as three different Java classes. So I'll map this in the code, okay? So the first class, the main class, is called as driver. So that's your ignition point. Think of it like the place where in the car you insert the key. That's where you drive the whole engine. The second file is mapper, that talks about what should be done with each record. And then there is third file, which is reducer, which says what should be done with each group or bucket. So for example, the student's example, what should be done with each student, and here what should be done with China, let's say 11111, the whole bucket. So the driver you initialize, driver will call the mapper will write its output, automatically framework will take care of shuffle and sort, then the driver will call the reducer and you will get your output. So as a developer, you are supposed to code three things. You will code the driver, you will code the mapper, and you will code the reducer. How shuffle sort works, that's something you will not code, because that's what framework will take care. It is as simple as that. Now if you have this diagram in mind, I will map this to the code. And it is that simple. Every MapReduce program, my friends, that you use will have these three classes: mapper, reducer, and driver. So don't worry about it. It is dead simple. You just have to relax out. There are three things to know. What should I put in driver? In driver, you will put a very simple thing. Oh, who's my mapper? Who's my reducer? What is the input data format, output data format? In mapper, you will write the logic saying what should I do with one record at a time. And in reducer, you will write the logic which will say what you should do with one group at a time. Okay. Now, if this is the logic, there you will see a lot of things in the code right now. With that, today what we will do is I will show you 4 code samples. How many code samples? 4 MapReduce programs. In every MapReduce program, you'll have a driver, you'll have a mapper, and you'll have a reducer. Now you can also have advanced things like chaining, where you say that driver can have 2 different mappers, and then they will call the reducer. All these complex workflows are possible. Okay, so it's like you can go on making it more and more complicated. But the good practice is keep it simple by having multiple MapReduce programs and call them as a workflow. So what I'm trying to say is, can I code like mapper, then reducer, then let's say one more reducer, for example? Yes, you can. But a good practice will be MapReduce, and then chain them as a workflow. That will make your code very, very maintainable. Okay. So let's today we will look at 4 examples. So now we've understood how this works. We will now jump into the code. First thing we'll talk about is how to write a word count program. Okay, what we just did now. We will look at one more example, which is how to aggregate. Same thing, like word count is aggregation, this is also aggregation. We will then see how to do joins. So there'll be two type of joins we will see: joins in mapper and joins in reducer. These are the 4 code samples we will see. So let's go ahead and do that. Now it's time to basically look at one piece of code. Okay. So on LMS, let's say everything is available, you can download. Now just help me out. From LMS at download, there are, what you call Hadoop code files. So there is writing MapReduce program, multiple input format, joining, how to aggregate data. These are some of the files. So I get word count, and my code is in source. That's Java code. Let's talk of code. I open in gedit, and the first thing you say is, no man, how will I in real world write it in Notepad? So you should not. You should actually use a tool called as Eclipse. So why don't we directly look at it in Eclipse? All you need to do is open your what you call this thing. So let's start from a fresh slate. So I open Eclipse. Eclipse is saying me that, Mr. Ravi, I will look for your code. I will look for your code in home training workspace. So you better have your code there, because that's where I'll point to. I go to my home training and workspace, and I realize that there is nothing. There is some file called intellipaat.txt. Let's get away from that also. So Eclipse is saying that, dude, I am expecting your code or new projects will be created at workspace. And in the background, I see workspace is completely empty. So we are starting with 0. Okay. I go to workspace. Okay. So how do I create a project right now? So one way is I can directly create a project from here, and I can, build a file. I can do that also. Or I can take this project that we've got, okay, and take this word count project. So I'm just taking this and putting it inside workspace. Okay, so there are some additional files, ignore them right now. Okay, and I will simply say that I would want to create a new Java project. It says, where is the code? I'll say word count, and this guy says, yes, I realize there is word count. When I say finish, okay, so there are some files I see, but God, there are some errors also. So here you go. This is trainer's code. Looks to be pretty good. Problem is that there are so many errors. What do you do right now? The errors are because you have never got the libraries. So it's time to get the libraries. So let's look at it. There are good amount of errors. Let's say 48. Let's bring the library one by one. So we say Java build path, add external jars, user lib Hadoop, and get all the Hadoop libraries. Once you come in, some errors will reduce. So there are actually less errors right now. Now we need to get libraries from MapReduce also. Add external jars, lib, MapReduce. Perfect. So some errors are less. Let's see what is the error that is still there. There is something called generic options parser that appears to be a pain. Now let's see what you are supposed to do. First thing, you've got MapReduce, but you are supposed to deploy your code on Yarn. So you should also have the Yarn libraries. and you should also have Hadoop lib in these libraries. So I've created all the libraries, and so good, all errors are gone. We are happy, pretty happy. Errors are gone. So let's say code is given to you. We've not got into code, but you imported the library and it is code free, right? It's like error free right now. So let's say export. So I'm showing you how to bundle it now. First, we'll jump into code later. I say jar, and I'll say put it in home training word count.jar. I say finish. It says there are some issues. I'll say okay, ignore them. So I see this jar called as word count.jar. This is just now created by me. This is just now created by me. Let's run this. Hadoop jar word count.jar. Now my package is com.hadoop.wordCount. com.hadoop.wordCount. Okay. I am running it with input data, and I'm running with a new folder called as, or let's run with output, but we should clear the output. So HDFS DFS ls. I will delete the output folder. HDFS DFS rm-r output. So I've deleted output. So let's run this job. It says it was expecting output folder. I said no problem, take it. So the job has got submitted. So once this job succeeds, you know how to see output. And we'll pause for a minute to document the steps for you so that you see that this pointers will be there for you to see. Okay. So let's first talk about how to create the code. So first one, take the code from LMS, unzip it, take the word count folder and put it in workspace. Open Eclipse. So good. Say new Java project. Include libraries from user lib Hadoop, user lib Hadoop lib, Hadoop MapReduce, Hadoop. Yeah. Export the code as jar file, run the jar file, bang, you are done. Okay. So how to create a code? This is option 1. This is option 1. There is other way also, we'll see that. We will see that. So then this is your option 1. Okay. Now option 2. Option 2. So this is called using Eclipse. So using Eclipse. Option 2 is using a build tool called Ant. Let's see what do we mean with that. Let's see what do we mean with that. Okay, so we will do this and then we will jump into the code. So we'll pause for questions and then we'll jump into the code. Now I don't want to use Eclipse. No, I'm not comfortable with that. I am a guy who's, let's say, very comfortable with build tools. So don't worry, Intellipaat has already taken care of that. In the word count folder, okay, this code is ready. I'm supposed to build a jar file, but jar is already there. Let's remove, we'll see it. So you use a tool called as Ant. Ant is a tool that will create a jar file based on the steps. Let's look at it. It will be simple. Okay. Just to prove that I am doing it differently, I will do completely different setup here. So let's look at it carefully. I'm saying mkdir America. This directory is nowhere I have created in front of you. Then I say cp Hadoop code files, writing MapReduce program, word count. I want to copy this entire folder in America folder. So I'm not using Eclipse anymore, okay? I'm copying it in America. It's done. Look at it. lsltr America. You see a folder called as word count. Now I say cd America lsltr word count. What man, this jar file is already ready for me. So I will delete this jar file in front of you. I'll say rm-r word count of jar. So now you see there is no jar file. So Ant is a utility that you install and just go to word count folder and run this command Ant. And Ant has successfully built a jar file for me. So this was like from the command line. Now what I do is, it is simple. I'll say I want to run this word count.jar. I am directly running word count.jar, which we created right now. But instead of output, I'll give another folder Ant. Okay, so output came. Just to prove HDFS DFS LS, I'll see how it's going. So let's document. If you want to use a build tool, first in your VM, just run a command. First, install Ant. Use a command sudo yum install Ant. Copy word count folder from the LMS code files to say a new location of your choice. We did it in America. Now there, just do cd word count and delete existing jar, run Ant command, bang, your jar is ready. Run your code. Now Eclipse is very easy, it's all automated. But now the question would be that, can I have this Ant based stuffs? I have already given you all the steps, but if you want more details, each program as a README file for deployment. So if you go to this Hadoop code files in word count, there is a proper readme.txt that will tell you how to do it. Make sure your folder paths are correct. That is something you can take care of. This explains you the logic of the program, and at the very end it tells you how to run it also. It tells you that exact steps also. Okay, so this is README. If you're doing from Eclipse, that is easy, just import a project that you don't need a documentation. But if you're doing it from the background, this is what you should be doing. So I've documented both the steps. So at least one thing is clear. At this moment, we are clear with how code gets submitted, how code gets bundled from Eclipse as well as from command line using and how to code MapReduce. And now it's time to talk about how do you code it. Now when it comes to how to code it, every MapReduce program will have three files: driver, mapper, and reducer. Okay. Okay. So here we go, and that's where we have our word count program. And as said, we have one word count.java, but there'll be three classes in that. So let's first see all three classes before we jump. So this is my reducer class. I guess in case you're not able to see, let me increase the font size. Preferences. So we go for editors, text editors, colors and fonts, edit, and let's go for a bigger font, 14. So this is bigger. So this is my word count, which is my driver class. This is some reducer, which is my reducer class. And this tokenizer mapper is my mapper. So in this you find three Java classes. Okay. So word count happens to be my driver class. Within that I have a mapper, and within that I have a reducer. So we are clear. Let's see how does it go. So the first thing that happens is it goes to main. That's where Java code starts. That's where Java code starts. Now the first thing we are calling is, we are saying that read the configuration. Okay, that means where is the name node and all that. So if you recall today morning, today first thing we saw is that etc Hadoop conf folder. So this basically is reading that particular configuration folder, and it is also checking if there are any other arguments that we've got from the user, some customization that user has given, for example. Okay. Alright, so read the configuration and see if there are some other configurations like input path, output path, and all that stuff. Okay. Now, what we are looking at if the arguments given by the user, if they are not equal to 2, then job should fail. That means we are expecting the user to give us input path and output path, and if we don't get it, I would request it to fail. Let's look at it here. So I'm running this job and I don't give output. It clearly says the usage is word count in and out. So that's exactly what it says. So then it starts the job class. Job is basically now reading the configuration and applying it. And here we are saying that my mapper class is mapper. My combiner is going to be the reducer class only, and then there is a reducer class. So we are calling our combiner. Set jar by class is basically saying that this is our main class. So the jar file should basically look for this particular main class. So here we are good. So we've informed our framework that these are the classes that will be called. Now let's talk about the output format. Now we are saying that what we are saying is, so first here we are specifying that input path and output path is specified. We are saying that both mapper and reducer, their output is text comma integer. Let's carefully understand. Let's carefully understand. So we were looking at the output folder, right? HDFS DFS cat output slash part R00000. So this is text. This is text comma integer. So we are saying that our mapper output is word comma 1 and our reducer output is also word comma integer. So we are saying our output key class is text and our output value class is int writable. Int writable is nothing but integer which is serializable. Integer which is serializable. So there is a class for that. And once we've set all that, we are submitting the job. We are submitting the job. So if you see, our driver class has no business logic. It just knows what is mapper, what is reducer, and it simply calls it. It just knows mapper and reducer and it simply calls it. So far we've not done anything with the business logic. Business logic will come later. So my driver is ready. And yes, we agree that driver is not business logic. It is just setting expectation. Oh, this is my mapper, this is my reducer, this is my input type, this is my output type, blah, blah, blah. Now let's go to the mapper. Now mapper is our smart guy who will work on one record at a time. One record at a time. When I say one record at a time, what do I mean? Let's talk of that. When I say one record at a time, it is HDFS DFS cat input Intellipaat.txt. Am I missing something? ls input. Okay, it's got the spelling wrong. Intellipaat dot. Why am I doing ls? I should do cat. So one record means Intellipaat is one of the very first companies who got into big data. Okay. So this map will take one record at a time. That means this is my record. And in the notepad file or text file, this starts with a byte offset 0. Okay. So it says this is an object which is key and the value is this entire string. Intellipaat was the very first company or is one of the very first company that got into big data. Now inside, if you see, we are tokenizing this value. We are tokenizing this value. That means this string is now tokenized into so it's tokenized as so that first record is broken into bunch of strings. Okay. So Intellipaat is one of the very first companies now broken into this. Now we are iterating it. While the iterator has more tokens, please go to the next token and emit word comma 1. Now what is 1? It is already defined here. 1 is this integer 1. That means the output of mapper will exactly look like Intellipaat comma 1 is comma 1, 1, the comma 1, the very comma 1, first comma 1. Nice. Now shuffle and sort is part of the framework. We don't really have to code. We just have to code the reducer. So after shuffle and sort, the input might look like big comma 1 1 1 1 because there were 4 sentences, and data comma 1 1 1 1. Nice. Now reducer takes one bucket at a time. That means it takes big comma 1 1 1 1. Key is text and iterable on integers. It starts sum from 0. It says 1 plus 1 plus 1 plus 1, and bang, the output is big comma 4. That's my final output, big comma 4. My friends, look at this. HDFS TFS cat output slash part r big comma 4. Why it is 4? Because in my input comma big is 4 times. That's how your word count is coded. Like this, any MapReduce code can be coded. Any MapReduce code could be coded. That's how it looks like. Okay, that was first what you call code. Like this, there are what you call multiple assignments, and they will more or less follow the same trajectory. So let's proceed and do one more project. We go again. Again, we are interested in looking at the code right now. Okay, so the job will run, README is there. Let's look at how to aggregate the data. So the project is time diff, and we are interested in looking at the code right now. We know how to run it, so that's fine, and code is working, so that's okay. We need to see the code right now. Let's see what we're doing. So I say cp Hadoop code files, how to aggregate time diff. I will copy this in workspace so that I can show this in Eclipse. That's the idea, right? So I say workspace, life is good. Say programming, Eclipse. So we'll close word count. I'll start a new project, new Java project, time diff, finish. And now you know how to get rid of errors and all, but I'll just do it just to, you know, steer clear of it. Libraries, add external jars. Same process which you've already seen. Okay. So now what we are trying to do here. So let's carefully understand this. Again, you want to understand it, very simple. Just go inside and there is a proper readme.txt. So it shows how to run, but the idea is this is my input data where I have some users. I have their start time and end time. I just want to know how much time they spent. Let's carefully look at it. It's a very simple thing, okay? There is a user called Ram. He started at 12 and Ram stopped at 13. So 13 minus 12 Ram is 1. Del. Started at 12, ended at 14. So we are just doing the same word count thing, but we are just performing another operation. So del is 2 and money guy is 2. All good. Now let's look at the code. So again, we have our mapper, we have reducer, and we have main class. So same thing, we are setting up everybody just like previous thing. In my mapper, my output is username comma time. Username comma time. So here my output will look like this. My output actually from mapper will look like this. Now if you carefully see, so I'm putting this full-fledged thing so that you get the whole idea. But I'm only writing name, which is key, and the time as value. So I'm not writing start and end. Let's say I'm not interested in it right now. That's why I've said I want to only emit user comma time. I'm not interested in start and stop. That's how I code it. Simple as that. Nothing like I can push it. It's Java, but I'm just pushing username comma this. Now to reducer, the input, there'll be 3 buckets. First one will be this, which may look like 10, 12 or 12, 10, doesn't really matter. For second one, it will look like del 12, 14. And for third, it will look like RAM 13, 12. Doesn't really matter. Here we are saying that take any first value as whatever you get and the other value as start. So first will be start, second will be stop, and finally we are just subtracting by doing abstract. So my output will be, I'm using the absolute value, my output will be minus an absolute value, so my output is 2, 2. So that's how you write your MapReduce code. MapReduce, divide, conquer, performing a join. Let's say here, this actually is a classical example of we are kind of performing a join. Okay. So I say cp-r Hadoop code files, multiple input formats, multiple to workspace. Okay, so it's multiple input. We go to Eclipse. So this is slightly strange and slightly interesting because, so we'll ignore the errors, you know how to fix them. Here what we are doing is, there are multiple mappers. There is one mapper that reads customer details and there is another one which is reading delivery status. So there are 2 mappers in it and there is one reducer in it. Okay. So here what we do is, I say multiple inputs. For this particular input path, call customer detail mapper. For this input path, call delivery status mapper. So first 2 mapper will run, one for one file, other for other file, and then you call the reducer where you are performing a join. So let's pay attention to it. From customer side, I am writing cell number, comma, let's say customer name. From delivery side, again I'm writing cell, comma delivery code. And here based on cell, I am giving away customer name and delivery report. So this is a classic join. Let me draw this for you. So the flow looks like mapper, mapper, and let's say reducer. So this mapper, he reads customer data, and this mapper reads delivery data. So this is complicated in terms of, you can always have multiple mappers like that. Now this guy emits, let's say, customer ID, comma, some details, and this guy also emits CID, comma, some details. What we get here is CID, comma, details 1, comma, details 2, and here we can emit details 1, comma, details 2. So this is how you will perform a join. Let's look at the readme part. This will give you complete idea. So like this, you will always have what you call more and more examples on internet. You can find thousands of them. So I have customer data, which is this, and I have mobile status, which is this. Now what we do is, one mapper will extract ID and name, second will get this, and finally I am getting the status as a join, which is customer and does he have a phone or not, let's just say. Okay. So like this, we've seen the basic constructs of MapReduce and everything that is around it. We've gone through the real code. The use case that I showed was actually doing a join. Now for join, you've got to have the key, which is same. So let's understand what we are trying to say. There are two ways to achieve it. Two ways to achieve this separate data. So let's say first is a easier case. I have a file from what you call RDBMS that came as CSV, which had, let's say, user ID and let's say XYZ info. Another file I got from JSON, the JSON structure will have user ID and again ABC. So of course one way to tackle is my mapper will be called here. My mapper will be called here. Okay. And it will emit the same key and then you go to the reducer. Now, this will work only if you have the key. So formats are different, but they still have a key. Now, if you have completely separate data sets, you will have to still find a way to get a key that is for you to get it. But let's take a simple example. Okay. I'm doing some XYZ analysis on cameras. Now for those, you know what you call, then I have some images. Okay, and in that images I have quality of images. Let's say there is a way I calculate quality. So I have cameras, their specifics, images, and let's say their pricing information. Let's say my use case says that finally I want to know which is best camera at every quality point. So now this use case is pretty much very much like ETL, right? So I get my data into Hadoop. This is my E. This is my E. Then I may have to write separate MapReduce code to get what I want and maybe dump a key inside. So I may have to manufacture a key inside. So this will be a separate T, separate T, separate T, which is completely independent. But when I write a T, I have to somehow make sure that now I get the key right. And then I'll have to perform the final join and then do a L. So the point is, the example that I showed, keys were ready-made there, but sometimes you don't get keys ready-made. That's where you require developers who will do E. Your process of T is to make sure that data has the same key. Just like a normal traditional BI, you have dimensions and facts, you're wiring them up. It will be a tedious effort because let's say formats are like, for example, here you actually got images. In this case, T, you are extracting information from an image, analyzing it, and then basically wiring it together. So sometimes this will work where the key is ready-made and you directly do this. And sometimes you'll have to write independent jobs and eventually wire them together to get what you want. Are we clear with that? But yeah, eventually your job is to get the keys together, otherwise you'll not get your output. That's how your ETL facts and dimensions is what you create, right? That's exactly that way. Hadoop ecosystem. So let's start. So let's take a small example just to drive the whole thing. So let's say you have wrong design, but let's just say this is iPhone. This is iPhone. So sorry for the drawing, but well, let's just say this is iPhone. Okay, so we've got iPhone. When you say iPhone, what does iPhone really mean? What does Apple give you? It gives you the hardware, plus it gives you iOS, that's the software. Now this is basically your phone. Let's just say that this is your core phone. Along with that, now this is what you get when you buy a phone, but there are few other things that are related to iPhone, but that are not part of your core phone. One of course is apps. So you buy them, you install them, that's your wish, but that you don't get directly with your phone. Accessories. So let's just say screen guard, cover and stuff like that. And let's say there are some services like, you know, think of it like Spotify, music services and so on and so forth. So these three things are not part of core Hadoop or core, you know, what you call iPhone, but they are kind of ecosystem. Okay. Now, very similarly, when you say core Hadoop, what you get is HDFS yarn and MapReduce. So let's say you call up your friend and say, hey man, I have installed Core Hadoop. That means you have HDFS, yarn and MapReduce, and we've kind of covered that in a lot of detail. But my friends, that's not all. That is not all. Why that is not all? Well, just like a phone, there is a supporting ecosystem. You have bunch of applications that are there to solve some problems and add to this, and that is called Hadoop ecosystem. That is called Hadoop ecosystem. So let's just say that what apps are to iPhone or any phone, ecosystem projects are to Hadoop. Okay, so let's proceed with this right now. Very similarly, Hadoop has ecosystem apps. Let's see some of the apps. If I want to get data from RDBMS to Hadoop, the ecosystem project that is there, or the app that I should be installing, is called as Scoop. It is called as Scoop. If I want to get data from real-time logs, the ecosystem app is Flow. If I want to, so this is my ingestion tool. If I want to process or transform this data and process, I have Hive and I have Pig. Just like Hive, there is another what you call processing layer or SQL engine query called as Impala. Then there is other processing framework called as Spark. Okay, so whatever is in black, it's an ecosystem project. So my point is, my friends, when I say I have installed Core Hadoop, that means I have only installed HDFS, MapReduce and yarn. Everything else has to be installed by me. Okay, so these are some apps. Everything that you see in black is ecosystem projects. Now, after our Core Hadoop is done, today's agenda is just to discuss all or introduction to all these ecosystem projects. That's the real idea. Okay, so let's proceed now. So here is the idea. Intensity will start when you go deep into each and every ecosystem project. So, okay, Hadoop has ecosystem projects. Can you list down some of them? Well, I'm going to list down most of them. But before I do that, note to you. So this is a small note from my side to you. Every app on your phone has a specific purpose. Like I cannot book my movie tickets from Facebook. I cannot book, let's say, my restaurant table from Uber, for example. Okay, so every app has a specific purpose. Very similarly, every ecosystem project has a specific use case. So with that, let's talk about each one of them. So let's talk about most popular. Okay. So first is Scoop, which is RDBMS to Hadoop or Hadoop to RDBMS. Second is Flume, real-time logs to Hadoop. Third is Oozie, which is workflows for Hadoop. Fourth is Pig, kind of PL SQL on Hadoop. Fifth is Hive, which is SQL on Hadoop. Impala, which is SQL on Hadoop, just that it's faster than Hive but does not have failover capability. That means even if one slave fails, job will have to be resubmitted. So that's one major difference. Spark, just think of it this way, it's a new framework that is much faster than MapReduce. U, it's Hadoop on browser. Sentry, ACL for Hive tables, that is grant, insert, select kind of layer on Hive tables, and so on. So the list goes on. So the list goes on. You'll have a couple of more here and there, but these are some of them. Now, what we are going to discuss here is the first five: Scoop, Flume, Oozie, Pig, and Hive. U is nothing but a browser-based application, and Sentry, again, nothing's to be covered from the developer perspective because it's just grant, insert, select to user this. So for admins, they need to set up Sentry separately. That's the idea. So Impala is just like Hive. Spark, we'll just touch base upon it, but we'll go fairly deep in the courses ahead. U is Hadoop on browser, and Sentry is basically the ACL layer, access control list layer. So now the next thing we do is let's understand what we are supposed to do today. So I'm basically building this for you guys. Here we have so let's understand the flow. Let's understand the flow very, very smoothly. First, at the very bottom, guys, you have a Windows machine. On Windows machine, you have CentOS. And yes, there are 6 services that are installed. The services are name node, data node, secondary name node, okay, resource manager, node manager, and job history server. Now what I want is, okay, so we understood that there are 5 ecosystem projects. They have all their purposes. and we've kind of introduced them. We will first on this VM install Scoop. What is Scoop there for? So let me install, let's say, Scoop here. Once I install Scoop on my VM, let's say I have MySQL, let's say. So Scoop will help me get data from RDBMS and dump it into HDFS. So that is our first demonstration today. Okay. So we've seen the ecosystem projects. So Scoop is basically a guy who can, let's say, get data from RDBMS and put it in Hadoop. It is all good. Once my data is in Hadoop, okay, what I'll do is to process that data. Of course, one way to do it is MapReduce. So we will install Hive and we will install Pig, and we will find a way to analyze that data. Today's agenda is to see, oh, there are 5-6 ecosystem projects. How do you really play with them? So the first one is Scoop. I'll get data from MySQL, put it into Hadoop. Perfect. Second is being able to write some queries in Hive and Pig. Okay. So let's start with that. Okay. Now, just to ensure that before we go deep, you should have some things installed on your laptop so that you are ready. Okay. So now I'm going to basically demonstrate the whole thing to you. So our first agenda is, can we take data from MySQL and dump it into Hadoop? Can we take data from MySQL and dump it into Hadoop? Can we then, do some processing, some any other data on Pig and let's say Hive? Let's look at that. So the VM is firing up. Okay, we are in here. All right. So let's carefully understand what we are trying to do. Let's talk about the main thing. So our main agenda right now is get data from MySQL and let's say query that in Scoop. Get data in MySQL and query that in Scoop. So first you're supposed to install Scoop. Scoop will get data from RDBMS to Hadoop. Scoop will get data from RDBMS to Hadoop. So let's do that now. First thing, Mr. Trainer, why don't you prove us that MySQL is there? So let's do that. MySQL -u root -p, that's password, and it is root. Oops, it says cannot connect to MySQL. And the error is so very clear. It says I cannot get through MySQL on the socket. Oh, that means MySQL is not running. How do I prove that? Sudo service MySQL D status. And this guy says, boss, MySQL is not even running. So I have not even got to Hadoop. I'm just making sure that RDBMS is up. If you're not comfortable with MySQL in real world, I'm sure you are comfortable with some database, be it SQL Server, be it Oracle, it's fine. So let's start MySQL. To start MySQL, the command is sudo service MySQL D start. Sudo service MySQL D start. Okay. So let me just put this command somewhere for you guys so that so the first command is start MySQL. Second is, do you have data in MySQL? MySQL -u root -p root. I'm in MySQL. I say show databases. And this guy clearly shows training DBs there, which is amazing. So I'll say use training underscore DB. And I say show tables. So within training DB, there is one database called as user underscore log. Within training DB, there is one database user underscore log. So from our flow perspective, one thing is dead sure that yes man, MySQL is there and we have verified it. Let me change the color here. Yes, MySQL is there. It is healthy and it has a database called training DB and a table called user log. Second is Scoop installed? The document tells you how to install Scoop, so you don't have to worry. So I have installed Scoop here. When I run, it says try Scoop help for usage. That means Scoop is installed. If it was not installed, I would have got an error command not found, but it is perfectly installed. So now let's play with Scoop. Let's play with Scoop. Let's do some simple stuff. So I'm not importing the data so far. I am just doing some simple stuff. So I'm saying Scoop list databases connect JDBC MySQL localhost training underscore DB username root password root. I am just checking the list of databases. When I run this, Scoop is running and it says yes, there are 4 databases in MySQL: information schema, test, MySQL and training underscore DB. Or let me verify this for you, okay, so that this is clear. MySQL -u root show databases. 4 databases, 4 databases. That means Scoop is good. Next thing I do is I say show me the tables within training DB. Instead of list databases, I'm saying list tables. So it says there is one table user underscore log. So why don't we see it here? Use training underscore DB show tables. It is indeed user underscore log. So looks like everything is good. Can we now import the data? Can we now import the data using Scoop? Before that, let me show you a snapshot here. HDFS DFS LS as of now has 3 folders and I'm going to delete all of them so that it's very, very clear to you. HDFS DFS LS, it's blank. Oops. Sorry. So HDFS DFS LS is completely blank. Let's do our main thing right now. We will use Scoop and we'll say Scoop import connect to this training DB username password, and I'll say that the table that I want is user underscore log. Fields should be terminated by by tab. Now Scoop internally will generate a MapReduce job, and what I want is I just want it to run one mapper. it's a small setup, so I just want to have, it's a small setup. So all I just want to do is, I just want to make one connection to RDBMS. I don't want to make multiple connections. By default, Scoop will make 4 connections. I just want to have one connection. Okay. So I'll say table user underscore log fields terminated by tab okay, and -m1, and I say bang, it is running. Let me prove it here. We have nothing in HDFS DFSLS, so it's submitting a MapReduce job. So the job is done. Carefully look at it. It got 50,000 records. It got 50,000 records. So let's match everything. I say select count of star from user underscore log 50,000. HDFS DFSLS. Oh, user log is created. Within that, I see one output file, which is, this is the output. But let's carefully understand what I'm trying to do. HDFS DFS cat. I want to count the number of records. So that's WC, so number of lines in a file. WC -L, and it's 50,000. You're free to do a cat to see this 50,000 records. And you are free to do a select star from user underscore log. So we've successfully got our data from MySQL to Hadoop. So that's our demonstration one. Now I'm sure that the feeling would be that probably, oh yeah, this is very basic. Yes, of course, today's idea is to be having it basic, because as I said, today level 1 of course is completing. It is just to introduce you to the whole thing. It's just to introduce you to the whole thing, and you go very, very deep into each one of them. Okay, but that's the general idea of Scoop. Okay. Now with that, now that we've got our data in Scoop, I want to write a SQL query on top of it. Okay. So Hive will let you create tables and basically let you perform analysis on it. Okay. So now we will look at how to write SQL queries in Hadoop. But how Hive internally works, we will go very, very deep in the next week. So just stay parked, stay put. Everything that we see, we will have a lot of details on it. The next part of our introduction is Hive. Okay. Can we write SQL queries on the same data? Can we write SQL queries on the same data? So what I'm trying to say is HDFS DFSLS, I see user log. Now on user log, at user log, I see this part M000 stuff, which is the file. Now, can I create a table on top of it and write my SQL query? Can I create a table on top of it and write my SQL query? See, what I'm trying to get to is, guys, this is a normal text file. On text file, I cannot say select star. So Hive will let you do that. Right now the point is, oh, I have got some data and I am unfortunately not good at Java. So I don't know how to write MapReduce code. Can I do some magic so that this file that I got, which is let's say 50,000 records, I want to perform some analysis, but I'm very good at SQL. So the tool I will use is Hive. The tool that I will use is Hive. And now we are going to see how will Hive do that. How will Hive do that? Okay. And how is internally this whole thing is working, how this whole setup is there, next week is all for that. And we will go very deep into Hive. Okay. So this is like the setup part that you'll be doing on your VM. Okay. Now, all we need to do is we need to go to Hive. Okay. Wow. So I'm on Hive prompt and I say show tables. Oops, there is only one dummy table. Let's drop that. Sorry. It's drop table dummy. So now when I say show tables, Hive does not show me any tables. Okay. My agenda is that the file that I got from Scoop, can I write a SQL query on that? Right now, that's my agenda. And we will do that right now. Okay. Right now, we will just look at the usage. So think of it this way. I am right now explaining features of a car and how to drive a car. Okay. Right now, just look at, oh, how to drive a car and just enjoy that part. So let's jump. Now what we do is, I run a simple create statement. So what I do is I say in Hive, let me exit, say Hive. Now carefully look at it, guys. I say create table user underscore log, where the first field is country and that happens to be string. The second field is IP address and that happens to be string. Each row is a single record, so we say row format delimited fields terminated by very important tab. The data that we got from Scoop, we only said that the data should be delimited by tab. That's why I have to respect that delimiter in Hive also, that the data that came is tab delimited. Had I made it comma here, I should have been putting a comma here because the data is delimited that way. So now I am saying yes, the data is in, and yes, it is separated by tab and it is very well stored as text file. Wow. So I have created my table. This looks perfect. This looks perfect. So the table is created. I say show tables and I say user log table is there. But I have just created a table. I have not loaded the data. Select star from user underscore log. It says there are 0 records there. So why don't we load the data? So let's load the data. Now for data, we are loading exactly the same file that we got using Scoop. I am just loading exactly same file. I am saying load data in path user training user underscore log part m, okay, into table user underscore log. So I'm loading this data. So the data is loaded. Let's run some queries. select star from user underscore log. This shows the whole thing. Let's get the count by country. Select country comma count of 1, it's as good as count of star, from user underscore log group by country. So it submits a MapReduce job in the background, so I don't have to learn Java. It is converted to MapReduce. So the job is running. And this gives you count by country. So this data was country and IP address. You're simply getting country comma the count of the requests. The assignment is about a data that pertains to movies. A data that pertains to movies. So the data is called movie lens. Okay. And here you are supposed to create a table, load the data, and perform joins. Now this data is already given to you on LMS. So this is your data, ML100K. Just to explain this data, this ML100K is basically bunch of files which are there. They have different delimiters and all that. So your job is to first create the tables, load them, and perform the analysis. So I'm going to run you through the steps, and this is your assignment. Okay. Create table u underscore data, blah, blah, blah. Then load it, but this time you're loading it from a local file. So give the correct path wherever you are putting it in. Then you are creating another table called as u underscore log, user. Load it. Then you practice joins and whatever is required. So that's your assignment. That's your assignment. Okay. So this was a quick introduction to Hive. We've done introduction to Hive. We've seen how to get data from MySQL to Hadoop. We've seen how to query that in Hive. So let's see what hands-on document will say for us. So we are done with Hive. Okay. On through the week. Now Pig is another way to do things instead of Hive, but Pig is more expressive. It is more like PLSQL. Okay. Scoop and Flume is like E. Hive is like L. That's where you load, and transformation will happen in Pig. Okay. So you install Pig. Now the way this assignment will work for you is, just to give an example, I have written 6 codes for you. I have written 6 Pig programs for you, and you have an assignment to do the 7th one. You have an assignment to do 7th one. Okay. So now there are a couple of programs on Pig. We will directly walk through the code because there is nothing else to explain. Pig is just like gets converted to MapReduce, just that it's more expressive. So I've given you some programs. You are supposed to do one assignment over the weekend. Okay. So let's carefully look at it. So on your e-learning site, you will get this. I extract my Pig programs here. So we've written 6 Pig programs. Okay, they are very, very simple. Let's look at a couple of them. Okay. So let's say we will look at the first one, Pig with schema. Here what we are doing is, we are initializing, let me see if I can find a way to increase the font size. How do I increase font size? Preferences, fonts. Where is the size? More space 10. Okay. 16 would be good. Yeah, nice. Let's go very comfortably and look at it. So I'm saying that I want to have my first, think of it like a variable. Again, we'll go very deep into it in the sessions to come. Today is just a starting. We say weblogs load user training weblogs webstar using pig storage. It's a library that you call functions. We will see that in the next class using a delimiter called as tab. Now, in my data, I am specifying that there are, let's say, 18 fields, and I'm kind of declaring them. That my first field is this, second is this, third is this, fourth is this, and then I can perform any operation. In this first example, I'm just taking that data and dumping it on screen. Okay. So this is pig with schema where I'm defining a schema and I'm dumping it. Let's say if I want to do something else. Let's say I want to filter it. So I'll use something called pig with schema and filter. So what I'm going to do is I will load the data, but I will write a code which says career visitors filter weblogs by URI is equal to careers, and then dump it on screen. So I can either call it as dump and store. All you need to look at is that a Hive is more like SQL and this is more like PLSQL or more expressive. This is very close to what scripting would look like. Okay. So I can filter. I can also do a group by. So I'm saying group by something and generate the count. So basically pig is more like PLSQL and we will have good 6 hours of coverage on that. We will go very deep. Now let's quickly look at running one or two of it. So we will basically go very deep understanding how we are running this program, and then there is an assignment for you. So let's do that. So first thing is, let's say I want to filter all the users who are coming for careers website. Let's just say, boss, but where is the data? Oh, where is the data? What is the data? I don't even know that. So let's carefully look at it. We are saying that we expect data in a folder called as user training weblogs, and there has to be a file called web. How will it work, man? We don't even have the data. Well, it's our job to build it. Let's do that. So let's go to HDFS and say HDFS DFS ls. Do we have a folder called as weblogs? No. So it's our job to create it. So we say HDFS DFS mkdir weblogs bang. So the folder is created. We are all in good shape. But where is the data? Now the data is also given to you. Okay, it's there on the learning site. And this is your file, which is weblogs. So the file is weblogs parts.txt. We will put this file, okay, inside HDFS. So let me just copy this file to my training folder so that becomes easier for me to get it. So I'll say places. In my home folder, I'm putting this file called weblogs parts.txt. HDFS DFS put weblogs parts.txt in weblogs, the folder I just created in HDFS, and we are in good shape right now. HDFS DFS ls weblogs, and this shows me that particular file. So there are good amount of records. How does this file look like? Well, let's open it. It's a big file. So our first thing is IP address. Second is the whole date. Then for analysis, we've again broken the whole date, 3 June, all that. The time zone. Okay. Get, so this was the GET request. What URL did the user visit? 200 is a response code. In the web, 200 means that the request was successful. 0 is something based on the data that we have. The user came from Mozilla, he was using Windows operating system, and so on and so forth. So this is my one record. And as a developer, I have already specified pick that my first thing is IP, second is full request, third is day, month, month number, year, hour, minute, second, time zone, verb, URI, HTTP status code, bytes returned, referrer, and user agent. So now I have decided that this is my schema. In this program, I want to filter every user who came for a URI careers. So basically the URI should basically have careers as the URL. Only then we would want to filter that. So let's run this program now. Let's run this program. It is going to be dead simple. So now where is pick programs for me right now? Pick programs is in my downloads folder. Just to simplify it, okay, I will put them in my training folder. That's my home folder. Just to simplify, okay, it's just a folder copy, nothing else. So my PWD is home training. I said pig programs, pig with schema and filter. So I want to run the pig program which will filter everything by careers. Run this job, submit some MapReduce job, runs a big time job. Let's see. Now we've said that we want output to be dumped. Okay, there is other function called store. We'll be looking at that in detail. But here is the record that came. So like this, this is our output, let's say. Couple of records, we'll just look at it. 683.41.613.5 was our IP. This was our whole date, our time zone, the date broken. It was a GET request, and the URL that user came for was careers. Okay, so we've got all the requests that had careers in them. Like this, I have given you 6 programs. So you are free to run them, practice them, do what you want. And the 7th one is an assignment for you. So you've written all the 6 programs, understood the code, which is very simple, nothing, filter, group by, all that. Review all the 6 programs and write the 7th one. The 7th one should read the log file and give output as IP, month, year, and visits. Okay, IP, month, year, and visits for that IP address. So that is pig. Okay, can we do it? Yes. Will you do it? Generally no. Okay. Again, probably I won't be able to. I wanted to show one slide to explain what is what you call. If I wanted to just show one diagram for pig, this is the favorite diagram that you say. I get data from multiple sources. I'll have bunch of pig jobs that may validate errors, fix errors, encode values, and load it in a warehouse. In Hadoop, the warehouse is Hive. So let me take a screen snap of it so that I can explain what I'm trying to convey here. Okay, I take this, say capture, and this is E. Okay, this is T, and this is L. Now, having said that, does pig allow me to connect to Hive tables? Yes, absolutely possible. But in real world, you will not normally see people doing that. So answer is yes. But when somebody is doing, or you want to do it, ask yourself a couple of times in production level that, do I really need to do that? That's the point I'm making. But yes, it's possible. Don't worry about that. Hive and Pig are like SQL and PL SQL. They'll have bunch of their own libraries. Okay, and there is community which will have a lot of defined functions. But let's say something is not being done for you. Let's say be it Hive or Pig, you don't have a function to calculate a shipping cost. I can write that in Java and Python. You can call that as a user defined function. You can call that as a user defined function. So what I'm trying to say is, be it Hive or be it Pig. Okay, let's just put it this way. Let's say Pig has, for example, 100 functions, and from web you can get another library with another 10,000 functions. So that's, I think you'll easily find something called as piggybank.jar. So this will have basically some more functions for you in Pig. Same is the case with, let's say, Hive. Just like SQL, it has some functions ready-made for you. Just call them. But let's say your organization has a peculiar use case which has to be done, Okay. So, for example, you would want to pass a code, and based on that, you are supposed to get a full value, for example, that your organization only knows. Take a simple example. Your organization has device codes where you get device code and then I'll tell you the actual device, for example. So let's say Ravi will code something like a pig UDF for device name.java, .jar, and I will expose a function to you called as get device, for example. So whenever you're transforming, you pass one record, I will code that in Java and give you the output, just like a service. So this is called as user defined function. Same will be for Hive. Now, what you're doing is using Scoop to you're loading that HDFS in Hive and writing SQL query. Is that clear? Very straightforward exercise, completely self-explanatory. So if you look at exercise 5, it's you have MySQL where there is some data. It's fine. You are getting that data out using Scoop and dumping it to Hadoop file system. Fantastic. Once you get that data in Hadoop file system, you are using Hive to basically load that data in Hive and query that data using SQL queries. Okay. Now it's a self-explanatory exercise. You would not need help. Steps are fairly clear. What I would like to know from you is, do this exercise and answer a few questions for me. Okay. So question is, for Scoop, there is a UI. I'll talk about it at the end of the class. But right now, I'm not going to talk about UI because you'll first do it this way, and then I'll tell you what UI is available. Okay. So please answer following questions after you do the exercise. Okay, we successfully got data from MySQL to Hadoop, and from MySQL data is stored in Hadoop at which folder. You need to tell me the path where the data is getting stored in HDFS. Second thing you need to answer is, okay, we got data from MySQL. We got data from MySQL, and we found that there were X number of rows in MySQL table. What is? So get started. Just one thing before you start, please run this command. The command is not in PDF. It's sudo service mysqld start, and go on and complete exercise. All right. All right. So all you're doing is from MySQL, you are using scoop and getting data by HDFS. Then you're writing Hive queries, and you will be able to run queries on top. Now the only thing I want to know after the exercise is, you guys tell me, you got data successfully. Which folder does it get stored in HDFS? First thing. Okay. When you got the data from MySQL, how much number of rows are there in that particular data? And before you start, please run this command. This is very critical. You have 30 minutes to complete the exercise. So get started.
Can I ask you a quick question?
Yeah.
I'm trying to run this command scoop list databases.
Huh?
And after that there's a space and there's a backward slash. Is that correct?
Backward slash is basically continuation of the command in Linux. Okay.
Okay.
Just to tell you, backward slash is your way of saying my command is not complete, but I wish to go to next line. Okay.
Okay.
So,
okay. That's correct, because for some reason I was.
If you are typing the entire thing in one line, avoid. Okay.
Okay. Perfect. Thanks.
I typed the exact command and I got an error saying no manager for connect string JDB.
Are you getting communication link failure?
Oh, sorry, I type error. I'll try again.
Okay. Yeah,
Yes.
see, this PDF says this PDF has been tested by 300 odd students, so exercise 5 at least for sure there is no mistake at all. So you just have to check your command once. You might have not started MySQL, just be sure of that, and everything else should be good. Absolutely.
This is actually the base SQL tool, scoop tool. I have the issue like it's saying setting user your password on the command line is insecure. Consider using -p instead.
Okay. So I guess you missed. So there are two ways. Either you do that, or I think you missed password. You would have missed one hyphen here. Is that the case? There are two hyphens before password. Got it, Money? All right. Can you share your screen, Money? Okay. Yeah, just share. Okay. Oh yeah, I mean that's fine if you're getting your output, but yes, setting the password, you can do this, that instead of giving from the command line, you can basically what you call, give it from -p password, and it would ask you, prompt you the password so that it does not appear in your command. That's it, nothing else. Everything else is good. Yeah, it's perfect. Yeah, that's the same problem, Tang. See, you've not started MySQL. If you see the notepad, I've already conveyed that before you do anything, you need to start MySQL. Your MySQL service is not up, and what you need to do is you need to say sudo service mysqld start. Just run this command and rerun your command, everything should be good. Correct? Your MySQL service is not up. It's communication link failure. Can you come down, type this command sudo mysqld, sudo service mysqld start, and just rerun the command again. Yeah, sudo service mysqld start. No, okay. Come down, scroll down, scroll down. You have not started your MySQL. All you need to do is sudo service mysqld start and run all the commands in the PDF. Got it? Exactly. Good. Just run this and run all the commands as you've been running in the PDF. Everything will start working now. Alright. Now just press up arrow key 2 times and you can run the previous command. Everything will work. Yeah. And run this now. Yeah. Enter. Alright. Done, right? Dank? Yeah. All you have to do is start your service that we've written in the notepad. Good. So just continue now. That's it. How do I exit? To exit Hive prompt, you have to use exit. Getting error on the last command. Okay, tell me what error you're getting. I'll tell you.
It is like syntax error. It's saying for
Yeah, so then just check the syntax. Yeah, it's a semantic exception, then it's syntax. That's it. Is Hive case sensitive? Functions are case sensitive. Okay, table names are not. So it's there is no straight answer to it. So a few things are case sensitive, few are not. And again, it's trial and error. Stuff like functions, they are case sensitive. So count has to be case sensitive. Table names need not be. Statements need not be. So select in small or big is all same. So it's like that. Yeah.
I'm getting an error, no matching path HDFS this one, so
Yeah, but not a problem.
messed up the mistake step or
Share your screen. I will just. Okay. So select country count of 1 from Hadoop. Turn off the webcam. Okay. Okay. Select country count of 1 from user log group by country. So if you see select country, hey man, you need to go to Hive prompt. You first go to Hive prompt. You can't type it from here. You'll have to get there to Hive prompt. Okay, everything is from Hive prompt. Yeah. Okay. But I guess, yeah, if you dumped your data in a database, then you'll be doing it from a shell command only. So, I mean, from the Hive prompt only. So just run Hive, 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 and yeah, enter, and run this command. Run the last command. Wait a minute. Good. Now run the last command. Run the last command and you should be good. How does Scoop understand that, hey, I have to talk to HDFS? Point is, Hadoop is installed on your machine and Scoop searches for Hadoop config files. Searches for Hadoop config files. There it finds, oh, Hadoop is on local host, and then runs on local host. So if money worked on Oracle, you know tnsnames.oracle, right? You have Oracle client and that guy talks to the database. Similarly, you have Scoop client. That guy figures out where is Hadoop's config file and it looks that, oh, it's running on localhost, so it connects to localhost. If your Hadoop config was pointing to a cluster in New York, then Scoop will also connect to New York automatically. Got it?
So is there any configuration that need to be changed in Scoop when Hadoop is on a different machine or something like that?
No. So if there is a Hadoop on a different machine, your Hadoop configuration will change and Scoop will pick that up. See, right now your laptop, okay, your virtual machine, Hadoop is running on the same virtual machine, right? Okay. Let's say Hadoop was running in New York cluster. So you are sitting in Bay Area, Hadoop is running on New York. So your Hadoop client on your laptop will now say, I have Hadoop, but I'm not running Hadoop. I'm pointing it to New York cluster. And when Scoop is running on your machine, it will say, it'll ask your Hadoop. So can I import data to you? You are saying that I'm not running Hadoop. New York cluster is running it. So whenever you execute Scoop, it should be executed on the New York cluster. Got it? You will be, now you're right. Hadoop client and Scoop client both are in launch. Alright, so if everybody's done, can we start the next exercise?
Is there any chance you can actually tell us where exactly it's stored, the information on Hadoop folder, or what Hadoop folder it's used? I'm a little bit lost on that.
Just run Hadoop FSLS and you may find your answer. Can you just run Hadoop FSLS on your machine?
Yeah.
It is moved to Hadoop file system, right? So how do you access your file system or your workspace? Hadoop FSLS. Do you see something new there?
Yes. Yeah. Okay.
Got it?
Yeah. Perfect. Thanks.
And the other answer was there were 50,000 rows that got transported. And I think everybody got 50,000 right. Okay. All right. So let's get started with next exercise. Next exercise again is a 5-minute affair. I'll explain you. I'll show you that exercise. And after that, you guys can do it and call it a day. So as in when you complete, you can just call it a day. So exercise 5 was clear to everyone. Now let's talk about exercise 4. So look at this. In real world, when you code a MapReduce, this is what the flow looks like. So first always is write your Java code. You will have to write your Java code, right? Then bundle the same as a jar file, submit it to Hadoop cluster, just like the way we ran the sample program. So all you're trying to do is you will write your Java code, bundle the same as a jar file, and submit to the Hadoop cluster. Fantastic. That's simple. Now I have already done one part for you. I have already written code for you. So all you need to do is you'll bundle it as a jar file, run the job, and see the output. Okay, very simple, really straightforward. Okay, is everybody clear with what I'm talking about, or somebody is not clear? All right. So now we will ask one of you guys. I'll ask one of you to share the screen, and let's do this. Okay, but before that, let me give you high-level steps. First, we will create an input folder in HDFS. This will be our input folder. We will dump some data in HDFS. So this is our input data. We bundle our code as a jar in Eclipse, and we finally run the code to get the output. Very straightforward affair. So who wants to share the screen? Alright guys, next 2 minutes, just on screen carefully. All the instructions are in the PDF. Follow them correctly and you should be good. Okay. Now let's start with the first thing. Let's create an input, directory. So you are saying that Hadoop FS mkdir user training word count input. Word count input. So guys, just pay attention for 2 minutes here. Don't do it. Then you dump some input data. So you are saying Hadoop FS put word count.txt to user training word count input. Awesome. So you have your input data also in now. Now, what you need to do is, you will see that I have written that code in home training exercises. So can you do ls home training exercises word count, ls ltr hyphen ltr, home training exercises, home training exercises. No, home has to be starting with the slash.
Sorry, yeah.
Home training exercises and word count slash word count.
It should be LTR, right? It is type LRT.
No, word count is not an empty file. It has data. Okay. So right now, what you see is that there are 3 Java files I have written for you: mapper, reducer, and the main class, which is the word count class, which is your main, where the main function is there. So what you see is that 3 files are coded for you. All you need to do is bundle it as jar file and submit it to the cluster. Now thing is, to bundle jar file we will use Eclipse, but Eclipse by default picks up the code from workspace folder. So we will copy these files to workspace and then open Eclipse. So now you start running the commands in the step 2.
Okay.
So you can just clear your screen and run command from step number 2.
Yep.
So you just say cp. Yeah, cp. -r. So now we are copying all the commands that I've had. So you are taking the code and dumping it into home training workspace word count. Exactly. Not required, not required. That's fine, yeah. Enter. Okay, cool. Now the next thing is your code is at the right place. Now open Eclipse.
Open Eclipse from
Applications,
okay.
programming,
Applications.
programming, and Eclipse. So guys, you are supposed to say open Eclipse, new Java project. Okay, so okay. Click OK. So open Eclipse, it has to be new Java project, give the name as word count, and everything else will follow.
Okay, so
there's a file, new Java project. Okay. In Java projects, type word count. So the name of the project is word count, all small, all small. Awesome. So when you do word count all small, everything gets grayed out because everything is defaulted. Say finish, just say finish. Once you say finish, you look at word count and you will see, can you expand word count default package? What do you see?
Okay. So you
see all the 3 files?
All the programs here, yep.
Yes. But then you get errors. Why there are errors? Can somebody tell me?
Because there is no build path set up for the files, maybe?
Exactly. There are no Hadoop libraries set up for this project. That's a problem, right? So now what you need to do is you need to import the libraries. So you click on right click on word count and say properties. Say Java build path. Say libraries and click on add external libraries. Add external jars. Now on the left side you see file system. Yeah. And now navigate to a path called user lib Hadoop. User lib Hadoop. User lib Hadoop. And select all the jar files. Fantastic. Then again say add external jars once more. And this time you need to go to user lib. So file system, user lib, Hadoop 0.20 MapReduce. And select all the jar files. Say OK. Now what you should see is all the errors are gone. So you are all done. Now right click on word count and say export it as a jar file. Say Java, say jar. Okay. Click on jar. Yeah. Click on jar and say next.
Yep.
Say browse. So you are already in your home training. You need to just say word count. WO all small word count and say OK. So this will create a jar in home training word count. Say finish. Finish. You're done. Now close Eclipse. Now, can you do ls-ltr? Do you see something new?
Yeah. Yeah.
Word
Word
count.
count chart.
Now run this program. So just say Hadoop jar word count.jar. Now space main class name, which is word count, W capital C capital, space word count input and word count output, all small, because your input path is word count input folder, which is small. Word count input, input. That's the folder you created, right? And word count output is your output folder. All right, just say word count output. Press enter and you are done. Okay, press enter. The program runs. So successfully done. Then Amrish, can you tell me how will you see the output? You've already done that. How to see the output?
Yeah, Hadoop. No, sorry.
Yeah, you're right. Go ahead.
Hadoop FS.
-ls. -ls. Enter. Do you see the output that you need? Which folder should have the output? Exactly.
Okay. Word count output.
So you just say Hadoop FS -ls word count output, and you will see a part file there. So you see your, now what you do is you say Hadoop FS cat word count output part 00000, and what you get is the word count of all the words in word count.txt.
So the question is like, what is Pig and is it something similar to Hive? I have heard a lot about Pig. So where it is used, where it is not used. The first thing I'm going to tell about Pig is that, so this might be a little bit confusing, but still, Pig and Hive were invented almost at the same time to solve the same problem, meaning both these tools were invented almost at the same time, and both these tools allow you to solve the same problem. Well, almost the same problem, I can say. In most of the cases where you can use Pig, Hive can also be used. There are some situations where you cannot, but mostly. So you may be asking then, why did you just invent one tool? Why did you invent two tools? If Pig and Hive are almost the same, then why do you have two tools? See, the answer is very simple. Remember the use case of Hive? So Facebook was dealing with massive amount of structured data, and they were running most of their queries and all on Oracle with hand-coded Python, and that was the stage set for the invention of Hive, right? So Facebook had to move to Hadoop, and they had to query the data, and they didn't know what to do. So they practically invented something called Hive. At the same time, Yahoo was facing the same problem, but in a different way. So you see, Yahoo is the company who practically kind of invented Hadoop. They did not invent Hadoop. They basically acquired the Nuts project, actually, but the first stable release of Hadoop actually spun out of Yahoo, right? So when Yahoo had Hadoop, okay, the same problem was there. All right, I want to work with the data in Hadoop, but the only way is MapReduce. That means I have to force my employees to learn Java, then write MapReduce code. What should I do? But Yahoo thought it in a different way, actually. What Yahoo thought was, right, all right, let's create a scripting tool. Let's create a scripting tool which is very easy to learn so that people will just install it, write their script, and just run it. And the scripting tool is going to convert the script into a series of MapReduce programs. And that is your Apache Pig. So even though Yahoo invented it later, they contributed that to Apache, and it became a top level project. And you will be surprised to know that somewhere around 2013 and 2014, I think around 70 to 80% of ad hoc jobs in the world of Hadoop were achieved only using Pig. Pig is so popular, actually, one of the most popular tool. Well, not very recently, after the invention of Spark, in fact, Pig's popularity is not as we see today, but yes, still Pig is one of the best choice for all the programmers and analyst folks, right? So what exactly is Pig? We will see. So to give you the backdrop, this was invented by Yahoo at the same time when Hive was invented by Facebook. The only problem, these two companies did not talk to each other, right? So they didn't know that they were trying to solve the same problem and ended up inventing two tools. What is Pig? So it's basically a scripting language used for exploring large data sets. Now it is a new language, which means you will get some time to use to it. So the learning curve of Pig is higher than that of Hive. To put it in another way, if somebody has to learn Hive, it will be much easier since Hive follows SQL and most of us know SQL. You can just get a Hive CLI and start exploring right away. But when you start with Pig, Pig has its own language called Pig Latin. So Pig's language is called Pig Latin, and Pig Latin is a new language. So the syntax, how you use it, all are new. So you'll take some time to get familiar with Pig, but that's all fine. I'm gonna help you to figure out how to learn Pig and how to work with that. That's not a big deal, actually. So components of Pig. So actually Pig comes as a package in which you have something called a Pig engine, which runs on top of your Hadoop and converts your code into MapReduce. The language is actually called a Pig Latin. Pig Latin is your language which you are supposed to learn. Now what are the advantages of Pig? It removes the need of users to tune Hadoop, in the sense like if you're writing a custom MapReduce program, then you might have to fine tune the program, but Pig by default optimizes your code. You can turn on and off the optimization, but by default code optimization is turned on by Pig. So that means Pig will create the best optimized MapReduce code for you, and it insulates the users from Hadoop interface, so you don't have to practically learn MapReduce or Hadoop or anything. So if you're supposed to write some 200 lines of Java code, you can write the same thing in 10 lines of Pig Latin. And the same way, if you try to develop a Java-based MapReduce code in 4 hours, the same can be done in 15 minutes approximately in Pig Latin. So it opens the system to non-Java programmers. Now this we have practically seen. So whenever we are writing a Pig code, it's quite, how do I say, fast and easy to work with. Now it's a common way for every scripting language, right? So whether you are into Python or say Ruby or to shell scripting, all scripting languages gives you a couple of more advantages. All scripting languages are short and sweet. They have a lot of built-in functions to use. For example, if you look at Python, n number of packages and functions are available, right? Python codes can be very, very small. It's a scripting language, right? So the same way, Pig also acts like a scripting language. But it's not like your SQL, okay? So SQL is more or less like a query. So there, maybe if I want to pull the certain results from a table, I can write a single complex query and run it and get the result. But here, you might have to write it as a script to interact with Pig. So the next is Pig Latin data flow language. So it actually allows you, regular data types. So you can use long, float, char array, int, etc. So that is all possible. Pig also supports complex data types, which I will come in a moment. It is extensible and supports user-defined functions. So that means if you want to add some functionality to Pig, what you can do is that you can write it in something like Java, right, and call it inside Pig. So that is called user-defined function. I will show you an example of UDF or user-defined function. So you can write your own functions in your language, say Java, and package it as a jar file and register that with Pig so that Pig can use that UDF actually. Pig doesn't need metadata. It can work without metadata, without type declarations or anything. But if you provide Pig with metadata, it will work the same way. But Hive is not like that. If I'm working with Hive, my metastore service must be running. I cannot say that, okay, create a table, now don't use any metadata. It doesn't work that way. Either I have to use my own metadata service or something like hcatalog. But metadata is required. For Pig, you don't have to use metadata, but it can use when it is available. It can even share the metadata with other tools like Hive through hcatalog. It operates on files in HDFS. We know that. Provides common operations like join, group, filter, sort. So Pig has a lot of built-in functions. So provides common operators like join, group, filter, sort. So the power of Pig actually comes from these built-in operators. That means whenever you want to perform any operation, so you want to do a join operation, you can call the join operator and it will do the join operation for you, right? So this is actually from where the power of Pig comes into help us, right? What are the usage scenarios? So one thing might be web log processing. I will show you a Pig program which actually takes a web log and process it. Now Pig is very good at string operations as well as regex, your regular expressions. So this can be extremely helpful in situations like web logs. So imagine you have a web server running and it produces a lot of log files. Now the log files will be kind of unstructured. It doesn't follow a particular pattern as such. You can call it semi-structured, but I would like to put it like unstructured data. And if you want to extract something, you can use Pig. So Pig is very good at trim, substring operations, regular expressions, etc., etc. Data processing for web search platforms, ad hoc queries across large data sets. Even Hive can be used for ad hoc queries across large data set. Rapid prototyping of algorithms for processing large data sets. So who all uses Pig? Yahoo, one of the heaviest users of Hadoop, runs 40% of its jobs in Pig. Twitter is also another well-known user of Pig. So Pig is kind of like one of the most widely used ecosystem tool that is available to us. Pig versus Hive. Where Pig and Hive looks exactly the same, right? Then why do you need, or is there a difference actually between them? Yes, there are differences, right? So if I just have to relate this, the major difference might be starting with this, okay? This is so maybe the first point is that Pig is just a client-side application. So there is no Pig server or something, right? So that means, so Hive can have an optional thrift server, and we have seen a Hive server 1, Hive server 2, etc., and where you will be using what, right? But when you look at Pig, Pig is just a client-side application. So there is no Pig server or something. And why is that so? Because Pig is not a data warehouse, and Hive is a data warehouse where you need to create connections for accessing and storing data. Well, Pig doesn't have to have. And one more thing here is there is no JDBC ODBC connectivity, and here it supports connectivity. So that means either using the Beeline client or from your regular SQL clients, you can always connect to a Hive table. Right, so Hive actually supports JDBC drivers, right? So you can directly connect to Hive and do whatever you want to do. But since pig doesn't work on tables and doesn't work on storage, there is no JDBC ODBC connectivity. So if pig has to get some data, the data should be in Hadoop, in a folder or somewhere. And it reads the data, transforms the data, and stores it back into Hadoop. That is what it does. There is no table or something inside pig, right? And pig is actually used by developers mostly. And here it is used by analyst folks mostly. Right? So, I mean, it's up to you. But again, mostly pig is by developers and Hive used by analysts. And here schema is not mandatory. And here schema is mandatory. You need a schema, right? When you create a Hive table, you need to have some sort of a schema at least, right? And also pig doesn't have a web server. Here you can have an optional web server, a web interface for your Hive. That is possible. So I think these are the obvious differences actually. There can be much more, but some of the points that you need to consider, right? Where does actually pig fit in the scenario, right? So let's say you have a Hadoop cluster. I have a MySQL database maybe, and I have a web server here, and I might have an app server here. So what I can do is that maybe I'm collecting data. So maybe I can bring in Scoop here, which can bring my data from MySQL into a Hadoop, right? And from web server, maybe I will pull the log files using Flume or something. So I'm getting all the logs from here. And here also I'm pulling some logs. So you see, I'm trying to collect multiple types of data, mostly structured and semi-structured. I dump all this data in a folder. Okay, so this is my folder in Hadoop. So what am I doing? I'm collecting data from my RDBMS systems, from my web server logs, maybe from my data warehouses, from multiple places. And then I dump them in a folder in Hadoop. Okay, so now the data is there. Now you may ask me, can I send this data to Hive? Yes, you can, but usually what we do is that once it is in this folder, I will run pig, which will read the data from here and transform the data and send it back to Hadoop. So maybe, you know, here is my data, right? And this transformed data will be accessed by Hive for reporting purpose. So pig is actually used as a data factory operator or something which can clean your data. So what happens when you get raw data from the web server logs or from your databases? You may want to clean the data. So the ETL guys can correlate this very well more than that, right? You may have unwanted information, unwanted marks and traces and cookie related information, robot scrolling information, etc. a lot in the data. So in that case, I may not be in a position to dump this data into Hive, because Hive is my final destination where everything gets stored and my reporting tools can directly connect to Hive table. So what I do, I use pig for transforming my data, cleaning my data. And once pig cleans the data, I give the structure to the data, and then that data can be stored in a Hive table. So you see, pig is not storing anything. It is reading the data, transforming it the data, and storing it back to Hadoop. Another example is this sensor data, weather data. So if you're collecting data from this weather sensors like temperature, etc., etc., I will again show you an example. What happens is that the weather data usually comes in a very specific string format, which is very difficult to decode. So when I have my whole weather data in a folder, we can easily get the data, use some string operations to get whatever information you are interested, and then that structured data is stored in another folder so that your Hive can access. So pig is used as your cleaning operator or data factory operator to give structure to your data and so that it can be stored in Hive. This is the original concept. Now these days, whatever Pig can do, most of the things Hive can also do. Hive can also work as an ETL tool sometimes, but yeah, so Pig can be considered as a typical ETL on top of your Hadoop. Where Pig and Hive fit in the system, right? Where not to use Pig? Well, Pig is not really good at pure unstructured data. For example, you have audio, video, images, etc. In such cases, Pig might not be the right fit. It may not be able to process. So Pig is the best fit use case in terms of structured and semi-structured data. And the next point I wanted to discuss, how come you have a weird name, Pig, for this tool? You know, the guys in Apache are really funny, I believe. I mean, there is something called the philosophy of Pig. If you want, you can read it. The Apache Pig philosophy, wherein Apache explains how they gave the name Pig to this tool. So what Apache says is that, you know, first of all, the animal pig can eat anything. Same way, your Apache Pig can also eat any type of data, mostly structured, semi-structured, and some sort of unstructured. So that means Pig will not say no. Anything you give, it will eat, just like the animal. The second point is that the animal pig is easily domesticated, meaning I can have my pig in the house, pig in my farm. So pig is a creature which can fit into any place. Same way, this Apache Pig is also a tool which can very well work with different platforms. And Apache also says pigs will fly. So in the sense, like, you can write scripts on the fly. So that is the pig philosophy. So this is Apache Pig's philosophy. See, pig eat anything, right? Pig lives anywhere. Pigs are domestic animals and pigs fly. So check out the pig's philosophy and understands why it is called as pig. A pig actually supports something called complex data types. So it supports your regular data types, and it also supports a complex data type. So what do you mean by complex data type? There are three of them. One is called a tuple. Tuple is very common even outside the world of pig. Tuple is an ordered set of fields. Think about tuple like a row from a table, and tuples are usually represented like this. For example, 19,2, this is a tuple. Then there is something called bag. A bag is a collection of tuples. Well, the definition is not so correct actually, because a bag can contain tuples. A bag can also contain other bags actually. So bag is an unordered collection. So a bag is a complex data type which can contain tuple, or it can even contain other bags. Map is a key value pair. How to start working with pig? So first things first, you have to understand the data that I'm working on. Otherwise, there is no point, right? So first thing you have to understand is the data. Now it is very common in any big data scenarios. You have to understand your data, then only you can start working with the data. So let me show you the data that I'll be working on. So now we have the data to work with. So there are two set of files. Okay, this is called New York Stock Exchange daily data. This has certain columns. For example, the first column is the exchange name, which is New York Stock Exchange. The second column is called a symbol or ticker. This is the stock name that we are monitoring. Then we have the date. So this is the date column. Then you have opening value, closing value, high, low, total trade volume, and another value, right? So basically this is stock data. So every stock will have opening value, closing value, high, low, total volume sold, etc. And this is a real good piece of data set. It's a public data set because you can do a lot of operations on this data. So this is one data set. The second data set is this. It is a similar data set but with only 4 columns. So this has first the exchange name, NYSE, second the symbol or ticker, third the date, and the last column is dividend. So there are 4 columns. So these are the 2 data sets we will be using initially to understand pig. Now if I go to my desktop, both these data sets are available in my desktop. You can see here NYSE daily and NYSE dividends. So both the data sets are available on my desktop. The first thing you need to understand about pig is that pig can run in 2 modes. One, local mode. 2, MapReduce mode. In this mode, pig will read the data from local file system, transform it, and store it back to local file system. Okay, in this mode, pig will read the data from HDFS file system, transform it, and then what? Store it back to HDFS file system. So, which means you can run pig in 2 modes. There is local mode and MapReduce mode. Local mode means if you start pig in the local mode, it's going to start it, and it will take data from your Linux machine. Basically, it will expect the data from your Linux machine. It will read the data from your Linux machine, right? And it will do whatever transformation you ask it to do, and store it back onto Linux machine, meaning it will not touch Hadoop in the local mode. In the MapReduce mode, the same concept, but it reads the data from HDFS, that is Hadoop, transforms it, stores it back into Hadoop. So MapReduce mode is something we use in production. Local mode is for testing. For example, if you want to create a pig script and see how it works, what you can do, you can run pig in the local mode on your laptop. It'll read data from your laptop's hard disk, transform it, store it back on the hard disk. So you'll just experience how pig works using the local mode. Right? You can also do this in the MapReduce mode. So the first thing I'm going to show you is local mode. That means how pig can read and transform the data and store it in the local file system, right? So in order to start pig in the local mode, all you need to do is just type pig-x local. Yeah, in local mode, it has nothing to do with Hadoop. And local mode we just use for testing, right? So now I have started the local mode of pig. How do I know? I see this prompt called grunt. So grunt is the pig prompt actually, meaning this is the prompt of pig, right? So here I can type my first pig command. So this is how a pig line will look like to you. A line of code, a line of pig script will look like this to you. So what did I write? First of all, you can see that I have written something called dividends, and there is an equal to symbol, this symbol. So whenever you see this symbol, it means it is a relation. Pig works on something called relation. How do you identify a relation? When you see this equal to symbol, that's a relation. So here I am declaring a relation. I'm saying dividends equals load, this is the file, as exchange symbol date dividend. Now this dividends can be anything. Okay, I just called it as dividends. Okay, you can give any name to that. For example, I can say Raghu equals this. works. So here what you give doesn't really matter. I mean, it should be something which you remember. By the way, it is not a variable. Pig doesn't have a concept of variable. This is called a relation, not a variable. So now we say Raghu equals load this file. So does that mean there is some data which is getting loaded? No. Load is an operator in Pig, or a function you can call it. What load actually does is that it will create a pointer to the file. Meaning, now I am saying that whenever I call Raghu, Raghu means this file. And this file has 4 columns. I'm naming the columns exchange, symbol, date, and dividend. And you see, I'm not giving any schema, meaning the data type. All I'm telling Pig is that, you know, Pig, if I call Raghu, give me this file. And I have 4 columns in the file. These are the headers for 4 columns. That's all I'm doing. Now there are multiple ways to write a relation actually, but remember this, you have to start with a relation to work with Pig. So first step in every Pig script is actually loading the data or pointing to the data, because without the data, how do you work? How do you work without the data? Not possible, right? So now I have created a relation called Raghu, which points to this data, right? And you could have also noticed that when I created the relation, nothing happened. I said Raghu equals to load this. Well, that's fine, right? But did something happen? No. Nothing happened, because we call Pig as the lazy operator. Pig, just like the animal pig, is very lazy, right? So to give you an example, let's say you're sitting at home, you with your wife, okay? But imagine you are sitting at home with your wife or with your girlfriend, right? Now your wife comes to you and say that, you know, tomorrow evening, today evening, you have to go out and get something. And she creates a list of things that you have to do. For example, you have to go to the supermarket and buy something. And you have to go to the telephone exchange and pay the bill, maybe. You have to go to the milkman and get the milk. But will you be doing that now? No. Because you are just creating a list of things that you're supposed to do. You are just sitting at your home and your wife says you have to do something, right? So what do? You create a list of things you have to do, right? You will say, okay, milkman, go and get 2 liters of milk. After that, what? Supermarket, go and get groceries. After that, what? Telephone exchange, go and get this. X, you create a list of things to do. But when it is time to do, when it is time to actually go, what you do? You just go out and execute them one by one. That is exactly how Pig will work. So here I'm saying Raghu equals load this data, and I hit enter and nothing happened. Why nothing happened? Because this is like I'm creating a list of to-do things. I'm telling Pig that, hey Pig, this is the data called Raghu. So Pig is going to ask me, so what? So what? If this is the data, what should I do? I'm not going to do anything, right? So just for the sake of argument, we'll keep it as dividends. Okay, so you can change it like this. So see, the declarations are completely dynamic, right? So I changed from Raghu to dividend. So now this will be reading it as dividends. So first I declare my relation. Now I don't want you to pay attention to the syntax, but I tell a Pig, you know, Pig, group dividends by symbol. So dividends is my previous relation. I want to group that by symbol column and store it in another relation called grouped. So now what happened, there is a second statement which correlates with the first statement. And still is Pig doing anything? No, it is not doing anything. It is very lazy. It sits idle. Okay. Then I say, for each group, that is a previous relation, generate the group number calculate the average of dividend, store it in a relation called AVG. So I have typed 3 commands here. These are the 3. Or in Pig's terms, 3 relations, and nothing has happened. Why nothing has happened? Each line is read, and Pig will look at it and see whether it has to do something. Yes, it has to do something, but are you asking for the output? No. Unless you ask for the output, Pig will not do anything. Pig will sit lazy. So in the first line, I will say, okay, load the data. Second line, I will say, okay, group it by the symbol column. In the third line, I will say, calculate the average of every dividend. Fine. But finally, what should I see? I should see the average, like a print statement in Java, right? So finally, you say system.out.println. That is where you see the output, right? So I have not done a print statement for Pig. How do I do a print statement for Pig? I will say dump avg. So dump is a keyword in Pig which basically says execute this relation. Dump means you're asking Pig to do it or print it or show me the output. Now when you say dump avg, it's going to read this line. It says avg is collected to grouped. So it'll go to this grouped. This is related to dividends. So it'll go to dividends. So it starts executing line by line and show you the result. If I hit enter, a MapReduce job will be fired. Pig executes it line by line and will show me the average. And you do have the average here. All the entire stock average is written. This is how Pig works. I mean, I don't want you to understand the syntax right now, but just the feel of Pig actually. You first create a relation called dividends. Then on that relation you do grouping. On the grouping you calculate average. Then you will say dump average. This is one way of doing that, right? So, but there is a problem with this. The problem is that you're typing the commands line by line. You're typing the commands line by line. And the last line says dump avg. Dump is a keyword which we use to show the result on the screen. And avg is your previous relation, right? So if you don't want to do this, you can just quit from here. You can write it as a script. So what I can do, I can create a new file. I will call this file as testing.pig. So what is the name of the file? Testing.pig. So this is how you create a pig script. You can give it any name, .pig. And inside this file, I can just write my commands. So let me just copy paste them. So I just created a file called testing.pig. And if I open the file, it has the same 4 statements we had, but written like this, right? Now what I can do, I can say pig-x local. This means I'm running pig in the local mode, meaning the file will be read from my desktop. My desktop already has the file, and then run the script called testing.pig. If I hit enter, it should execute that. Same thing, and you get your prompt back, right? So either you can work interactively with pig by launching the shell where you have to type in line by line the commands, or if you are an expert, if you're very good at pig, you just put all the commands that has to run in a .pig file and run it. Both ways it is fine, right? So what did we learn? We learned that pig can work in the local mode, right? That means it is reading the data from your local machine and storing it also. Now another thing, if I open this thing, so one problem with this script is that the script will read the data, find the average and show me the result, but it is not storing the result anywhere. If you want to store the result, instead of dump, you can say store average into, then you give a folder name, say April 8. So what am I saying? I'm saying execute the 3 lines and then store AVG into a folder called April 8. Now if I run the script, it should run the same way, but should store the result in a folder on my machine. Done, right? So now if I do an ls, there is a new directory called April 8. And if I go to April 8, there is a file called part R. If I open the part R file, here is the result. So either you can ask Pig to show the result on the screen, or you can ask Pig to save the result in a file. Both ways it will work. April 8 will be the folder name it will be creating. Inside the folder, the part R file will be there. Look at here. See, I'm inside the April 8 folder, right? There is also the MapReduce mode of Pig, right? So in MapReduce mode of Pig, what Pig will do, it will read the data from HDFS, do the transformation, store the data back. In order to demonstrate that, I will use the same example, but my data will be in Hadoop. So let me show you that the same data is available in Hadoop first. So this is my Hadoop, right, Hue, and you see this NYSE daily and NYSE dividends are already available in Hadoop, right? So all I need to do, if I want to run Pig in the MapReduce mode, just type Pig and hit enter. Remember previously you used to type pig-x local. Now you have to say just Pig, and you see the same grunt prompt. But there will be a difference. For example, the same command I can say, I will write it again. I have to say load /user /cloudera / so I have to give the Hadoop path here. I have to give the Hadoop path here, right? Now if I want to store, I can say store dividend into, I can say /user /cloudera / a folder name April 8. So this will start the MapReduce job. It's going to store the file into Hadoop to a folder. So you can see that it is creating the jar file and running the MapReduce job, etc., etc. So the MapReduce launcher is done here. You can see it is 0% complete. So it's a proper MapReduce job because you are running in the MapReduce mode. Done. So you see the result, right? And if you go to my Hue, if I go to my Hue, just go back to the same directory again. It should have created a folder called April 8. Here is April 8, and here is the result file. So my point is that running Pig, the commands and all are same in local mode and MapReduce mode, right? If you want to run Pig, it's same, right, in local mode or MapReduce mode, right? Only difference is that, you know, in local mode, you have to give the input path from your Linux and output path in Linux. In MapReduce mode, give the input path in Hadoop, output path in Hadoop. That is the only difference, right? So now we can look at the schema. Look at what I'm doing. If you carefully observe, you will understand what is happening. So first, let me start Pig in the interactive mode, the local mode. I'm going to start Pig in the local mode. That means I have the file in my desktop. I want to read it and do something, right? So I started in the local mode, and what I'm going to do is two things. So first thing is this. I'm going to say dividends equals load the data as exchange char array, symbol char array, date char array, dividend float. So this is explicit data type declaration, meaning this is usually how you work with pig, because you will have the data and you will know the columns and you will know what data type you want. So what you do is that you will tell pig, hey pig, load this data called NYSE dividends, which has 4 columns, and these are the data types of all 4 columns. If you do this, pig will stick with whatever data type you have provided, just like any other programming language. So here I'm saying that these are the data types I want. And how do you know the data type of a relation? You say describe. Describe dividends. So when you say describe dividends, it will say that dividends has 4 columns, and these are the columns. Now let me do now dividends. Describe here. What I did, I loaded the data saying explicit data type. I said these are the columns, these are the data types. Then I said describe dividends, which will show me the data type for dividends, and it says these are the what data types that we have. Then I said dividends equals load NYSE underscore dividends. Let me just, or you can say daily. Okay, so let's take another example. Or you can say this, and you can say describe daily. So I'm just saying that load the file. I'm not giving any schema. So then if I say a describe, what it is going to tell me? So pig will say schema for daily unknown, because you are not mentioning any schema, right? So now the question is, if I'm just loading the file like this without describing the schema, can I perform some operation on the file? Yes, you can do that. That is the real advantage of pig. And I think no other tools have this advantage. Very less tools have this advantage. I'm going to show you that. So now what I did, I just loaded the file called New York Stock Exchange Daily. It has like 8 columns. I did not even give the column names or data types or anything. And then I just said describe daily, and pig tells me that schema is unknown. But you can transform the data. So I loaded the data, and then I'm saying for each daily. So what is daily? Daily is this data, right? Generate $7 by 1000. So $7 is 8th column. So we represent column with numbers $0, $1, $2. So I am asking pig to divide every number in the 8th column by 1000. Again, I am asking pig to multiply every element in the 4th column by 100.0. Then I am asking pig to extract the first character from the first column. I am also asking pig to subtract the 7th and 4th column elements in every row. Now leave the syntax. So it is using an operator called for each generate, but basically what I'm asking pig is that, hey pig, look at this thing called daily, right? And it has 8 columns. You have not given any column name, that's fine, but it has 8 columns, right? So Obviously, when you load the data, if the data is tab separated, Pig can read. So Pig expects the data which is tab separated. So every column should be separated by tab. If your data is not tab separated, you can give an argument like comma or whatever you have. But by default, my data is tab separated. So when I say load NYSE daily, Pig will automatically identify every column. It's going to name every column like $0, $1, $2, $3. Then I'm saying for $7 by 1000, that means I want every element in the 8th column to be divided by 1000. Every element in the 4th column to be multiplied by 100.0. And substring operation means from $0, that is the first column, I want a substring 0 to 1, first character. And I also want for every row subtract $6 minus $3. That means 7th column minus 4th column. Now what I am trying to tell you is that you are asking Pig to divide every element in the 8th column by 1000. So when you ask somebody to divide something by 1000, that means that number should be an integer. So Pig will automatically cast it as integer, the 7th column. Again, for the 4th column, you are asking it to multiply by 100.0. So when you say 100.0, multiply something by 100.0, Pig will assume and cast the column as double, data type double. And when you say substring, it will automatically understand that you want to extract characters. So it's going to understand that this is char array. Right? But when you say minus $6 minus $3, there can be a confusion because you are asking Pig to do a subtract operation. Now, the subtract operation can be between integers, can be double, can be floating point, right? So for precision, Pig will assume both are floating point and will do the subtraction. Now if I do a dump of this calcs, you can see it will show the result. See, even without giving any schema, it is able to understand your schema. So the first column is integer because you're asking to divide by 1000. The second column is casted as double. The third is char array. The fourth is again a floating point, right? Did you? So I will show you this calc relation once more. Now look at the result. You will understand. So this is what will happen if you do not mention the schema. Ideally, you should mention the schema. So that is another thing. Ideally, for Pig to work on, you should mention the schema. I mean, that is what we do. But in some cases where you don't have the schema as well, you can quickly load the data and transform. For example, imagine you're getting a text file with some 10 columns. All are whole numbers, integer. You can just load it and do all the operations. You don't have to declare any data type. Because, you know, when you say, okay, divide by 1000, it will understand it is integer by looking at by what number you are dividing and cast it as integer. Let us look at the operators or the syntax in writing. Operators in detail. Right? Now, what is the load operator? The load operator will, like I said, create a relation which will point to your data. So if you look at my data that I was using, it is this NYSE underscore dividends or NYSE. So if I open this data, you see this data is tab separated. The separator is tab. And by default, Pig will understand your data if you're using the tab separator. But what if your data is not having the tab separator? What if your data has comma, right? So what you can do is, if you look at this data, this is the Olympic data set, and this is comma separated data. This is the comma separated data. Now what can I do with this data if I want to load it? Very simple. All you need to do is, in pig you say a equals load, say Olympic, using pig storage. Now I'm saying load Olympic, this is my file, using pig storage comma. So you have to say this pig storage if you're having another type of data. Now I can simply, so this is the load operator. So if I say load Olympic only, it will expect the data to have tab separated values. If I say load Olympic using pig storage comma, that means it expects the data with comma. So this is very good if you have CSV files or comma separated values, etc. This is how you can load the data. And just to see whether the data is loaded, do we have a schema? No, there is no schema because we have not mentioned. You can say what? Dump A. It should dump the data. And you can see the data. So you see the data is perfectly loaded. So you have to see this using when you are using the load operator. And we also know this store operator, right? If you want to store the result, so this is the load data, then I can say store A into Hadoop folder name, whatever. So you have to create a folder here and it will store. Dump will show you the result on the screen and store will store the data in a folder. So either you can use the load store operator or the dump operator. Dump operator will show on the screen, which is not so good. If you're having like 1 million lines, it's going to throw all the 1 million line on your screen. Rather you say store, it's going to store someplace. In Hadoop, you can give any folder name which you have access to. Relational operators. Okay, we have something called relational operators, right? So now let me show you a couple of examples for this. So I'm going to load another one. I'm going to create a relation here. I'm going to say load NYSE daily as, I'm just giving the column names here. Exchange, symbol, date, open, high, low, close, volume, ADJ, close, right? So I'm going to load that. Now, the first operator you have to be familiar in pig is the for each operator. So how your for each operator works is that it is going to take every row and apply an operation you are mentioning. So here I'm saying close minus open. So there is a column called close, another column called open, right? So it's kind of like a SQL loop, right? So it's going to apply something like a SQL loop. It's going to go iterate through every record and subtract. What if I want to see whether this is working? What should I do? So I have to dump the operator called gain. So I will say relation called dump gain, and that's it. I can also do much more things. Okay, so now what I did this, right? I can also say C equals prices. I can say for each prices generate $0, $1. And now let me do a dump of C. Did you see what I did just now? I said for each prices generate $0, $1. Right? That means you are just extracting 2 columns. And when I did a dump, what did I get? Exactly 2 columns. So how easy it is to filter, right? I just want 2 columns or 3 columns, You don't have to even cast it. You don't have to say the data type. You just say load for each. That's it. You get. And store it as a separate file. That's it. So this is data transformation. So that is what I'm saying. It is very easy to transform your data. Is this relations case sensitive? That means, okay, A equals load is not same as A equals load. Here I'm saying A equals load abc.txt. And I'm also saying capital A equal load. So small a and capital A are different. So relation names are case sensitive. But I can say either this or this. So the operators like load or for each, either you can use small letters or capital letters, but the relation names are very specific. Now you can also do this. For each operator can be used for mentioning a range. So again, I'm loading the same data, prices, right? And I can do these things. You can say for each prices generate dot open. That means it produces exchange symbol date open, all the columns till open. Or you can say open dot close. That will be open, high, low, close. Or you can say volume dot. That means volume and adj underscore close. So you can mention a range of columns like this. So I say I created a relation called divs. Okay, and I'm loading the same one. And I can say, okay, so here I'm creating a relation, right? And how many columns we have in this relation? Well, it's not called columns in what you say pig. It's called a record. Sorry, it's called a field actually, not a record. How many fields we have in the divs relation? 4. Exchange, symbol, date, and dividends. So we have 4 fields, right? And look at what I'm doing. I'm saying here a new relation in underscore sense. For each divs, generate dividends into 100 as dividend, comma, dividends into 100.0. So this is a bit confusing the way I write it, right? So I'm saying for each divs, that is my previous relation, generate, I want to multiply this field called dividends into 100 as dividend. So what do you mean by here as dividend? I have written dividends into 100.0 as dividend, again dividends into 100.0. It is the field name. See, what I'm telling to pig is, multiply every element in dividends column or dividends, what you say, field, right? And store it as something called dividend. So I'm creating a new column or a new field called dividend. But on the second relation, what I'm doing, I'm saying multiply every element in dividends, but I'm not asking to store it as a new column. So what will automatically happen? A dollar will be created. So if I do describe, see, it has a column called dividend, which is double. The second column is just double. There is no column name, and you will be able to access it by $1. Did you understand that? That means whenever you're performing any operation, you have to say as some column name, right? Otherwise, it will create a column with a dollar notation. Okay, let's go to filter. So in filter operator, I will just load the data first. So it says load dividends as exchange carry, symbol carry, date carry, and dividends float. Okay, and I can say filter divs by dividends greater than, I don't know what's the data we have. See, what did I do? First I loaded the data. So data is loaded like this. NYST dividends as exchange, symbol, date, and dividend. Then I can say filter divs. Divs is my previous relation by dividends column greater than 0.14. I want all the rows where, so you can say some column greater than some value, less than some value, equal to some value. And then I did a dump of D. It will dump D and show me all the records where this column is greater than 0.14. So filter operator will take a condition. Filter will say that filter the relation where the column value can be greater than, less than, something, something. Now that will work for integer, floating number, etc. If you are having characters, for example, in this example, first two columns are characters, right? Third is date, leave it. But first two are strings, right? So what I can also do is that I can say what? Filter divs by symbol, which is my column name, matches cm dot star. So that is like matching with an expression. So I want all the records where in the symbol column it starts with cm. If I do a dump, see all CMO, CMA, CMS, CMI, CMK. All you need to do is that filter a column, either a regular expression or you can say greater than, less than something. That is the filter operator, right? So that's the filter operator. Now you also have a very important operator called grouping operator. Okay, so this grouping operator is very, very, very important in case of big. Just see, there are so many operators actually. Let's look at grouping first. Anyway, so first let me load the data. Now you can also load the data like this. Look at here. I'm saying, load NYSE daily as exchange and stock, meaning I'm just using only two columns. I'm just using only two columns. So it will load only two columns, right? I will say group daily by stock. So grouping is a very common operation. We see grouping in SQL, grouping in many places, but grouping works in a very different way in your pig. So all I'm seeing here is that I want to group the previous relation, which is my data actually, by stock name. So you will expect all the stock names will come together. Yes, it will come together, but in a very specific format. If I do a dump of grpd, okay, so this is the grouping result. Or let me see whether I can get any other data set. So I can say A equals load Olympic, okay, using pig storage comma. This is the Olympic data set. And since I did not mention any schema, it's going to load with default schema. Okay. Now I want to access, let's say 0, 1, 2. So I can say B equals group A by 2. So what I'm saying, group A by $2. So what is $2? $2 is the country. I want to group the data based on country. When I say dump B, this is what you will be getting, and this is probably what I want to show you as well. Yeah. So look at this. You have the country name. So let's see a country where there are very less athletes actually. So it's easy for us to identify, right? Look at here. This is one record of grouping operation. This is one record. So here it will have two parts. One is the grouping key, which is the country. So I'm looking at the country called Dominican Republic. Second part is all the records which belong to Dominican Republic. Look at here. So there is one guy who is in Dominican Republic, and there is another guy, there is another guy, there is another guy. So this is how the grouping result will happen. So my point is, when you do grouping operation, the result is like a key value pair. The key will be your grouping key, in this case the country, in my record Dominican Republic. The value will be a bag which contains all the records matching with Dominican Republic. Same way you have Trinidad and Tobago. If you look at here, another country, right? And these are all the values of Trinidad and Tobago. So look at the first element, Trinidad and Tobago. That is the grouping key. Then in a bag, you have all the athletes who are in Trinidad and Tobago. So this is one record, one athlete here, right, from Trinidad, then another athlete here, etc., etc. So what I can then do is, for each B, generate group. I can say something like this, and count, let's say A equals load Olympics. Then I said where is B? B equals to group this. Then I can say C equals for each B, generate group, comma. Then here we are basically what we are doing is actually counting the data. Count. Then I can say dump C. So this statement means we are just loading the data. Fine. Then what did we did? I said group A, which is my original data, by $2. $2 is what? My country column. Then in C, for each B, generate the group name. So I want the country name and count A. So what will be A? A will be my original data, right? A is where I'm loading every record. So it's going to count. So basically, this is going to give me a count of every country. See, New Zealand, there are 51 records. North Korea, there are 21 people. So grouping is very useful in doing things like this. Grouping is very useful in, and for NYSE, you can do the same thing. You can say load NYSE daily as exchange and stock. That means I'm loading exchange and stock. Group the relation called daily by stock. Then I can say for each group, generate, so previous relation group, and then count the daily. So it will count how many are there. So this is how we do the grouping operator. You can also say order by. I say daily equals to load this, right? And I can say order daily by date. So what this will do, it will look at the date column and order that. By default, it will be in the ascending order. You can say descending as well, right? So, so by default, it will be in the ascending order. Okay. You can also do multi-column ordering. I can say order daily by date, comma, symbol. If you want, you can do that also. Okay. And you can say order daily by close descending, comma, open. So this close field will be descending, other will be ascending. Yeah, so here is join operator. So if you want to do join, you can simply load the data and you say devs load as exchange. You can say join daily by simple date, devs by simple date. You can do single column join or multi-column join. Let me just show you this. So I will load the data called daily first, and then I will load the data called divs, and then I can do a join. So this will be normal join, right? You can also do left outer, right outer, full outer, whatever type of join you want. So here I'm saying join daily by symbol comma date, divs by symbol comma date. If I dump JND, it should have the multi-column join result. See? So this is the join operator. You can also say limits. Okay, so I can say load the data. So here I'm saying load the data. I'm not giving any schema. I can say limit. I can say limit divs 10. Okay, now if I dump first 10, what's going to happen? It's going to show me only 10. So what did I do? Limit divs 10. So the limit operator will limit how many records will be shown. How do I say? Random selection. You cannot say which to limit. So the limit operator actually limits your data, right? What a word count program. Now the first thing I'm going to do is that I'm going to run the word count program, right? And just ensure that it can actually do the word count. We will look at the script later. First, we will run the script and see whether we are getting the result. So I have the script. This is the script actually, which will do the word count for us. And I will explain the script later. As of now, we just have to run the word count program and see what is going to happen. This is the script which has this word count.pig, and all I need to give is the file name, and the file which will be analyzed is this file. This is the file which will be analyzed. Mary had a little lamb, its fleece was white as snow, and everywhere that Mary went, lamb was sure to go. This is a nursery rhyme, right? So we will do the word count on Mary had a little lamb. So this is the sample data that I have for analysis. So in my script, I have to give this data. So what I'm going to do, I'm going to open my script and I'm going to say that this is what I want to load. And then I'm going to run this first. I'm going to say pig-x local word count.pig. So this is how you run the script. So I'm just going to say that, hey, pig, run this for me, word count.pig, and just show me what it is there, right? I'm just going to hit enter and see whether we are getting the expected result. And we are able to do the word count very well with the script. So it is just a 4-line script that we have, and it actually does the word count. Now compare this with your Java program, the MapReduce program, which was doing word count. It was very complicated to write, right? So this is quite easy to do it. So now, all right. So now let's see what is going to happen. I'm going to just explain the script. Rather than explaining the script, what I will do is that I will run it line by line. If I just run the script, you will not understand anything. So what I'm going to do, I'm going to run it line by line. So to do that, I'm just going to start. Let's analyze the script. This is the first line in my script, and I don't think it needs any explanation. All I'm doing is that I'm loading the data as a single column, a single field. So I'm calling this entire 4 lines of data as a single column or a single field. The name of my column is line. The name of my column is line. Now I'm not mentioning any data type or anything, because since it is a word count, I really don't know what will be the data that I'm getting in. I don't know. So I'll just say that load this data as line. So line is my column name. What is line here? It's a column name, basically, right? Then what I do is I do this. So I will create another relation called words. For each A, that means for every line in my data, generate, tokenize the line. So what is line here? Line is the column. So line means, the column which represents your data. Tokenize is a function or an operator in Pig which will extract every word. So basically what tokenize will do, it will pick every word. Flatten means it will create a row for every word. So basically when you say for each A generate flatten tokenized line, what it is going to do is that it's going to read every line, extract every word, and for every word it's going to form a row. So basically it will arrange all the individual words in a single column. As word means that will be my column header. So think about them like column header. Here line is your column header for your original data, and this is the column header for the transformed data. Now if I do a dump of words, so I'm dumping this relation, okay? So if I'm dumping this, this is what you get. So what that tokenize flatten will do, it's gonna pick every word and arrange them in a column like this. So now I have all the words that I want to count, but I know that Mary is repeating here. So here is Mary in the first row, and again Mary is here. So Mary is repeating 2 times. So if I want to count Mary, I should group them. So the next step will be grouping my data. So I will say that GRPD group words by word. Words is my relation, word is the column name. Okay. Now don't get confused. Words is my relation, word is the column name or column header. So I'm saying that group the relation called words by the column word. Now the column word has all the data. What data? This data. So this is the column which contain word actually. So remember the grouping operator in Pig. So I know that this is my data, I mean the previous relation, and I know that I'm doing grouping. I know that I'm doing grouping, but being a Pig developer, what you should know is how the output of grouping will look like. So to do that, I will do a dump of this relation called GRPD. I'll take a dump of this, and this is how it looks like. Look at an element called Mary. Now this element or this record called Mary has 2 columns. First column is the grouping key, which is Mary. Second column is a bag which contains a tuple, I mean not a tuple, the repetitions of Mary, right? So first is the grouping key, second is the actual number of repetitions of Mary. Same with lamp and snow, sure, they just repeat only once, right? But this is what you need to understand. Now what I need to do is I have to say for each GRPD. So GRPD is my previous relation. For each GRPD, generate group. Generate group. So what is group here? Group will be this first column. And count words. What is words? Words will be this column. So if I apply this, what is going to happen is that it will generate group called Mary and then count 1, 2. 2 times Mary is repeating. Now remember that words is your original relation, right? So this is words. The column called words, remember, so that is where the column which contains all this, data, right? And I grouped it. Then I'm saying that count these words. So basically these words, this Mary is actually part of words, right? So I just want to count this 1, 2, right? And this is group. So if you look at here, see, group words by word, right? For each generate group. So generate group means it will generate the grouping key and count it. Right now, if you do a dump of CNTD, you have the final result. Right? So always remember the result of a grouping operation has two parts. One part is the grouping key. The second part is the elements that are repeating. So in this case, Mary will become the grouping key and Mary, Mary will be the result. So all you need to do is that, for each generate the group and then count that relation. So it will count how many times it is happened. So this is how you write a word count program in Pig, weather data analysis using Pig. So basically this is string operations actually what we are going to do. Now let me first show you the data, then I'm going to explain what we'll be doing. So this is the data which we are going to analyze. And it doesn't look nice. The data doesn't look nice. Why it doesn't look nice is because it is the weather data. So what do you mean by weather data? So these are the type of data that we get from sensors and all. So this data basically has temperature readings and lot more than that, but we are actually interested in temperature readings, right? Now, if you look at the data, you may think it doesn't have a structure, but it does have a structure, right? But you cannot really put it into a column format and all as of now because the way it is given is kind of like very funny, right? So what we are going to do from this data is this is kind of like unstructured data, semi to unstructured data. We are going to use Pig to extract the information that we want. So I just started Pig in the local mode. And if I look at the commands that I'm doing, okay, so first thing that I'm doing is that, so what's the file name that we have? Let me just check. It is weatherpig.txt. So first thing I'm going to do is that I'm going to load the data. I'm going to say A equals load this data using text loader as data and char array. So basically I'm going to declare this as char array because I want to perform the substring operation. I want to perform the substring operation. So I'm going to declare this as char array for the time being. All right. So then what I'm going to do, I'm going to say for each A generate trim. So trim is an operator which you can use in pig basically to trim, and then you can say substring from this column called data 6 to 14, 38 to 45, 46 to 53. So what does this mean? So basically I want to extract character position 6 to 14. So where is that? 6 to 14. 0, 1, 2, 3, 4, 5, 6. 6 to 14 will be this data. So since I'm loading it as char array, you know what it will do is that it's gonna get this, right? And this is going to be the date column. So this is the date actually. You can see it is 2013 January 1. Same way I'm gonna extract from 38 to 45, which is minimum temperature, 46 to 53, which is maximum temperature. Now you might naturally ask me, how do you know that this is the data? You have to ask the guy who is giving you the data to understand the data structure. Right. So, you know, once I extract that, basically, you know, I can actually dump off this and see how it looked like. Dump AF. And this is how my data looks like now. So now the data is extracted into the date. So date is there, comma, minimum temperature, comma, maximum temperature. So I have this format now for my data. But this is not I want to do. So my use case is different. So what I'm going to do now, I'm going to store this data. So I will say store the data into a folder, right? So how do I know whether a folder is created? So if I do an ls, there is a new folder called data9, right? If I go to this folder called data9, do an ls, there is a part m file. If I cat into this part m file, I have the data. So basically I stored the data in a folder. Okay, so once your data is stored in a folder, what you can do is you can give structure to your data. I can say that possibly this will be data9. I can say load this data which we just extracted using pig storage comma, because the data is comma separated, as date, minimum, maximum. Now you are creating schema for this data and loading it into the relation called S. So now this relation called S will have 3 columns which you have extracted from the raw data, and these 3 columns are even having specific data types like char array, double, right? So now I have the date, the maximum temperature, and the minimum temperature. And what I can do, very simple. If I want to find the hot days, what I can do, I can say x equals filter s by max greater than 25. So I'm saying that filter the previous relation, okay, by the column called max greater than 25. So I'm assuming that any day which is having a temperature of more than 25 is a hot day. So now if I dump x, I will get all my hot days. So look at this. On the last column, all are more than 25, the max temperature. You can also say min less than 0. You can find the cold days actually. So I can say x equals filter s. S is my previous relation by min column less than 0. Now if I do a dump of x, I should be able to see. So you see the second column in this result, right? All are less than 0, right? So basically that is the condition I have given. Right? You can also do a lot of other things. Now these are more towards the statistic stuff, right? This is more towards the statistic stuff. So basically if you want to find out the hottest day, what you do is that you do a group S all. So I will say, so normally you say group S by the date column, by the minimum column, by the maximum column. But here I'm saying group S all. This is a very special grouping I'm doing. See here. So this is what I want to show you. I'm saying group S all. So normally you say group by. So now if I take a dump of H1, the result will be very interesting. So this is the result. See, group S by all actually means it will create only one result. The key here will be all. Can you see this? The key is going to be all. The values are the entire data that you have. So when you say group S all, so you are asking to group by everything, which is kind of like impossible. So what Pig will do, it will create a key value combination in which the grouping key will be all. All means everything. And the value part will be every element in your relation. See? So this is what happens. And then what I'm doing, I'm saying, you know, for each H1, so that is my previous relation. For each H1, generate max S dot max as maximum. So I'm declaring a new column here. So that is why I'm saying as maximum. I'm using the max function. Okay, S dot max. That means in this, I'm going to find the maximum. So then if I do a dump of this relation, I should see the max value. So that is 34.1. This is the max value that I'm getting. Now, so I'm finding the hottest day. So then all I need to do is that I have to say filter S. S is my original relation by max, that is a column, equals I dot maximum. So I dot maximum will be this. So basically finding the maximum and filtering the data. I want the record where this 34.1 occurs. So that is basically if I do. So if I do a dump of X, this will show me the hottest day. This is the hottest day. 2013, 12th June, maybe. It's a bit complicated to understand, but I guess you got the grip of it. So first I will group S by everything. Then I'll say for each H1 generate maximum, you know, S dot max as maximum. So this will give me the max value. Then I will say filter the S by max equals I dot maximum. So it will show me only that. Same way you can find the coldest day as well. So same way you can find the coldest day as well. Okay, you can just say max of the column and then do the filtering also. Here I wanted to show you this group as all, so that is why I used it this way. Okay, so you can also, you know, say that instead of doing this, you can say for each, you know, S, generate max of the max column and filter that by I dot maximum. That will also work. S dot max actually means, S dot max means in the relation S, you know, the max column. In the relation S, the max column. So what the only thing here we are doing is group S all. This will create a result wherein the grouping key will be all and the values will be everything in your, you know, S. So S is your basic data, right? And then I'm saying for each H1 generate the max. Max is my operator. S dot max. S dot max is my column as maximum, right? Then I'm saying that filter S by max equals I dot maximum, right? So this is the way I have written. I suggest you to try a little bit different also and see how it gives you the result. What is the requirement of Hive? You have this guy called RDBMS, right? So let's say you are using MySQL and you are also using, let's say, MS SQL, that is Microsoft SQL, right? And you are also having Oracle. So your organization, let's say, uses 3 databases, right? Now, why are you using 3 of them? I don't know. Maybe you're using Oracle for transactional data, payment, etc., etc. Maybe you're using MySQL to store product catalogs, etc. Maybe you're using Microsoft SQL for some other purpose. So, but just assume that you are having 3 databases, right? Real-time databases. Now, these guys are called RDBMS or database, right? And we also call them a name called OLTP. They are online transaction processing systems. Now, I know that this is too basic, but I'm just trying to give you an idea. So every organization has multiple OLTP systems, maybe single OLTP systems deployed across the world. Now, your manager comes to you and says that, hey, so let's say I'm the employee, so my name is Raghu. Hey, Raghu, we want to do something. You know what? We want to just collect the data from all these databases, and I want to create a nice report and show to my CEO so that I can get a free holiday. So I can impress my CEO with my nice report and all, so I can get a free holiday. Maybe you get a salary hike also. So why don't we pull all the data from these systems and put it into a place and practically create a report out of it? Now, you have guys known as business intelligence guys, BI. So business intelligence is a part wherein you get data and you make sense out of the data. Given any type of data, you can create nice charts, pie diagrams and reports, etc. using business intelligence. There are a lot of BI tools available in the market. For example, we have Pentaho BI, many tools are available, right? So I thought like, all right, so let me do one thing. Let me take a business intelligence tool which can create nice reports and all, and let me install it on my Oracle. Let me also install the tool on Microsoft SQL and MySQL, all 3 databases. But this doesn't make any sense. Why it doesn't make any sense is because you see all these databases are real-time databases. That is why we call them as OLTP. And they are serving your customers in real time. I don't want any unnecessary load on these databases, right? So if I install a reporting tool on top of it and start digging the data, it may impact the performance of these databases. So I don't want to do that, right? So what I do is I bring in the elephant in the room, and that is, my friends, your data warehouse. We call it as DW. You can also call it as OLAP, Online Analytical Processing System. So using ETL, you bring data from your RDBMS systems into your data warehouse. So technically what is happening is that using ETL tools, ETL is extract, transform, load, right? You can take data from your RDBMS systems and dump it into a place called a data warehouse. Now, data warehouse is a fancy term actually. It's not a fancy term, it's a technical term. What is a data warehouse is nothing. Data warehouse is a place where you store, first of all, massive amount of data. Point number 1. Point number 2, this data is ready to be accessed, ready to be reporting. So if I have a BI tool, my BI tool can be directly installed on my data warehouse and it can produce nice reports, etc., etc. And a data warehouse is internal to your company. You don't have public access, because this is your private storage. I'm collecting all the data and dumping into this guy so that this guy holds the whole data, and now I can do whatever I want with my data. Very simple. Organizations were doing this for quite some time. If you go to any enterprise organization, what they do is that they will have multiple OLTP systems. They keep on collecting the data, nightly cron jobs or whatever you want, and then dump it into a data warehouse, right? Now the data warehouse will hold historical data. So this guy has historical data, meaning it will have this year data, last year data, last to last year data, a lot of data, right? And on this data, you can do whatever analysis you want. Very simple. So data warehouse is a place where you store massive amount of data ready for analysis, and you do not typically have public access to this thing, right? And that is. Now, if you look at the players in data warehouse, you have many companies who are doing this. There is somebody called Teradata, which is a major player actually. You also have Oracle Exadata. These are all data warehousing companies, okay? You have SAP HANA, you have Netezza, Greenplum, etc., etc. These are all data warehousing companies. So in your organization, if you want to implement a data warehouse, what you do is that you go to, let's say, Teradata and say that, hey, Teradata, you know what? I want to implement a data warehouse in my company. So Teradata says, alrighty, take this and go. So they will give you practically an appliance, like a box, which you install in your company, and then you can load it with data. It stores, you analyze the data. So the question is, why am I talking about this? What is the big deal about this? See, there is no big deal about this, but so far, whatever I was discussing is how the world was working. Now, everything seems nice here. Okay, nice. We have OLTP systems. We take ETL. We dump the data to data warehouse. We produce reports. Nice and happy. But only one major problem. And the problem is this. Dollar, dollar, dollar. Money, money. Okay. The problem is cost aspect. Data warehousing is a costly affair, to be honest with you. Right? For example, if you want to implement a Teradata solution, it will cost you millions of dollars, practically speaking. It is not so easy. Also, it is not so cheap. People who are working in the data warehousing background will be able to comment on this, but data warehousing is a costly affair, right? So that is the backdrop. That is the history that we are talking about. Now enters Hadoop. So here is your Hadoop cluster. So what is this? Your organization has a Hadoop cluster. Now imagine your organization already has a Hadoop cluster. Fine. What is the problem? In a Hadoop cluster, obviously you can store big data. Right. But what happened was that somewhere in 2006, the company called Facebook got interested in Hadoop. So Facebook was dealing with this big data problem. So basically, Facebook was in the growing stage in 2005, 2006, etc. And Facebook was getting a lot of users at that point in time. And Facebook was thinking that, you know what, everything is working fine, but we really don't have a solution for storing big data and analyzing big data. And Facebook was running completely on Oracle. Oracle was their prime backend actually, and Python. Python plus Oracle, that was Facebook's initial architecture, right? Now, somewhere in 2006, somebody told Facebook that, hey, you know what? Why are you so worried about storage of data? There is something new in the market called Hadoop, and if you implement the Hadoop cluster, you can store unlimited data practically, because Hadoop is naturally the solution for big data, right? So Facebook got interested in this idea and they immediately implemented a Hadoop cluster. So practically speaking, the entire data that Facebook was storing and analyzing, they moved into Hadoop. But what was the problem? Back in 2006, we were at Hadoop version 1, or the old Hadoop, or the original Hadoop. And you know what? The original Hadoop had only MapReduce. That means if you want to interact with the data in a Hadoop cluster, the only way was that you must write a MapReduce program. Right? You have to write a MapReduce program. This became a problem for Facebook because every day Facebook needed to fire 70,000 queries, SQL queries. The requirement of Facebook was that every day they had to fire 70,000 SQL queries on their data. And this was working when they were having Oracle. Even though it was slow, they were able to somehow manage. Because Oracle is a typical RDBMS, you can easily write 70,000 queries. Now what happened? All of a sudden, the whole data is moved into Hadoop, no more Oracle. So the developers at Facebook faced a serious problem. The problem was that now the entire data is in Hadoop. And Hadoop doesn't understand SQL. Hadoop never understands SQL. What Hadoop understands? Hadoop understands MapReduce. And if you want to write a MapReduce program, you have to learn Java, you have to write your program, you have to compile it, create a jar file, deploy it. It's not easy. If you're a SQL developer, trust me, learning Java is not going to be so fun for you, right? Because SQL developers, we tend to be, more towards the SQL side of the spectrum. We don't really are not programmers, right? So all of a sudden, all the employees in Facebook started complaining. They said that till yesterday, our SQL queries were working on the data. Today, when I write a SQL query, I'm not able to run the query. What happened? So Facebook said, guys, we just moved everything into Hadoop. Well, that's not justice. That's not just, right? So in Hadoop, you cannot run SQL queries, or you were not able to run SQL queries. Then what was the alternative? The alternative was to write a MapReduce program for a SQL query. And that's practically madness, because for a simple select count star query, you have to write 100 lines of code in Java and compile it. And imagine 70,000 queries. So what Facebook did is that they thought, all right, we need a solution for this. We have a lot of structured data in Hadoop, but unfortunately, our developers are not able to access the data. So what we can do? And thus, Hive was born. Hive was created by Facebook. Later, they donated Hive to Apache as a top-level project. But the first Hive version rolled out from Facebook. So the next big question, what exactly is Hive? Imagine you are storing some data in Hadoop. Storing structured data. Let's say you're storing a data called sales.txt. A text file called sales.txt. Imagine. And imagine this text file has a structure like, comma separated values, imagine. So they are having order number, product ID, blah, blah, blah. It's a very big file actually. You store it in Hadoop. Now, if you want to analyze this file, you can write a MapReduce program. Or what you can do, you install Hive, right? Now Hive will give you a shell or a command line. You write SQL on the Hive's command line, right? You say select count star from this table. You write a SQL on Hive's command line, hit return, meaning run the query. What Hive will do, it will convert your query into a MapReduce program, run it in the cluster, and show you the result. That is Hive. Hive is a SQL interface on Hadoop, and it is the default data warehousing framework on top of Apache Hadoop. So what is a data warehouse? A data warehouse is nothing, a huge storage with a SQL interface. Data warehouse is huge storage with SQL interface. Now you already have Hadoop, which is huge storage. You install Hive, you get a SQL interface. You practically create a data warehouse with zero investment. That is the advantage of Hive. Hive is free. You just install it. You can start writing SQL, and you can access structured data using SQL. You can do all your regular operations, creation of tables, left outer join, right outer join, group by queries, blah, blah, blah. That is Hive. Now, what is the difference between Hive and HBase? Now, Hive is what we are seeing right now. HBase is your default NoSQL database on top of Hadoop. But remember, HBase is the default Apache NoSQL database on top of Hadoop, right? The real question is that why somebody should use Hive? You should use Hive. Say, for example, I don't want to learn Java. I don't want to learn MapReduce. I'm not a programmer. I know SQL. Then Hive is your choice, because it just understands SQL and it will automatically convert that into MapReduce, so that you don't have to sit and learn Java and MapReduce. You write your logic in SQL and it works. Imagine you have an Android mobile phone, right? Now what happens is that in the Android mobile phone, when you're buying a mobile phone, obviously, right, you get a default calling option, messaging option, etc. You can call people, you can text people, you can do a lot of things with an Android mobile phone. But you can also download apps. For example, if I want to catch a taxi, I will download and install Uber. If I want to check WhatsApp, I will download and install WhatsApp. Similarly, Hive is a tool which you have to install on top of Hadoop. So that is why it is called as an ecosystem tool. Ecosystem tool means tools which can be installed on top of Hadoop. Think about Hadoop like your Android operating system, and Hive like Uber app you're installing on top of that, right? So Hive can talk to Hadoop. It gets installed on top of Hadoop. Point number one, right? Now, another point. Where is Hive? right? So the first question is, where is Hive getting installed? Is it inside the cluster? Is it outside the cluster? Is it on top of my head? I don't know, right? Where are you installing Hive? So I have a Hadoop cluster, right? Now the point you have to understand is that Hive doesn't have any storage. Hive doesn't have any storage. For example, let's say you're copying a data. So I'm copying a data called, let's say, transaction.xls. It's a spreadsheet. I'm copying a file called transaction.xls. Now what happens in my Hadoop, this gets divided into blocks in data nodes. We are all familiar with this, right? When you copy the data, what happens? The data gets divided into blocks on my Hadoop, right? So in Hive, when you say create a table and load the data, Hive will refer to this data which is lying as blocks on your data nodes. It doesn't have its own storage. Very important point. So Hive is just giving you a projection of your data. Your original data is lying as blocks in data nodes, and when in Hive you say create a table, you're just giving a structure to the data so that you can see the data in the form of a table. Clear? So Hive doesn't use any storage, right? The second point you need to understand is that if I am sitting here, okay, and I have a laptop or a desktop, Hive is a client-side application. For the time being, I will explain more about this, meaning Hive gets installed on your laptop, not in the Hadoop cluster. Now there is a slight variation to this, but for the time being, let's assume like this. That means, and your laptop is obviously connected to the cluster. You will have Hadoop client libraries, so your laptop can access the Hadoop cluster. So Hive is a client-side application. That means you install Hive on your laptop, open the Hive shell, you will say create table, and you will give some schema, whatever schema you want. Okay, then you will say insert the data into the table. Now what is this data you are inserting? This data is these blocks, that's what I'm saying. You are not inserting anything. When you say insert the data, Hive will just refer to these blocks in your Hadoop. And then you say do a group by query or some SQL query. What Hive will do, it will generate the jar file, right, and send it to the Hadoop cluster. So for Hadoop, there is nothing called Hive. For Hadoop, it is just a MapReduce program. Let's understand that Hive is a client-side application. That means you install Hive on your laptop. And why are you installing Hive on your laptop? Because you don't know MapReduce. And you are a SQL developer. And you know that there is structured data in Hadoop. You want to create a table out of the data and do the queries. So you install Hive on your laptop, say create a table, load the data, write your query, hit enter. Hive will automatically write the equivalent MapReduce program, create a jar file, send it to the cluster. So from the point of view of the Hadoop cluster, it is a regular MapReduce program. It's not Hive. Hadoop doesn't understand Hive. Hadoop understands MapReduce. So either you can write MapReduce, create a jar, say run. Or you write in Hive, Hive is also going to create a jar and say run, same thing. That means Hive doesn't have its own storage or anything. It is just accessing the data in Hadoop and giving a projection so that it is easy for you to work with. Now, you cannot work on blocks or data nodes and all. If you can see your whole data in a table, it's easy for you to write queries, right? And that is Hive giving you. It is giving you a projection of structured data stored in Hadoop. That's it. So Hive understands your SQL, even though Hive's language is called Hive Query Language, or we call it as HQL. It is pretty much similar to SQL. So that means if you're a SQL developer, you know SQL queries, you can easily start working on Hive. Introduction of Hive. Hive is a data warehouse infrastructure that is built on top of Hadoop. Hive provides a mechanism to project structure on the data using SQL-like language called HiveQL. Hive uses MapReduce and HDFS for processing and storage retrieval of data. Now that we understand, the data is an HDFS, processing is done by MapReduce. Now there is a small point here. It's not exactly MapReduce, right? But for the time being, let's keep it as MapReduce. The advantages of using Hive, it can be used as an ETL tool in the sense you can bring data to a Hive table, modify the data, store it as permanently. It provides capability of querying and analysis. So Hive is actually used by the analyst community who is very good at SQL, can handle large data sets, and you can do filters, join, group by, all these SQL queries on top of map and reduce. Now, if you ask me, can I see the MapReduce code created by Hive? No, you cannot see. So the MapReduce code created by Hive is not visible. You will just get a jar file. You won't even see the jar file. You will see the jar file running, right? Now, the most important point you have to remember is that Hive is expected to be slow. It is slow because ultimately it is MapReduce. It's not like your Oracle or MySQL or something, because in any RDBMS systems, typically when you write a query, you will expect the results within microsecond. In Hive, when you write a query, sometimes I have seen queries taking 4 hours, 5 hours. Why? Because, it's just an illusion. Where not to use Hive. So this is a very important point. Where you should not be using Hive. Hive should not be used if the data does not cross gigabytes. That means if you are not having big data, why are you using Hive, right? You can stick with your traditional tools. If we don't find schema or bringing in schema is difficult or not possible. Now the point is that when you access Hive, you have to create a table. Hive works on the concept of databases and tables, right? And whenever you're defining a table, the table should have a schema. Now, if your data cannot fit into the table, there is no point in loading the data. Let's say you're getting some type of data. Let's say you're getting text data, raw text data, right? Now, in that data, you're not able to find a structure to the data. Imagine, I'm just saying you imagine you're getting raw data, plain free-form text, right? So in free-form text data, how do you find a structure? You cannot find a structure. That means you cannot use Hive on top of that data. So you have to use Hive where you can find some structure to the data. Maybe you have comma separated values, space separated values, column separated values, something, or JSON files, XML files, even semi-structured data. They can all fit into Hive. Now the next case is if we need response in seconds and low latency applications. I told you Hive is expected to be slow. And if you are looking for a faster solution, don't use Hive. If RDBMS can solve, don't invest time in Hive. Very important point. Hive is not a replacement for RDBMS or something, okay? Because RDBMS systems are real-time systems and Hive is not something which can replace them. If your RDBMS can solve most of your problems, then don't use Hive. Hive is specifically for huge amount of structured data. Say you want to create a table, size of the table is 3 terabytes. Very good, do it in Hive, query the table. Your SQL will be very easy. Even though it takes some time, you will get the result. That is where your Hive's use case will come. So think about Hive like a translator. It's a translator. You write SQL, it speaks MapReduce to Hadoop, right? And Hadoop gives the result, it shows as a table to you. So for you, the developer, everything is SQL and table. For Hadoop, everything is MapReduce. And Hive stands in the middle. Now, what is the similarity with SQL and difference from SQL? Hive is very similar to SQL-like queries. It is based on actually SQL 92 framework, and it is safe to say that its functions are mostly same. What is the difference from SQL? The major difference is that Hive query executes on Hadoop rather than traditional database. That means you cannot install Hive outside Hadoop. It works only on HDFS. This allows Hive to scale to handle huge data sets, which cannot be done by RDBMS. The internal execution of a Hive query is via a series of automatically generated MapReduce jobs, right? So the next question naturally you will have is that, oh, I understand Hive, but can I fine-tune Hive? What about performance? Can I improve the performance? Can I do something with Hive? Yes, you can do. Now all Hive queries will be converted to MapReduce job. So why can't we write MapReduce ourselves? So this is one question people ask. See, Hive is converting everything into MapReduce. So why don't you just write MapReduce for God's sake, right? Why are you using Hive? Understanding the internals of Hadoop framework is must to write MapReduce. SQL engineers can quickly write Hive scripts. Now, if you want to write MapReduce, right, you have to learn Java or Python or Ruby or C#, right? Then you have to implement your logic or using MapReduce framework. You have to write your custom mapper, custom reducer, package it as a jar file, resolve all the complexities, errors. Now here, you don't have to do any debugging, anything. Create a table, write your query, and it just works. That is how it works. So the next point is that now talking about the real world. Okay, so let's suppose you learn Hive in our Intellipaat course and you master Hive. And what did I teach you? I taught you that Hive is a SQL interface to Hadoop. Fine, you understand that, right? And then you go to a real world project, okay? And then you go to the project and say that, you know what, I'm an expert in Hive. An expert in Hive. I know Hive really well. You want to say to your project. And these guys are going to tell you that, you know what, you can use Hive or you can use Hive plus this. You can use Impala. You can use Spark SQL. You can use Phoenix. What did I just do? I just blew your mind out of proportion. So when you go to a real project, in a real world project, and you ask them, okay, I have data on Hadoop, give me a SQL tool, they will either give you Hive or give you Hive plus this, or give you Impala, or give you Spark SQL, or give you Phoenix. And you are like, oh my God, there is only Hive that is a SQL interface. Now I am in a dilemma because these guys are talking about this, Impala, Spark SQL, Phoenix. And trust me, if you write a SQL query, it will be executed the same way in all these platforms. You write a group by query, Hive will execute it, Hive plus this will execute it, Impala will execute it, Spark SQL will execute it, Phoenix will also execute it. So the real question is, what are these different tools? Right? So this is some real world info to you guys, right? See, Hive is the original tool. This came first, right? So Hive is the first Avenger. So this is the first Avenger. So this is the first guy who came into the world, right? So when Hive came, everybody was happy. So people said, all right, fantastic. Now I got SQL interface. I can write a query, and you know what? The query executes nice. But over a period of time, people didn't really like Hive. People said like, all right, Hive is great. But the problem is that the queries are damn slow. You know, the other day I wrote a query, it took a day to give me the result. I don't really like Hive. We need something else. That is when the company called Hortonworks started proposing Hive and Thais. Now what happens here is that if you access a Hortonworks Hadoop cluster and you write a Hive query, say execute, the Hive query will be converted into Thais, not MapReduce. So original Hive is Hive plus MapReduce. Hortonworks Hive is Hive plus Thais. So what is Thais? Thais is a framework, Apache framework. Probably if you're interested, you dig deeper. Well, Thais is created to make MapReduce faster. So I don't want to get into details of this. I'm just giving you some extra information. For the time being, understand that Thais is a framework which is built to overcome the problems in MapReduce. MapReduce is ideally slow. MapReduce is normally slow, right? So some guys built something called Thais, and Thais also uses mappers and reducers and all, but Thais is much faster than your MapReduce, right? So Thais is a Hindi word. It stands for speed, and it is created by Indians. It is the next level of MapReduce, you can say. So what Hortonworks did, they said, see, what Hortonworks did, they said, why don't we club Hive and Thais so that queries are faster? Are you getting the point? So if you are on a Hortonworks cluster, you write a Hive query, say execute, you will see a Thais job firing. You will never see a MapReduce job firing because Hortonworks promotes Thais. Even though Thais is Apache open source, Hortonworks says they promote Thais, and they say that's their queries are faster. So your first Avenger, original Hive, is damn slow. Now Hive plus Thais, this guy is interactive. Interactive query means it is faster but not real time. So if you are writing a Hive query on a Hortonworks cluster, it uses Thais as an execution engine, and it is faster, but it's not real time or something. It's kind of like faster. So when Hortonworks started this, even before that, there is another company called Cloudera. There is a company called Cloudera. Cloudera, what they did, they invented something called Impala. Impala is again built on top of Hive. Impala is a SQL interface, but what happens if you write a SQL query on top of Impala, it will run it using a daemon called Impala D. It doesn't use MapReduce, it doesn't use Thais, it uses a proprietary Impala D to run. So this is promoted by Cloudera, and this is also interactive. Now Hortonworks will say that Hive plus Thais is faster. Cloudera will say Impala is faster. That is a war going on for like past 4 years. Nobody knows. Both are same. But whether it is Hive plus Thais or Impala, it's again a SQL interface for you. Only difference, if you're on a Hortonworks cluster, the execution is done by Thais. If you're on a Cloudera cluster, execution is done by a daemon called Impala. And there is somebody called Spark. Spark has a SQL interface that's called Spark SQL. If you write a query on Spark SQL, again same SQL, this will be converted into Spark, and this is almost real time. So this is faster. Look at this, look at this. Hive Thais, Hive Thais, SQL, Hive, Thais. But in Hortonworks, you can also say that I don't want Thais, I want MapReduce. They can switch the engine. So these are all additional information, extra information, but good to know things, right? So Phoenix is SQL interface on top of NoSQL. That means HBase is your NoSQL database, right? And HBase doesn't understand SQL. So if you do not know the language of HBase, you install Phoenix, you write your SQL query, it's going to convert in the language of HBase, show you the result. Original Hive plus MapReduce is batch processing, very slow. Thais and Impala are similar, interactive, but Thais is Hortonworks, Impala is Cloudera. That means you will never see Thais on Cloudera and Impala on Hortonworks. Spark SQL is again on Spark framework. Phoenix is on HBase. Difference between different Hive. For example, you have something called Hive. Then you have something called Hive Server 1. Then you have something called Hive Server 2 plus Beeline. So what are these terms? What is pure Hive? What do you mean by Hive Server 1? What do you mean by Hive Server 2 plus Beeline? See, so this is something which you have to understand from the technical point of view. Originally, only Hive was there. And this is just a client-side application with an interactive shell, meaning the original Hive, what you call the pure Hive, is just a client-side application. That means if you are a developer, you take your laptop, install Hive, you get a command line. In the command line, you say create a table, drop a table, do the query, blah, blah, blah. It just works. There is no server, only client. And that is what I was explaining in my picture also, right? I drew a picture where I was telling you that, Hive is just a client-side application. So when Hive was invented, people were really happy. They said, oh my God, that's really great. So we can get a shell and we can write commands and we can work with Hive. That is nice. But later, people started thinking, so how do you connect your database? Can you tell me? You have an Oracle database. The Oracle database is sitting in some place. How do you connect it with the Oracle database or Microsoft SQL database? What do you use to connect? You need a client-side tool, something like MySQL Workbench or something, right? You need a client-side tool to connect using JDBC or ODBC, right? JDBC, ODBC connections can be made, but for that, yeah, you will have a server where Oracle is running. You need an Oracle client, some SQL client, right? So what people thought is like, okay, everything is nice about Hive, but I cannot connect to Hive from my SQL clients. Why? Because Hive was just a command line. Look at here. That is when Hive Server 1 came. This guy will allow JDBC or ODBC connections from your regular SQL clients. That means Hive Server 1 means there will be a server running in a Hadoop cluster. Clear? Hive Server 1 is a server which is running in the Hadoop cluster. You in your laptop, if you install Hive, you can open the command prompt and type queries. Or you can use your regular SQL client tools to connect to the Hive server and perform all the activities. Right? So Hive Server 1, the option is that you can create JDBC connections from your SQL client directly to Hive. So you can insert into a table, you can do whatever queries you want, you can directly run in your client. Very easy. You don't have to use a command prompt. You can use a command prompt also. So people were really happy. Hey, great, we have Hive server, we can connect, we can run queries, blah, blah, blah. But this lacked concurrency, meaning there was no concurrency or consistency in Hive Server 1. That means if multiple users create sessions to Hive, it was impossible to handle the sessions. Data persistence, data concurrency issues were there. That is where Hive Server 2 came. Hive Server 2, first of all, it also allows your JDBC, ODBC connections. It provides concurrency and it has a new client-side command line tool called Beeline. That is Hive Server 2. So Hive Server 2 is kind of like an upgrade to Hive Server 1. The basic difference is that it also allows JDBC, ODBC, but it provides concurrency. That means multiple JDBC, ODBC connections are possible. You can work with Hive, but they have redesigned the CLI of Hive, and the new CLI is called Beeline. Still, it supports the old CLI, and the new CLI is called Beeline. Beeline is actually a client which you can install, like SQL client. So I can go to a computer, install Beeline client. From there, I can make a connection request to the Hive Server 2 and start working in the Hive. So the Hive server will be installed inside your cluster. The architecture of Hive. Now you can see a person, okay, and he is using the Hive query language. Now you can if you are a person, either you can interact with Hive through CLI. That is what I'm saying. CLI means it can be the beeline client or regular command line, Hive shell. I will show you the Hive shell. It's an interactive shell. Or JDBC, ODBC. That means you are having a SQL client. From there you can connect. Or a web UI. Hive also provides a web UI. And whatever ways, look at the arrow. If you are using the CLI, directly you will be hitting Hive. That means hitting Hive in the sense, if you're using the CLI, you will be directly creating tables, etc., etc. But if you are using the JDBC, ODBC, these sessions are handled by Hive Server 2. So we are having Hive Server 2. So the main purpose of Hive Server 2 is to handle this multiple sessions that are created by users through JDBC, ODBC. That is why there is a difference in the arrow. CLI means you are directly invoking Hive. JDBC, ODBC means you're connecting through the Hive server. So either you use CLI or you use JDBC, ODBC. Now, where will I install Hive Server 2? It is not necessary that you have to install it inside a Hadoop cluster, right? It can be outside the Hadoop cluster also. See this picture? Your Hive Server 2 is outside the Hadoop cluster in this picture. Now, so like I explained, you sit, if you use CLI, directly it is Hive. If you use JDBC, ODBC, it goes through Hive server. But again, the sessions are handled by Hive server, but it is ultimately Hive, right? Now in the picture, it is very clearly shown that the Hadoop cluster is separate. That means Hive server need not be installed inside a Hadoop cluster. It can be outside. In most of the cases, it is installed outside as well, right? Now, inside the Hive architecture, you can see compiler, optimizer, executor. But how does Hive know where is the data? Or in other words, what about metadata? See, for any database or data warehouse or any system, you need to store metadata. What about the metadata? So in Hive, what happens? There is something called metastore service. What is metastore service? It is a service running to handle metadata. What is metadata? The definition of your table, the definition of your database, the schema of your table, all this is metadata. So you need to store the metadata somewhere, right? So that is what is handled by this metastore service. By default, Hive uses something called embedded metastore. This means it stores the metadata in built-in Derby database. So what happens is that by default, if you are downloading and installing Hive, it comes with a database called Derby, Apache Derby. Apache Derby is a database, and it will use this Derby database to store the metadata. Clear? So that is called embedded metastore. Embedded metastore means by default, if you just download and install Hive, Hive will need some place to store the metadata. So it by default comes with this Apache Derby database, and it starts using Derby to store the metadata. You don't have to do anything. It will be all configured. Okay, so this embedded metastore is good because you're saying that if I'm downloading and installing Hive, right, it will come with a database and it will store the metadata in the database. This is all good. But this Derby has a drawback. The Derby database is a single instance database. That means it will allow only one connection at a time. That means if you are using the embedded metastore of Hive, only one person can access Hive. So that is a drawback. So what you can do is that you can configure your own database as metadata storage for Hive. Example, MySQL. So this is what we do in production. Meaning in production what we do is that we will download and install Hive. Now we know that Hive will start working automatically because it will use Derby to store the metadata. But when it is using Derby to store the metadata, right, what happens is that it will allow only one connection at a time. Because Derby will allow only one connection. So we don't do that. What we do is that we will configure something like MySQL and ask Hive to store the metadata in MySQL so that multiple people can access Hive. The latest version of Hive allows updates, but all other versions of Hive by default does not allow updates, because remember it is Hadoop. Hadoop is a write once read many system. In Hadoop there is no update process, right? You copy the data, you delete the data, you again copy the data. It is all writing the data and reading many times. But the latest version of Hive allows you to do that. It selectively can update it. Okay, it can refer to the position of the block in the data node. So Hive can by default talk to Hadoop. It can understand where is your data and accordingly it can do. So what you need to understand is that if you are practicing Hive on the Cloudera VM, if you are practicing Hive on the Cloudera VM, you are using embedded metastore. That means there is a Derby inside and that is storing all your metadata. Very simple. But if you go to a company and start working on Hive, right, then the metadata will be stored in a separate database like MySQL. That is the difference. So two types of metadata storages are possible. So if a user write a query, the query will be accepted by somebody called a driver. The driver is not shown in the picture, but there is a driver. And the driver will pass it to somebody called compiler. Compiler will check with the metastore to get the metadata and compile your query. Then optimizer will optimize it and give to executor. Executor is your MapReduce, and MapReduce will run your query in the cluster. So step number 1, user writes the query and the query comes to Hive. Okay, and first step is compiling the query. Now you won't simply compile the query because you need the metadata. So you will check with the metadata store about the metadata. Once you get the metadata, you compile the query and there is a component called optimizer. It will optimize your MapReduce code so that it can perform better and then give it to another component called executor. Executor is normally your MapReduce program. I mean MapReduce engine, and that will execute your query and show the result. There are two situations, okay? Again, this is coming mostly from the practical aspect. If you are having a small Hadoop cluster, let's say you are having only 3 servers, I mean 3 data nodes, 4 data nodes, etc. And so it's a very small cluster, right? And normally this cluster will be accessed by only a couple of guys. So if you are sitting here, you have a computer, entire Hive will be installed here. Your Hive server will be running, everything will be running here. Why? Because it's a small cluster. There is no point in installing here and then connecting. You can install Hive, but usually, so I'm talking different use cases. I'm talking different use cases. In small Hadoop clusters, where you're having 3 to 4 data nodes and all, you will not do any heavy lifting. Why are you creating small Hadoop clusters? It might be for proof of concept. No, you're not actually running any production workload. So that means in this case, there is no Hive component in the Hadoop cluster. Entire Hive package is on your machine. Hive server, Hive CLI, whatever you call, anything starting with Hive is on your computer. Nothing is there in the cluster. Are you getting my point? Why? Why? Because either you or only your friend will be accessing this. And you don't need a separate client server and all, right? Because it's a very small cluster. So you install all the package on your computer, and then you can also install SQL client on your computer and create a JDBC connection. From here it will connect, etc., etc. But everything will be on your computer because it is a small Hadoop cluster. Now, what if it is a very big Hadoop cluster? In a very large Hadoop cluster, So this is a large Hadoop cluster. Say thousands of data nodes. You will have something called a gateway node. Have you guys heard about this? What is a gateway node? Have you guys heard about this? No, I think. What is a gateway node? This guy will have connectivity with Hadoop. And it's a Linux machine. Imagine it's a Linux machine. Here, you will install everything. You will have your Hadoop client here. You will be having your, Hive server here. And maybe Pig. Everything will be installed here. And what you do is that if you're sitting here, right, you have a laptop. You don't install here. Maybe on your laptop, this is your laptop, right? So this guy is sitting here. This guy is sitting here. What he can do is that he can do multiple things. He can SSH to this machine, connect to this machine. So he log into this machine, and from here he can type Hive. He get a command prompt, start working on the cluster. Now another guy is sitting here. He has a laptop, okay, and here he has installed, let's say, SQL workbench, SQL client. Now, if he open the SQL workbench, it will connect to this, and from here it will connect to this, right? So, what is the gateway node? Gateway node is nothing but is a server. Okay, it acts like an intermediate between you and Hadoop cluster. In large Hadoop clusters, you will not be directly logging onto the cluster. You will never even see your cluster. It is strictly prohibited. You cannot access your cluster. All you do is that you connect to this gateway node. From here, you can do anything. So if you prefer the CLI, what you do is that you log on to this gateway node using SSH. From there, you are on the gateway node. You type Hive CLI, you get Hive CLI. Or if you're having a SQL client, okay, you give the details of this gateway, and this will connect to the gateway. From there, it will connect to the large cluster. Right? So all the client packages are actually installed in the gateway node. That is my point. So you have two options. Either you log on to the gateway node. So now you log into the gateway node and open the command prompt and say hit Hive. You will see the Hive shell. You start working. Or if you're having a SQL workbench, your Hive server will be running on this gateway node. Okay, SQL workbench will connect to Hive server and to your cluster. Interface of Hive. Just type Hive and hit enter. And this is the Hive shell. So this is the command line interface of Hive, the interactive shell of Hive. What you see is Hive shell. Now, once you are in the Hive shell, most of the commands that you type need no introduction, because the commands are SQL commands and most of you are familiar with SQL, right? For example, I can say first command, probably if you log on to any of these systems, the first command you will probably type is show databases. You can see all the databases that got created. Now, the best way to understand Hive is to start working with Hive. So what I'm going to do, I'm going to say create database, let's say Dell, and if I do a show databases, it will be there. There is a database called Dell. Now if you want to use it, just say use Dell. So when you say use Dell, the database has changed. So now you're using the database called Dell. Fine. So far, so good. Now, these are regular things, right? Now, let's take a sample scenario and see how we can use Hive to solve a problem. Rather than just speaking about Hive, right? Let's take a sample scenario. So let me show you the data that I'll be working with. Yeah. So on my desktop, I have a file called transactions. Can you see this file? It is called txns1. It's a transaction data. If I open this file, this is how the data looks like. Just to give you an idea, right? Now, if I have to explain this data, let's pick one record. So this is one record so that I can explain to you. As you can see, every record is comma separated values. So this has some structure. The first column, so this is a transaction data from a sports store or a retail store. So first column is transaction ID, which is 4. Then you have date of transaction, 17th December 2011. Then you have something called customer ID, 4002613. That is the customer ID or the customer number. Then the amount spent, which is $98.81. And then the category, team sports, the item, field hockey, city, Nashville, and the state of Tennessee, it's a credit transaction. So this is how your transaction data looks like. Line by line, multiple customers have purchased items from a sports store. That's it. So it's a very big data actually. I mean, there are a lot of lines in this data, right? So this is one file. Now, I also have another file here called customers. So if I open this file, this is my customer data. For example, if I pick one line or one record at a time, first column is customer ID, okay, which is 400015. Then you have first name and last name, Julia Desai, aged 49, profession is musician. So we are having two set of data. One data is the transaction done by the customers. The second data is the data about the customer. Their name, customer ID, age, and profession. So I'm having two set of data. And as you can see, the customer ID is common in both the data set, right? Now what I want to do is, I want to analyze this data. What sort of an analysis? What I practically want to do is that I want to understand how much money is spent by youngsters in my store and how much total amount is spent by middle-aged people in my store and how much amount is spent by old-aged people at my store. So basically, I want to classify the customers into 3 groups, say 20 to 30, one group, 30 to 50, another group, 50 above, another group, and I want to calculate the sum of amount spent by them. I want to use Hive for this. So let's look at how we can do this. So as a first step, what I'm going to do is that I'm going to create a table. This is the syntax to create a table. And this should not be a surprise to you if you already know SQL. I'm saying create table called, this is my table name, transaction records. And this is my schema. Very simple. Transaction number, date, customer number, amount, category, product, city, state, spent by. And Hive imposes schema, which is very similar to, and the data types and all are very similar to what you deal in day-to-day life. Like it supports in, string, double, float, everything almost, right? So I have given the schema to my data, right? Then I say row format. I am expecting my data in row format. That means by default, Hive will identify a row and using new line character, it is going to separate every record. Delimited fields terminated by comma, meaning my individual fields are comma separated. If you give semicolon here, your input data should be having semicolon. Then I say stored as text file. By default, Hive stores the data as text file. Now you can say sequence file or any other format also if you want, but if you don't type text file also, it is going to store it as text file. This is the for syntax. If I hit enter, Hive says OK, which proves the data is created, right? I mean the table has been created. Now the next point, I have the table. How do I load the data to the table? Now there are multiple ways to load the data to a Hive table. I'm going to first show you the common way. That is what everybody does. So where is the data? The data is on the desktop of my Linux machine. I mean the data is in my local file system. So what you can do is load data local in path /home Cloudera. So this is the path, desktop, into table px. That is how you load the data. You can actually do insert, right? But typically in data warehousing, you get bulk data to load. So you will be getting huge amount of tables and text files which you want to load it into this place. So usually you will not say insert. Usually you will dump the data like this. So what I'm saying load data local in path. This means my data is in my local file system, and this is the path of my data into the table transaction records. That's it. So now if I do a select star from the table, say limit of 20 or something, I should be able to see the data. See, I'm able to see the data because I have loaded the data to the table, right? So now the data is also in the table. But what is happening in Hadoop? Behind the scenes, what is happening? That is one question, right? I will show you what is happening behind the scenes. Whenever you install Hive on any platform, what Hive does is that it will create a folder called warehouse in HDFS. So if I do an HDFS DFS-ls, you see this? Whenever you install Hive, Hive will automatically create this folder called warehouse in Hadoop or HDFS. The folder name is warehouse. Now if you check what is inside this warehouse folder, you see all the databases you have created. So this is our database del.db, right? So whatever databases you are creating is actually stored inside this warehouse directory. Whenever you create a database, okay, the database gets created in this path, user Hive warehouse, and then the DB, what you create. Now, the DB is just a folder in Hadoop. DB is just a folder in Hadoop. Hue is a web interface to your Hadoop, nothing else. So in Hue, I can just go to browser and I can just see, rather than typing HDFS, DFS, I can just come here and see what is the files in Hadoop. When you install Hive, it creates a folder called warehouse. So this is the warehouse folder, right? Can you see the warehouse folder? So it creates a folder called warehouse. Inside this warehouse folder, if you open this warehouse folder, you can see all the databases you have created. So this database called del.db is nothing but a folder in Hadoop. You created a database and you think it is a database. It's not a database, it's just a folder. See del.db. If I open this folder, what you see? Another folder called transaction records. The transaction records table you created is just a folder. And if I open this, can you tell me what you see here? The file that I copied. So look at the table structure. Look at here. Your database del.db is just a folder. Transaction records is another folder. Inside that you have the file. This is what is happening in Hadoop. So when you are loading the data into a Hive table, it is just copying the data from Linux to this folder in Hadoop. Is this clear to you or not? Of course, you use a command load data local in path, but what is happening behind the scenes is that the data that you are inserting into the table is just copied into this location in HDFS. And if this data was very big, it will be divided into blocks and all, just like regular Hadoop file. This is where your data gets stored. So I can also show this from command line. So if I do warehouse, then del.db, what will I see? I see another folder called transaction records. And if I again say txn records, I will see the file. So that is why I'm saying Hive is just giving you a projection. The actual data is just lying in Hadoop, right? Now what I will do is that, okay, I will create one more table because we have the customer data to be stored. I will say create a table called customer, and this is having customer number, first name, last name, etc. So another table, and we will load the data. So the data is into the table called customer. Right? So now the data is loaded into customer, but you will be wondering, so far I have not seen any MapReduce program, right? So I was telling you that if you query the data, you will see the MapReduce job and all, but so far I have not seen anything because you have not actually ran a query. So let's say select count star from transaction records. So this is a proper query. So I'm doing a select count star from the table. So basically I want to know how many rows are there. If I hit enter, it's going to fire a MapReduce job. Can you see this? Because it's a proper query, it cannot just show the result. It's going to launch a job and create a jar file. And here is the result, 50,000. So the answer is 50,000. The result of the query is 50,000. How did I do it? I just wrote my query and hit enter in Hive, and it automatically launches an equivalent MapReduce job to show me the result. And I get the result here. Now let's analyze this further. So what I want to do is that I'll be creating one more table. So I'm going to create a table called out1. Okay, this table has customer number, first name, age, profession, amount, and product. So basically my idea is to do a join operation. I have a customer data, I have a transaction data. Both the data has a common column called customer ID. So my idea is to do a join operation, a simple inner join operation. And the results of the join operation has to be stored on a table. So I have created a table already. So this table is called out1. And how do you do a join operation in Hive? Very simple. Insert overwrite table out1. So out1 is the new table we have created. Select a.customer, a.first name, a.age. So if you look at the syntax of the join operation, it is exactly same as your normal SQL join operation, right? If I hit enter, it's going to launch a MapReduce job. So now the join is over, and if I do a select star from out 1, this is the result of our join, and if I do a limit of 20 or something, see, this is the result of the new table. In the new table, if you see, this is the result of the join operation. So you see, you have customer related data and transaction related data. This is very simple, okay? I'm just following the same logic of SQL. Only difference here is that, it is converting it into MapReduce job, right? Now what I can do is that after this, I will create one more table. I'm creating a table called out2. Now what I want to do is, see, now I have done the join operation, but I want to classify my customers, right? My customers are having different age. So I'm having a column called age, and I want to classify my customers. How can I do that? Very simple. If you look at here, insert overwrite table out2. That means the result will be in this table, which we created in the last step. Select star comma case. You see, I'm opening a case here. And what is the case? When age is less than 30, then it will be marked as low. When age is between 30 and 50, middle. Greater than 50, old, else others, end. So what this query will do, it will pick all the rows from my previous table, look at the age column, and based on my criteria, it will mark every record as low, middle, old. You hit enter, it's going to fire a MapReduce job again. So every query will fire a MapReduce job. You don't have to worry about that. So you can see the map 0, reduce 0, etc. And now it's over. So if I do now the query is over. If I do a select star from out2, if I do a limit of 20 or something, you see every record is now having a category: old, middle, old, etc. Right? So now I am able to classify the customers. Now all I need to do is very simple. I will create one more table. I will do a group by query. So what I'm doing here is very simple, guys. I'm saying insert override table out3. So out3 is the latest table I have created. Select level. So the level column will have low, middle, that age classification. Sum of amount from out2, group by level. So it's a very simple group by query. The result of this query will have your final answer. So the table name is out3. And the query is over. If I do a select star from that, I will have the final answer. See, this is your final answer. So the youngsters are spending this much amount, middle-aged people are spending this much amount, old-aged people are spending this much amount. So this is how you start working on Hive. There are two types of tables in Hive. There is something called managed table. There is something called external table. And by default, any table that you create is a managed table. So I will tell you what is the difference, okay? But there are two types of tables in Hive which you can create. I mean, two types of tables. There is something called managed table and there is something called external table. Now, what are these things? By default, any table you create is called a managed table. So what is that? How do you know that? If you go to Hive, you can say show tables. And we have a table called transaction records. If I say describe formatted txn records. If I type this command, describe the table, it says it's a managed table. Table type is managed, and look at the location of the table. Managed table means the table is managed by Hive. That means this table is stored under user Hive warehouse, and you cannot change that as well. That is called a managed table. So if that is managed table, what is an external table? In Hive, I can say, what I can do is this. I can say create external table. So when you want to create an external table, I will tell you what is an external table. You have to say create external table. Well, the syntax is not correct. Let me add one more thing. Location / user / Cloudera / user Cloudera. I think it is user Cloudera. Then I can say my customer, something like this. Okay, let me type this first, then you will understand. Yeah, so this is the proper syntax, guys. So what am I doing here? I'm saying create external table. So whenever you're creating an external table, you have to specifically mention that it is an external table. Otherwise, you just say create table, it's going to be a managed table. So I say create external table, and this is the table name. And if you look at the schema and row formats, they are all same. There is no difference in the schema or the format or anything. Only difference, I'm saying location user Cloudera my customer, meaning this is the location in Hadoop. How do you know that? So once you create this table, if you go to your Hue, you go to user Cloudera, there is a table created called my customer. Can you see this? This table is just created and there is no data inside this. Now what is the advantage is that, so now I created a external table. If I do a select star from this table, txn records 2, there is no data because I just created a table. I didn't fill it with data. If you want to fill it with data, all you need to do is very simple. Go to the folder mentioned in the external table, that is my customer, copy the data to that folder. Now I just uploaded this data to this my customer folder. Can you see this? In the my customer folder in Hadoop, I just uploaded this data. Now if I come back here, again I do a select star, do a limit of 20, I have the data. So what is the difference between a managed table and external table? In managed table, which is the default table by the way, when you create a table, the table is always created in user Hive warehouse, that location. And then you manually load the data to the table. External table means when you create an external table, you are mentioning the location of your data. Look at this line. You say that the data will come from this folder, and whatever data you dump in this folder will be visible in your table. Very simple. What exactly is the difference between a managed table and an external table? Is the difference only the location? Yes, the difference is only location, but the real question is, where will you be using a managed table and where will you be using the external table? Now I can show you practically. Have a look at here, guys. Now, If I do a show tables, there is a table called transaction records. This is a managed table. I can say drop table txn records. So what am I doing? I'm dropping the table called transaction records. That's a managed table. What will happen to the data in this managed table? It will be deleted. Why it will be deleted? Because when you drop a table, that folder is deleted from Hadoop. Remember the folder structure. The data is inside that, right? So that means if you drop a managed table, the data is gone. But if I do a drop table txn records 2, that is an external table, the table is gone, but Cloudera and the folder is my customer, the data remains there. This is the difference. This is the difference. If you drop a managed table, the table goes, the data also goes. If you drop an external table, only the table goes, the data remains the same. So if you want to share your table with others, let's say you're working in a project, okay, you create a table and you think that you want to share the table with others, and you suspect accidentally somebody may delete your table, create an external table, because if somebody accidentally drop your table, still your data will be safe. Otherwise, create a managed table. How to use a Beeline. So Beeline is the new CLI, and by default, if you are using Cloudera VM, it will have Hive Server 2 running, and the default port number, it is 10,000. You can check the documentation to ensure that. Now, if you want to connect with Beeline, all you need to do is you have to start Beeline first. Okay. This is how you start Beeline. You will say user live hive bin Beeline. Basically, this is a location where Beeline is installed. It may differ in different distributions, but in Cloudera Hadoop, it is always right. So now you see the Beeline CLI, but here if I say show tables, it's going to throw an error. When I say show tables in Beeline, it's going to throw an error. It says no connection. Remember, Beeline is a client. It needs to connect with Hive server. Beeline is a client. Now you see the difference, right? When I'm opening Hive, if I just hit Hive, I am accessing the Hive entire package. It's not a client only. But when I say Beeline, it's a client. So in Beeline, when I say show table, it says no connection. I can't connect to the server. If you want to connect to the server, what you need to do is this, guys. This is the connection string. You can use the same in your JDBC or ODBC or whatever you have. This is your connection string. Connect JDBC Hive 2. Hive 2 stands for Hive server, right? Localhost, that's a port number. Username, password by default nothing because I'm running locally, and JDBC Hive driver. So it will connect, right? So now I am inside this. Right now, if I say show tables, show databases, it will list all the databases. So this is how you start Beeline. So you will say user live hive Beeline. So that will start Beeline. Beeline is your client. And when you say show tables, it won't show anything because it need a server connectivity. And this is the connection string. So you will say connect with JDBC Hive server 2, localhost running in localhost, and the port number, username, password, hit enter, it will connect. Okay. Once it is connected, you can type your regular commands. So I am typing, where is the command? Where is the command? Show databases. So this is the command I type, and here is the list of the databases. And the command line is pretty much similar to your Hive CLI. So this is how you start working on Beeline. This is Beeline. Okay. Now, if you want to quit Beeline, just say exclamatory mark Q. This is the command to quit. Very important. Exclamatory mark Q will quit Beeline. So now I am back. Right. So that is how you connect from Beeline client to Hive server 2. You can also download Beeline client on your desktop or something and make a connection to the Hive server. Now, if you don't want to type all the commands and all, you hate the commands of creating a table and all, what you can do is come to Hue. Okay, then what I'm going to do is that let me show you the data I'll be working on. Here, okay, there is a data called healthcare sample data. Now this has patient ID, patient name, patient mobile number, date of birth, hospital data, email address, social security number, the disease, diabetes, fever, cold, blah, blah, blah. So this is a sample data that I'm using. What if I want to upload this data into Hive and query the data? Basically, I want to get a list of all the people who are having cold. So if I want to do that, you can of course use the command line, but you can also use the GUI. Let me show you that. Go to Hue, go to this data browsers. There is something called Metastore table. Click on this. Once you click on Metastore table, okay, it will allow you to select the database. So I'm going to select our database. I can select this database. I can say create a table from a file. I can give a table name, test table. Okay. And then I can say select the file from where you want to create a table. So which is this healthcare data. Say next. It's going to automatically look at the data. It will ask you, hey, is this how your data looks like? Yes. I will say next. And it is also automatically going to select the data type. I'm going to say create table. So this will create a table from the file that I have uploaded to Hadoop. No need to type any statement or anything. Right? So going to create a table. Now once the table is created, you can query the table from the GUI. You don't have to use CLI. Let me show you that. What you can do is you can go to this query editors. There is something called Hive. Can you see here? You can go to Hive. In Hive, you have to use the database. I have a database called test table. I can select this table, right? So there's a table. So I can say select star from test table where column number 7 equals cold, and then execute the query. So this will run the query in the GUI and show me the result. Can you see this? Right? And I can create nice charts and all if I want. Right? I can create like, charts and all. See, stacks and groups and everything I can create if I want. Basically, what I'm telling you is that you can run queries from the GUI also. Partitions in Hive. So what exactly is partitions in Hive, and why are we doing this, right? What's the idea behind partitions in Hive and what we are supposed to do? So just imagine that you are working in a project which uses Hive. Okay, so you are in a project which uses, of course, Apache Hive, and you're happy you're working on Hive and everything is going fine. Now what happens is that, let's imagine that your manager comes to you and say that, hey, Raghu, do one thing, create a table for me in your Hive in which I want to upload all my sales data. So what I did, I created a table, create table, sales data. I created a table called sales data because my manager says he has to upload some data related to sales. So I created a table called sales data with some schema, some columns and all, whatever we have. Now imagine you are working on a managed table. So for the time being, we assume that we are on a managed table, and by default, what happens is that if you create this table, the table will be stored in user, Hive, warehouse, and let's say our database is called newdb/sales data. If you create a table called sales data, this will be the location by default. So this is the basic stuff, right? So whenever you're creating a managed table, the table's location will be this. Now what happened is that your manager told you that, hey Raghu, do one thing. I have some data. Why don't you load the data to the table? So your manager gives you a file and asks you to load that into the sales data table. No big deal, because usually you know how to load the data. You will say load data local in path and then load the data. When you loaded the data, so the manager says, hey, this is January month data. So you loaded a file called january.txt. Very simple. I have created a table called sales data. I have loaded a file called january.txt. This contains all the sales transactions in the month of January. Very simple. So you are happy. Your manager is also happy, right? Yeah. So then what happened is that, you keep on working in the project, and the next month your manager comes to you and say that, hey Raghu, we have some more data, so this data is from the month of February. Why don't you load the data to the table? So you end up having, so now the file is february.txt because this is the February month data. However, since this is getting loaded into the same table, this will be the structure. Now inside the sales data folder, now you have two files, January and February, right? So probably I will write it like this so that it's easy for you to understand. I will say like this. And then your manager says, hey Raghu, I have some more data. I have some more data. March.txt comes. Then what happens? April.txt comes. Then what happens? May.txt comes. And June.txt comes. So what is happening here? Every month you are getting the data, right? Every month you are getting the data and you're loading the data to the table because you have a table called sales data. But if you look at the way in which the data is stored, what you can see is that these all different files, January, February, March, April, May, June, all are inside the same folder called sales data because that is your table name, right? So, okay, so you might think that that's fine, but what is the problem? Now imagine, okay, you are writing a query like this, okay? Just imagine that you want to write a query something like this. Select star from sales data table where month equals, let's say, April. I'm just giving an example, okay? So let's say you want to query the table. You want to query the table. So what is the query? You say select star from the table where month equals to April. Means you want to see all the data from April month. Now look at the problem you have. Hive by default doesn't know where is April month data. So what Hive will do, it will come to this folder called sales data. It will first scan this entire January.txt, then scan this entire February.txt, then March.txt, then April.txt, it finds a match, again May.txt, again June.txt. Meaning your entire data is scanned for this single query and your queries will be really slow. So the problem we have is we have a table. So table in Hadoop is like a folder, right? And you keep on loading the data. Every time you load the data, it's going to store as a file. So that means inside a single file, now I have 6. Inside a single folder, now I'm having 6 files. January, February, March, April, May, June. And if you write a query, Hive doesn't know where is the data. It is going to scan all the 6 files. It is going to go through all the 6 files to show you the final result. And so you imagine you keep on adding files every month, data every month. If your table has, let's say, 100 different files, Hive has to scan this entire files before showing you the output of the query result. And obviously your queries will be really slow. So you are not actually saying where is the data. So that is a simple problem. And Hive has to scan the entire files to produce result. So ideally your queries will be slow. It will be really slow. So the question is, what can I do in such a situation? I don't want my queries to be slow. I want my queries to be faster. That is where your concept of partitions come into picture. So there is something called partitions in Hive. So what exactly is partitions? Partitions means you tell Hive to divide the data based on a column. What is a partition? You're telling Hive to divide your data or segregate your data based on a column. For example, what I can say here is that I can say, hey Hive, look at what I'm writing. Partition my table based on the month column. So this is what you can tell to Hive. So I can tell Hive, hey Hive, do one thing. Partition my table, okay, based on the month column. If you tell this, what Hive will do is that it is going to look at, now once you write this, it is going to look at the whole data first. Then it is going to look at the month column in the whole data, right? Now obviously in your January.txt file, the month column will be what? January. What Hive will do, it will create a folder called Jan and place this file inside that. Accordingly, it's going to create something called Feb and place it here, and March, place it here, sorry, and April, place it here, May, place it here, June, place it here. So when you tell Hive that, hey Hive, I want to create partitions and I want to create partitions based on the month column, what Hive will do is that it's going to pick the column from the whole data and understand how many values are there. In my example, there are 6 months data. It's going to automatically create 6 folders: Jan, Feb, March, April, May, June. All the January month data will be copied into this folder. All the February month data will be copied into this folder, etc. So now if you write the same query, select star from sales data where month equal to April, Hive will scan only this folder because it knows April month data is inside a folder called APR. Your queries will be much faster. This is called partitioning in Hive. A partition is nothing, it is a division on your table actually. So when you are saying create partitions, what is happening is very simple. Based on the partition column, those many folders will be created, and whatever criteria matching with that folder, that data will be moved into that folder. Very simple. You have to understand one more thing. So I will show you the data maybe, so then it is easy for you to understand. This is the data that I will be using for partitioning. If you take one record of this data, you will understand what is this data. So let me show you what is the data first, and then I will explain what I'm going to do. First, let's analyze the data. Look at here. This is one record. This is one record. So first name Gerardo, last name Vodka, then 69206 Jackson Avenue, that is the address, Australia, that is the country, then the state, primary phone number, secondary phone number, email address, and website. That is the data. Now, if I scroll down, let's say this data. Look at here. Angelicia Lovero, that is the name. The address is 689 S Steel Street, 1887, CA, California. I think California, right? And so then you have the other details. So basically, the data actually contains users' names. Okay, so I will just show you the last part of the data. Let me just show you the last part of the data. Yeah, this is US. So if you look at here, Gilma Luco and the address US, again for primary phone number, secondary phone number, email address, website. So that is the data that we are going to do. Now, there are two types of partitions. There is something called static partitioning. Static partitioning, and there is something called dynamic partitioning. Now, what is static partitioning? What is dynamic partitioning? In static partitioning, you have to manually create the partition and load the data. In dynamic partitioning, Hive will automatically detect your data and create the partition. So you will naturally think where this is applicable, because dynamic partitioning seems to be really good, because in dynamic partitioning, Hive is automatically going to create my partitions. Then why should I use static partitioning, right? So let's say you have a data like this, Raghu, comma, the phone number, and then you have email address. Then you also have Ram, something. Okay, ram@abc.com. Okay, now you also have some more data. Let's say Tina, some phone number, tina@abc.com. Now then you have Ajay. Okay, some phone number for Ajay, ajay@abc.com, comma. So let's suppose you are having this data. Now Raghu and Ram are in India, and Tina and Ajay are living in USA. But you do not have a strict column for India and USA in the data. See, in the data, all I have is name, then phone number, then email address, and website. I don't have a country. But I know that Raghu and Ram belong to India and Tina and Ajay belong to USA. In this case, what I do is that I will manually create two partitions. And partitions will be India and USA, and load the first two files in India and last two files in USA. This is static partitioning. Did you understand the use case of static partitioning? Static partitioning means you are getting the data. You know that the data is segregated. You know that half of this data is belonging to country India and half of the data belonging to country US. But that information is not present in the data, right? So what you do is that you create static partitions. Static partitions means when you are loading the data, you will ask Hive, create a partition called India, put this data there. Create a partition called USA, put this data there. Then you can query the data saying select star from my table where country equal to India. It will definitely query this partition. So this is like you're defining a column while loading the data. Now I will show you partitioning. That will be the best way to do this. So what I'm going to do is that I'm going to connect to the VM first. Okay, then let's see how partitioning is done. So now what I'm going to do is that, okay, I'm going to launch Hive first. Okay, first thing I'm going to do is that I'm going to launch Hive. So, and we have the data. I just showed you the data, right? So the first thing I'm going to do, I'm going to demonstrate static partitioning right now, right? Show databases. We have to take a database. Okay. So remember, Hue is your web interface, right? So first thing I'm going to show you is how my folder structure looks on Hadoop. Now, so I'm going to go to my root directory and user directory, and we have the Hive directory. There is the warehouse, and there is the Dell DB, and inside the Dell DB I have these folders. Now what I'm going to do is I'm going to say create a table called partitioned user. Now you can give any table name, and look at how I'm creating a partition table. This is my schema. Okay. After the schema, I'm saying partition by country and state. Look at here. So whatever columns you are using for partitioning should be outside your schema definition. So when you are creating the table, you say create a table, give the schema, no problem, that's all fine. But I'm saying partitioned by country and state. That means I'm telling Hive that, hey Hive, I'm creating a table and this is my schema, and I'm going to partition using two columns, country and state. If you hit enter, it will create a table. But look at here. If I refresh my Hue, this is the table we created, partitioned user. If I go inside the table, there is no partition. There is no partition. So when you create a partitioned table, there is no divisions. It's a normal table only. Can you see this? I just opened this table. This is the table partitioned user. If you open this, there is nothing inside that. Now, how do you create static partitions? Very simple. In order to create static partitions, what you need to do is, let me show you the data. I will duplicate this session. Root sudo su cloudera. Okay, I'm going to use this file called static. Let me show you the file. Now this file has 3 rows of data, and I am going to load this file into my table and create partitions. Now I completely understand that this file, is copied from the original file that we had, but this is the file which I will be using for demonstrating partitions, right? If you look at here, it has only 3 records as of now, right? So you have the name, then you have the address, right? And then you have the phone number and email address, website. That's it. So what I'm going to do is, I'm going to say load data local in path. So I'm going to load this folder into this table, partition country equal to US, state equal to California. This is how you're creating static partition. I already have a table, and that table has all the schema. Now I'm saying load this file, but while loading this file, create a folder called US. Inside that, create a folder called California, then put the data. Now US is my country, California is my state, the file will be inside that. I created the table here, then I loaded the data where I said country is US and state is California, right? Now I will show you how the folder looks like in Hue. If I refresh my Hue, if I go to Dell DB, there is this partitioned user. Inside that there is a folder called country America. Inside that there is a folder called state California. Inside that my data is there. And this is the data. Now, if you look at the data, there is no country column, there is no state column in the data, but I created this so that it falls here. Now, if I query the data, I will write a query where country equal to US and state equal to California. It will land on this data and query this, so that it will be faster. So these are the commands are used. First, you create the table, give the schema, define your partition columns outside the schema. So this is what I'm doing, right? Define the partition columns outside the schema. Then you load the data. While loading the data, okay, the data you should say this data is belonging to which country, which state. Very simple. You have to give a country name and a state name. Okay, now let's discuss dynamic partitioning so that you guys are familiar with this, right? Now, what I want to do is, before you do dynamic partitioning, you have to do a couple of things. First of all, you have to enable dynamic partitioning. Now, I will show you how to do dynamic partitioning. So what am I doing here? See, by default, Hive has static partitioning enabled. That means Hive will not allow you to do dynamic partitioning. So that is why I'm typing this command, set Hive execute dynamic partition true. That means it will enable dynamic partitioning. I am also saying that maximum dynamic partitions per node is 1000. That means maximum partitions created will be 1000. You can give more numbers if you want. It is up to you. I just use 1000 so that it sounds good. Okay. You are also saying that the partition mode is non-strict. Okay. You are having something called strict mode and non-strict mode. Okay. So I'm just saying that, you know, partition mode non-strict. Now, in order to do dynamic partitioning, like what I'm going to do is that I'm going to show you dynamic partitioning with the same set of data. Hive will allow both static and dynamic partitions. As of now, I have enabled dynamic partitions. By default, it has only static partitions. Okay. Now let's look at what I'm going to do. It's very simple, right? I'm going to create a temporary table. Now the temporary table concept in Hive is exactly similar to your normal temporary table. Okay. So how do you create a temporary table? Temporary tables are valid only till the session last. You say create temporary table. And this time I'm not doing any partitioning. You see, I'm giving the complete schema. Look at here. I'm creating a normal temporary table. No partition, nothing. Just a simple temporary table. And this table is called temp_user. So I'm creating a table called temp_user. Normal temporary table, no partitioning, nothing. Once I create the temporary table, I want to load the data. So let me load the data. Now this time, what data am I loading? I'm loading this file called customerdata.txt, and that is this file. This file has country and state column. We are working on this file. This file has a column for country and state. Okay, so I'm creating a file. Then I'm creating a table, a temporary table. Then I loaded my data into the temporary table. Now, as the first step, I just want to write a query and see whether my query is taking time or not. So what I will do, I will write a very simple query. I will say select first name comma phone 1 comma city from the temporary table where country equal to US and state equal to California, order by city, limit 5. It's a very simple query, but the only condition is that I'm using country and state just to see or just to demonstrate how much time it will take if I'm not partitioning my table. So right now there are no partitions. Okay, so let's run the query, and the query runs, of course, and let's see how much time it is taking. Okay, so this time the MapReduce job is over and it took 85 seconds. So we will see whether it is faster. Now there is also one more thing. I'm running it on a VM. And even if I do partitioning, it may not have much of an impact, but let's see. Now let me show you how to create dynamic partitions. If I go to my Hue, I go to this del DB, okay, and okay, so this is my del DB, right? Now what I want to do is, I want to create a partition table. So what I will do, create table called partitioned user 1, okay, and this is the schema of my table, right? Partition by country and state and stored as sequence file. Now this is optional. You can store it as text file or sequence file or anything, that is optional. But this is the same command we used for creating static partition. When I was creating a static partitioning table also, I used the same command. But here the difference is that the data already contains the state and country column. Now see what I'm going to do. So I created a table called partitioned user, right? Now see what I'm going to do. I'm going to say insert into table partition underscore user 1 partition country comma state. So what I'm telling Hive is that, hey Hive, I want you to copy all the data from my temporary table and load it into this new table and partition it with country and state. I'm not going to tell you which country, which state, you decide, because already the columns are present. Now let's see what is going to happen. So see, now what Hive is doing, it will take the data from your temporary table, look it into the country state columns, identify the countries, identify the states, create those many folders and put the data accordingly. I will show you this now. Look at your screen very carefully. You will be able to see Hive creating these folders. So now it is creating the partitions. You will see that right now. Just wait for a moment for that to pop up. Can you see the loading partitions, loading partitions, loading partitions? Can you see that? Country, country, state, country, state. Can you see it creating these files and folders? And done. Now if I look at my Hue, the table is called partitioned underscore user 1. If I open this table, there are 5 countries: Australia, Canada, UK, US. Okay, I mean last one you leave it, there are 4 countries. If I open the folder called country US, all the states are created wherever you had the data. If you open any of these states, you will have a file that will have only that state data. Of course, you are not able to see the file in the proper format because it is storing it as a sequence file. But this has the state related data only if that is matching with here. So now you can see that, you know, it is creating countries and then inside country it is creating states also. And inside that the file is created. So this is dynamic partition. Now we will just see whether the query is faster right now. Okay. So what I will do, I will write the same query on the partition table, see whether it is running faster. So I'm writing the same query we ran last time. It took 85 seconds in the last time. Now the same query but on the new table, see what is going to happen. It might not be that much difference, but I guess there will be some difference. See, time taken 41 seconds. Can you see this? Last time without partitioning it was 85 seconds. Now your query is taking only 41 seconds. That is the impact on the query time when you are using partitioning.
So now let's see how do these two differ. So batch processing is an efficient way of processing high volumes of data, such as a group of transactions which is collected over a period of time. Hadoop focuses on batch processing, but as you can see over here, there is a time lag in processing this data. So the data which is generated on day 1 is processed on day 2. Similarly, the data which is generated on day 2 is processed on day 3. And on the other hand, real-time processing involves a continual input, process and output of data. So it provides an organization the ability to take immediate action in times when acting within seconds or minutes is significant. So Spark helps in achieving this real-time processing. So again, as we can see over here in this figure, the data which is generated on day 1 is processed on day 1 itself, and there is no time lag in processing. So that's the major difference between Hadoop and Spark. So now let us understand about Spark briefly. So Spark is a cluster computing framework for real-time processing. It was Hadoop's sub-project introduced in the UC Berkeley R&D lab in the year 2009, and it became open source in 2010. And in 2013, it was donated to Apache Software Foundation. So Spark provides an interface for programming multiple clusters with implicit data parallelism and fault tolerance. So now that we know what is Spark, let's actually have a look at some of its features. So Spark is real-time. That is, it provides real-time computation and low latency because of in-memory computation. And Spark is also 100 times faster for large-scale data processing. And Spark is also polyglot. That is, you can write Spark applications in multiple languages such as Java, Scala, Python, R, and SQL. Spark also has a simple programming layer which provides powerful caching and disk persistence capabilities. And Spark also has multiple deployment modes, so it can be deployed through Mesos, Hadoop via Yarn, or Spark's own cluster manager. So now, let us look at some domain scenarios of Spark. So from small startups to Fortune 500s, almost every single company is adopting Apache Spark to build, scale, and innovate their big data applications. So let us see some industries where Spark is used widely these days. So industries like healthcare, media, finance, e-commerce, and travel are extensively using Spark to add value to their business. So now let's understand how are Hadoop and Spark used together. So Hadoop alone provided limited predictive capabilities as organizations were finding it difficult to predict customer needs and emerging market requirements. But with a combination of Hadoop and Spark, companies can now process billions of events every day at an analytical speed of 40 milliseconds per event. Companies can also enhance their storage and processing capabilities by working together with Hadoop and Spark to reduce costs by almost 40%. And by deploying a big data platform in the cloud, organizations can avoid duplication by unifying clusters into one, which basically supports both Hadoop and Spark. So now many organizations are already using Hadoop and Spark together. Yahoo, Amazon, NASA, and eBay run Apache Spark inside their Hadoop clusters. Hortonworks and Cloudera Hadoop distributions come bundled with Apache Spark. Altiscale uses Spark on Hadoop to provide big data as a cloud service, and Uber also uses Spark and Hadoop together to optimize customer experience. So now let us have a look at some of Spark's APIs. So Apache Spark codes can be written in Scala, Java, Python, and R, and we can also write SQL queries with Spark. But the most preferred language along with Spark is Scala. So let's have a look at some of the features of Scala. So Scala provides scalability on Java Virtual Machine, and its performance is also really high when compared to others. Scala also provides excellent built-in concurrency support and libraries. And well, a single line of code in Scala can replace 20 to 25 lines of Java code. And Spark is also extremely fast and efficient. So now it's time to have a look at Spark's architecture. So Apache Spark has a well-defined layered architecture where all the Spark components and layers are loosely coupled. So Spark basically uses a master worker architecture, and in the master node you have the driver program which drives your application. Now you might be wondering, what is a driver program? So basically the code that you're writing behaves as a driver program, or if you're using the interactive shell, the shell will act as the driver program. Now the driver program runs the main function of the application, and it is the very place where the Spark context is created. So assume that the Spark context is a gateway to all the Spark functionalities. So Spark driver and Spark context take care of the job execution within the cluster. Now Spark context also works along with the cluster manager to manage various jobs, And cluster manager is responsible for acquiring resources on the Spark cluster and allocating them to a Spark job. Now this job is split into multiple tasks which are distributed over the worker node. So these worker nodes are the slave nodes whose job is to basically execute the task and return the result to the Spark context. Then we have the executor, which is a distributed agent responsible for the execution of tasks. So every Spark application has its own executor process, and these executors usually run for the entire lifetime of a Spark application. So in a nutshell, the Spark context takes the job, breaks the job in tasks, and distributes them to the worker nodes. These tasks work on the partition RDD, perform operations, collect the results, and return to the main Spark context. Now, if you actually increase the number of worker nodes, then you can divide the jobs into more partitions and execute them parallelly over multiple systems, and it will be a lot faster. And with the increase in the number of workers, memory size will also increase and you can cache the jobs to execute it faster. So now let us see the various ways by which Spark can be deployed. The system currently supports these cluster managers. So we have Spark standalone cluster, which is a simple cluster manager included with Spark that makes it easy to set up a cluster. Then we have Apache Mesos, which is a general cluster manager that can also run Hadoop MapReduce and service applications. After that, we have Hadoop via Yarn, and we can also deploy it with Kubernetes, which is an open source system for automating deployment, scaling, and management of containerized applications. And Spark currently supports these three shells. We have Spark Shell with Scala support, PySpark with Python support, and Spark R with R support. Now it's time to understand about RDDs in Spark. So when it comes to processing the data over multiple jobs, we need to reuse and share the data, which can be achieved through in-memory data sharing, which is actually a lot faster than network and disk sharing. And RDDs help in achieving this in-memory data sharing. So RDD stands for Resilient Distributed Dataset, and it is the fundamental data structure of Apache Spark. So by resilient, I mean fault tolerant, as it can recompute missing or damaged partitions in case of a node failure with the help of RDD lineage graph. And it is distributed since data resides on multiple nodes. And dataset basically represents records of the data you work with. So the user can load the dataset externally, which can either be JSON file, CSV file, text file, or a database. So now let's actually implement a demo on RDDs. So we'll start off by understanding how can we create RDDs. So there are three ways to create an RDD in Spark. So the first way would be to parallelize already existing collection in a driver program. The second way would be to refer a dataset in an external storage system. And the third way would be to create an RDD from already existing RDDs. So let's create an RDD by parallelizing a collection. So this would be the syntax for that. So first we'll create a collection, and this collection is a list which contains these three elements: Spark, Scala, and Hadoop. And then we'll use sc.parallelize to parallelize this collection, and we'll store this result in my first RDD. So this is one of the ways by which we can create a Spark RDD. The second way was to reference a data set in an external storage system. So let's do that. So I'll just type in val and then give a name to the object, which would be, let's say, text RDD, and then let me load this external data file. So the command would be sc.text file, and then I will give in the path. Right, so this was the second way to create our RDD. And the third way to create RDD is to transform an existing RDD. So we'll do that using the filter function. Right, so over here we already have an RDD which is text RDD, and on top of that RDD I am using this filter function, and I will be extracting only those elements where it contains the string Spark, and I will assign to this result new RDD. So these are the three ways by which we can create RDDs in Spark. So now that we know how to create RDDs in Spark, let's go ahead and perform some operations. So the first set of operations would be the transformation tasks. So the Spark transformations basically produce new RDDs from the existing RDDs. So it takes RDD as input and processes one or more RDD as an output. And each time it creates a new RDD whenever we apply any new transformation. So the first set of transformation function would be the map function. So this map function iterates over every line in RDD and it splits it into a new RDD. So using the map transformation, we can take in any function and that function is applied to every single element of RDD. So what I'll do is I will go ahead and create an RDD with the name X, and this RDD is made by parallelizing this collection. Now what I want is, using the map function, I want to add the number 1 to each of these existing element. So this would be the command for that. So on top of this RDD X, I'll apply the map function and this will take in every single element and add 1 to that element. I'll hit enter. Now let me just type in y dot collect and let's see what is the final result. So over here we see that these were the initial values, and after applying the map function on top of this, 1 has been added to each of the individual element. So initially it was just Spark. After using the map function, it became Spark 1. Initially it was just RDD. After using the map function, it became RDD1. So this is how we can use the map function. So now we'll go ahead and work with the flat map function. So with the help of flat map function, to each input element, we can have many elements in an output RDD. So the key difference between map and flat map is that map returns only one element, while flat map can return a list of elements. So over here, what I'm doing is, I have a list 1, 2 and 3. And what I want to do is, I want to duplicate each of the individual element 3 times from this RDD. So I'll use the flat map function and I'll take this element and I want to duplicate each of the element 3 times. I'll hit enter and let's see what do we get. So this was our initial RDD, and after applying the flat map operation, we see that each element has been printed 3 times. Now let's say instead of 3 times, I only wanted to duplicate it 2 times. So what I'll do is I'll remove this X, I'll remove comma over here. Now I'll hit enter. So see that we have duplicated this initial RDD like this. So the duplication is twice over here. So after this we have the filter function. So the Spark RDD filter function returns a new RDD containing only the elements that meet a predicate. So it basically narrows operations because it does not shuffle data from one partition to many partitions. So I'll go ahead and create an RDD which contains the first 10 numbers. Now from this RDD, I would only want the even numbers. So to do that, I can use the filter function. So on top of this numbers RDD, I'll apply the filter function and I will extract only those elements where the remainder is equal to 0, and then I'll collect the result. So this was our initial RDD, and after applying the filter function, we have extracted only the even elements. So the next function is intersection. So when we apply the intersection function on 2 RDDs, we will get only the common elements between the 2 RDDs. And the key rule of this function is that the 2 RDDs should be of the same type. So I will go ahead and create 2 RDDs. Right, so first I am creating an RDD with the elements 1 to 9. After that I am creating another RDD with the elements 5 to 15. Now what I'll do is I will apply the intersection function between these 2 RDDs and let's see what do we get. So we see that we have only the common elements from these 2 RDDs. So the common elements are 5, 6, 7, 8, 9. So these were some of the transformation functions. Now after that we also have something known as actions. So while transformations create RDDs from each other, but when we want to work with the actual data set, at that point action is required. So when the action is triggered after the result, new RDD is not formed like transformation. Thus, actions are Spark RDD operations that give non-RDD values. So the values of action are stored to drivers or to the external storage system. So this basically brings in laziness of RDD into motion. So now let's work with the first action task, which would be reduce. So the reduce function takes the two elements as input from the RDD and then produces the output of the same type as that of the input elements. So let's say I create an RDD for the elements 1 to 10. Now what I want is the sum of the first 10 elements. So I'll use the reduce function, and what I'll do is I will add each element with the next element, and this should give me the sum of all the elements in this RDD. So when you add up all the elements from 1 to 10, the final result would be 55. Similarly, let's say I create an RDD which would have these string elements Abe, Abby and Apple. Now what I want is in the final result, I would want a concatenation of these three strings as the final RDD. So let's again implement the reduce function on top of this RDD. So here what I'm doing is I am taking each string and concatenating it with each other. So this was our initial RDD which contained three individual strings. We have applied the reduce operation on this and we have got a final string which is a concatenation of these three individual strings. So after this we have the first function. So the first function, as the name states, basically gives us the first element of the RDD. So I'll create an RDD like this which contains these three elements Apple, BT and Beatrice. So I'll apply the first function on top of this names to RDD to get the first element, right? So see that the first element is Apple and that is what we have extracted. And then we have the take function which returns the first n number of elements from the RDD. So over here I create an RDD nums which contains these elements. Now let's say if I wanted only the first four elements. So I'll just type in nums dot take and then the parameter would be 4 since I want the first four elements. So here I see that I have extracted only the first four elements from this entire RDD. And then we have for each partition which basically executes a single function for each partition of the data frame. So let's say I create a Spark RDD with these elements 1 to 9 and each partition would have 3 elements. So 1, 2, 3 would come under first partition, 4, 5, 6 would come under second partition and 7, 8, 9 would come under the third partition. Now what I want is for each of these three individual partitions, I want the sum of the elements, that is 1 plus 2 plus 3 for the first partition, 4 plus 5 plus 6 for the second partition and 7 plus 8 plus 9 for the third partition. And this would be the syntax to do that. So on top of this RDDB, I am applying the for each partition function and I will be printing the sum of all the elements for each individual partition. So I'll hit enter. So we see that when we add 1 plus 2 plus 3 we get 6. When we add 4 plus 5 plus 6 we get 15 and when we add 7 plus 8 plus 9 we get 24. Right, so that was a demo on Spark RDDs. Now let us understand the various components of Spark ecosystem. So let me start with the Spark core component, which is the most vital component of Spark ecosystem. So it is responsible for basic IO functions, scheduling, monitoring and so on. And the entire Spark ecosystem is built on top of it. So now you know how important it is. So as we already saw, Spark supports different deployment modes. It can be deployed through Hadoop via Yarn, Mesos or Spark's own cluster manager. Now let's have a look at Spark's ecosystem library. So the library is composed of Spark SQL, MLlib, GraphX and streaming. So Spark SQL helps us in performing SQL-like queries to process the data. Then we have Spark's machine learning library, which eases the deployment and development of scalable machine learning pipelines like summary statistics, correlation and feature extraction. And graphics component of Spark helps the data scientists to work with graphs and non-graph sources to achieve flexibility and resilience in graph construction and transformation. Then we have the Spark streaming component, which allows us to perform batch processing and streaming of the data in the applications. And since Spark is polyglot, it can be implemented in Scala, R, Python, and Java. However, Scala is the widely used language. And when it comes to storage, we can store data over HDFS, local file system, and cloud. It also supports SQL and NoSQL databases. So now, let us deep dive into the Spark components. So we'll start with Spark SQL. So Spark SQL is a Spark module for structured data processing. And the code for Spark SQL can be written in Java, Scala, Python, or R. And Spark SQL helps to query data from data sources like CSV, JSON, Hive, and Cassandra. And we can also seamlessly mix SQL-like queries with Spark programs. So Spark SQL lets us query structured data as a distributed data set or RDD in Spark with integrated APIs in Python, Scala, and Java. Another good thing about Spark SQL is it provides unified data access, so we can load and query data from a variety of sources. Schema RDDs provide a single interface for efficiently working with structured data, including Apache Hive tables, bucket files, and JSON files. Spark SQL also has Hive compatibility, so we can run unmodified Hive queries on existing warehouses. Spark SQL reuses the Hive front end and metastore, giving us full compatibility with existing Hive data queries and UDFs. So we simply have to install it alongside Hive. Another notable point is it provides standard connectivity through JDBC or ODBC. So Spark SQL includes a server mode with industry standard JDBC and ODBC connectivity. And finally, Spark is also scalable. So Spark SQL takes advantage of the RDD model to support mid-query fault tolerance, letting it scale to large jobs too. Now let's have a look at some advantages of Spark SQL. So the execution of queries in Spark SQL is much faster than Hive. So let's say if it takes 600 seconds to execute a query in Hive, it will only take 50 seconds in Spark SQL. And there are no hurdles if you want to migrate the Hive code to Spark SQL. And as we already know, we can do real-time querying with Spark SQL. Now let's look at the Spark SQL architecture. So let's start with the data source API. So this is a universal API for loading and storing structured data. And it has built-in support for Hive, Avro, JSON, JDBC, and Parquet. It supports third-party integration through Spark packages and also has support for smart sources. Then we have the data frame API, which is a distributed collection of data in the form of named columns and rows. It is basically equivalent to a relational table in SQL used for storing data in tables. And it is lazily evaluated like Apache Spark transformations and can be accessed through SQL context and Hive context. And the next component is SQL Interpreter and Optimizer. So SQL Interpreter and Optimizer is based on functional programming construct in Scala. It is the newest and most technically evolved component of Spark SQL and provides a general framework for transforming trees, which is used to perform analysis, optimization, planning, and runtime code spawning. It also supports cost-based optimization and rule-based optimization, making queries run much faster than their RDD counterparts. And there is also SQL Service, which is the entry point for working along structured data in Spark. It allows the creation of data frame objects as well as the execution of SQL queries. So now, let's learn how to create data frames and work with Spark SQL in Spark. So we'll start off by learning how to create a data frame in Spark. So I'll create a list with these three elements. So the first element has 1 mobile and 50,000, the second element has 2 shoes and 4,500, and the third element is 3 TV and 70,000. Now, what I want is to convert this into a data frame where this will be the first row, this will be the second row, and this will be the third row. And to do that, I would have to use the toDF function. So on top of this object which I've just made, product, I will use the toDF function and I will give the names of the three columns. So the name of the first column would be PID, the name of the second column would be product, and the name of the third column would be value. So now let me have a glance at the data frame which I've just created. I will just type out product df dot show. So we have successfully converted this list into a data frame where this became a first row, this became a second row, and this became a third row. Now we'll go ahead and do some basic operations on Spark data frames. So here I am reading a JSON file as a data frame. So the command for that would be spark.read.json, and inside this I will give in the path which is student1.json, and I will store it in df. So df is a data frame. Now as we had already seen earlier, if you wanted to show the elements or the records inside the data frame, we will use the df.show function. And if we also wanted to see the schema of this data frame, then we'll use the print schema function on this data frame. So df.print schema tells us that this data frame has two columns. First column is age, which is of type long. Second column is name, which is of type string. So now what I'm doing is, with the help of the select function, I am extracting only the name column from the entire data frame. So df.select name. So this data frame actually has two columns, name and age. But if I want to extract only individual columns, then I'll use the select function. So df.select name, and then I'll show it out. So we have extracted only the name column. Now similarly, let's say I wanted to extract only those records where the age of the person is greater than or equal to 18. So for this, the command would be this. So on top of the data frame, I'll use the filter function and specify the condition that age needs to be equal to or greater than 18. So we have 3 records, but out of those 3 records, we get only these 2 because Janet's age is equal to 18 and Serena's age is more than 18. And then in the final command, we are grouping the data frame with respect to the age column, and I want to find the count of number of persons for each age value. So there is one person with age 18, one person with age 17, and one person with age 19. So these were some basic operations on Spark data frames. Now we will go ahead and apply some Spark SQL queries on top of the same data frame. So for that, I would actually have to create a temporary view. Command would be create or replace temp view, and then I will pass in the name of the data frame, which would be student1. So let's go ahead and apply our Spark SQL queries. So in the first command, what I'm doing is I am extracting all the records. So we have a simple SQL query, select star from student1, which gives us all the records from this table. Now similarly, if we wanted only those records where the age is equal to 17, this would be a syntax. So select star from student1 where age equals 17, and this is the result which we get. So now let's understand about Spark's machine learning library, MLlib. So MLlib basically consists of 2 packages. First is spark.mllib, which contains the original API built on top of RDDs, and it is currently in maintenance mode. The second package is SparkML, which provides higher level API built on top of data frames for constructing ML pipelines. And Spark.ml is the primary machine learning API for Spark now. So with the help of MLlib, you can implement statistical analysis, you can implement classification and regression algorithms such as linear regression, naive Bayes, and decision tree. MLlib also supports clustering algorithms such as k-means and Gaussian mixture. So there are multiple things which you can do with MLlib. Now let us implement a demo on MLlib. So let me start off by loading all the requisite packages first. So we will basically be implementing the linear regression algorithm. Now let me load the dataset and show you guys the schema of this dataset. So over here we are loading a CSV file with the name e-commerce customers, and we are storing it into a data frame, and the name of that data frame is ecom.ds. Now after that we have printed the schema. So you see that these are the different columns available in this data frame. So we have email, which is of string type, address, which is of string type again, avatar, which is of string type again, and then we have these double values: average session length, time on app, time on website, length of membership, and yearly amount spent. So we basically want to apply the linear regression algorithm on top of this yearly amount spent column. So this yearly amount spent column would be the dependent variable, and the rest of the double values would be the independent variables. So average session length, time on app, time on website, and length of membership would be the independent variables, and yearly amount spent would be the dependent variable. So now what I'll do is I will go ahead and select only these double values from this entire data frame. So I'll use the select function, and I will be selecting this yearly amount spent column as label. So I will name this column as label, and the other columns I'll be selecting the same, and I'll store this result in ecomdf1. After that, I'll use a vector assembler which helps me to take in all of these independent variables and store them in a single column and name that column to be features, right? So this is the syntax. So I'll type new vector assembler, and I will first take in all of the input columns, which are nothing but all of the independent variables. So these are all of the independent variables, and I will be storing them under one new column and name that column to be equal to features. And I'll store this in an object and name that object to be assembler. So after this, I'll apply this transform function on top of the ecomdf1 data frame. So over here, we are basically creating a data frame which will have just two columns. First is the label column, next is the features column. So this label column would be our dependent variable, and this features column has all of the independent variables, and we are storing that in ecomdf2. So now let me just show you guys how the data frame looks like. So I'll type in ecomdf2 dot show. So this is our final data frame. This is our dependent variable with the name label, and this is our independent variable features, which contains all of the independent variables. So after this, I will go ahead and create a new linear regression object and name that to be LR. So we can create a new linear regression object with the help of this linear regression function. Now after this, we will go ahead and build the linear regression model on top of the ecomdf2 data frame. So the function would be lr.fit, and I am storing the result in LR model. So now that we've built the model, let's actually have a look at the training summary. So over here, I will use the summary function on top of the model which we've just built, and I'll store it in training summary. And I would want to know the residuals of this training summary. So these residual values are basically the error in prediction, or in other words, the difference between the actual values and the predicted values. So over here, these are all of the residuals for the first 20 rows. Now let's also have a glance at some performance metrics. So we are printing the root mean square error, the mean square error, and the R square value. So we see that the root mean square error value is 9.92, the mean square error value is 98, and the R square value is 0.98.
So now let's see how to deal with different types of data. And now what I want to show you is how to deal with something called JSON data. So basically JSON is not binary file. JSON is one of the most widely used file formats, especially in the case of big data. Well, you see JSON everywhere. Yes. So JSON stands for JavaScript Object Notation. JavaScript Object Notation. That is called JSON. To put it very simply, it is the format in which you will represent your data as a key value pair. Right. So, and why JSON is important? Because there are many platforms who are going to give you the data in the form of JSON. We had many customers, for example. So there are customers who are dealing with this so-called IoT, Internet of Things related data. So if you have a customer who is actually dealing with IoT kind of data, then
what happens is that the data that the sensors are collecting normally comes in the JSON format. Not only that, there are many applications which will give you the data in the JSON format, because JSON is a widely accepted, popular, and standardized way of representing your data. So chances are very high that you will see the data coming in JSON format, and it is called a JSON object. So if you are a person who is coming from the object-oriented programming side, it's very easy for you to programmatically access the data. That is the advantage. So if I'm getting a text file, okay, the text file is not an object, right? So, but JSON is an object actually. So if you can actually call it in your program and natively work with this type of data. And this is primarily the reason why NoSQL databases like MongoDB are extremely popular. Now, if you go to the NoSQL side, you have a database called MongoDB. I'm quite sure that most of you could have heard about it. The reason why MongoDB is #1 in the market is because it stores the data as JSON. So that internally JSON, but yeah, representation is JSON, right? Because then programmers can directly play around with the data, right? So not only in the NoSQL side, in many areas, this JSON data is very important. So now our problem is that we have some JSON data and we want to read it and analyze it inside Spark, right? So let me do one thing. Let me show you a use case or a case study rather than just showing you this. So let me figure out where is the data first, okay? I think here we have the data. I just need to upload this data, okay? So what I'm gonna do, I will just upload the data, and that may take a while and I will explain it. Meanwhile, what am I going to do? So I will just drag and drop this. So I will take a small case. So when you want to run a Spark program in production, you package it. The only difference is that you package it. And for that, you are using SBT. And we have already demonstrated how to work with SBT, right? Any program that you have, you can compile it and get a jar file, right? You submit the jar file. That is a difference. No other difference. But you can also use the shell. There are people who use the shell also. It is not like a hardcore way, say that you must always use the jar file. Like I use shell all the time, not the jar side, because sometimes you just want to, see what is happening. So when you submit a jar file, that's not possible, right? So we had discussed SBT, right? SBT is the way to productionize your program. Yelp was the original company who invented this idea of local business listing of restaurants. So basically what Yelp does is it's like Zomato. You can find restaurants to eat, you can have reviews, and then you can book a table if you want, you can have takeaways and all these things. So basically it is local business listing, especially for the restaurants, right? Restaurant side. And so I can just search for something. For example, I can say, I want to find restaurants in San Francisco, and you will get. This is what they do. I mean, that's what it does. Now, even if you open a restaurant, you will get tons of information about the restaurant. Like you have the name, the star rating, the address, the phone number, the pictures, the reviews, reservation details, so many other things actually. So Yelp has a huge amount of data related to all the restaurants, right? Now, Yelp also allows you to sort of like download the data, right? So all this data that they have is public data. So you can actually visit their website and you can download all the data that they have. There's a file called a business.json, and that is the file. Now, the idea is when you download the data, it comes in the JSON format. And this is how the data looks like. So this is the original Yelp data. So basically, this contains all the restaurants, probably not all of them, but some of the restaurants which are listed in Yelp, right? And let's say our requirement is that we want to load this data into Spark, and then we want to ask some interesting questions about the restaurants, right? So we are interested in, loading this data into Spark and then answering some interesting questions. Let's say how to do that. Now, if you want to have a look at the data, you can see that every restaurant will have something called a business ID. That is a unique business ID. And then you will have this full address of the restaurant. Then you have this hours key. Within hours, so how hours is a key, then Tuesday is the value. Again, it is nested. Tuesday becomes the key, close becomes the value, and then you have all the days and all. Then you have categories, then you have a city, and then latitude, longitude, so many other things. So if I scroll down, some of the restaurants will have much more interesting information. For example, I don't know. There is something called business info. Let me just try to get it, okay? City review count, attributes. Look at this. So this attributes is something very interesting. For example, these are two restaurants and I'm just showing you the attributes. In the first restaurant, the attribute says it allows no parking, no street parking, no valet parking, I guess. Accept credit cards, true. Wi-Fi, no. Price range. So this is the attribute of one restaurant. But if you look at the attribute of the second restaurant, see there is more, right? These are all the attributes. For example, what kind of a music do they provide? What kind of an ambience do they have? And classy, trendy, upscale. Do they support smoking? Accept credit card, takeout, happy hour, outdoor seating, Wi-Fi, diner. So many things are there. So the point that I'm trying to tell you is the data is not really properly structured. If you try to put this in a table, one restaurant may have 20 columns, the next restaurant may have 100 columns. Because that is how the business is. When you are listing your restaurant in Yelp, Yelp cannot say that your restaurant must have 10 features or something, right? So every restaurant will have its own different features and options and all. So this data is not really something which we can easily analyze and put it in a row column structure. But anyway, let's see how to play with it in the Spark SQL side. So I also need another file. Yeah. So what I'm going to do, so the first question will be naturally, how are you going to read it, right? So let me start the Spark shell first. So this is semi-structured data. So JSON files are actually semi-structured. They fall in the category of semi-structured data. Now, in the traditional world, let's say you are not using Hadoop or Spark or something, like you are in the traditional world. So normally what people do, there are JSON parsers. You can use something called a parser library and you can read it. But the problem is that will work if your data set is kind of like small, right? So now what I want to do, I want to read the data. So what I'm going to do, I will simply say spark.read.json business.json. So the data is in Linux, not in Hadoop, right? Let me just upload it. So how do you copy that? HDFS, DFS - put the file to user training. Okay. And now let's run this. So, by the way, this file has a lot of columns and a lot of data, but look at what I have done. I simply did a spark.read.json, and gave the file. All I did is I used this method Spark read JSON and then said that, you know what, this is the file you want to read it. And Spark automatically read the file, sampled it, figured out the schema, and created a data frame for me. So the data frame is already created. Its name is BIS. Now, if I show you the data frame, you may not be able to understand because there are too many columns actually. So I mean, like it doesn't fit on the screen really, but the data frame is there. Now, what is more interesting is that if you look at the schema of this guy, look at the schema. All the column names and their data types, everything is automatically inferred. Don't you think this is really interesting? Because you don't have to spend any number of time understanding what is the structure, where it is, how many columns are there. All you need to do is that simply say spark.read.json, right? And there are nested columns, so that is very interesting, right? So the top column right now, it says there is a column called attributes. Within that, there is a column called alcohol. So if you want to get this alcohol column, you can say attributes dot alcohol because it is a struct data type, right? And all the columns are red, so that is the beauty of it. Now, what I want to do, so this is my data frame. So I will say create or replace temp view, and I will just call it as BIS. So what I'm going to do, I'm going to register this JSON file as a temporary view, right? So that we can run SQL queries, right? And once I have it, you know, I can simply start running SQL queries. For example, let's say we want to know how many restaurants are there. So I can simply do a select count one as business from BIS. So there are a total of 61,184 restaurants, right? You want to get the group state-wise number of restaurants. So what I'm going to do, I'm saying that, you know, select state comma count one as business, group by state, then show 10. And see, it is faster, right? It is not like Hive. You have to understand that you are looking at 61,000 lines of data, that too nested JSON. And if you run a query, the answer is getting in less than a second or two. That means it is fairly fast. It's not like Hive, right? Well, so what is this query? You are basically getting the state-wise number of restaurants, and I'm just doing a show 10 to get the top 10 restaurants. And let's also do a order by query. I'm again selecting the state, count one as business. I want to group by state, order by business in the descending order. Okay, and we want a show 10, let's say. See, very, very fast, right? So you're basically ordering the data based on the number of restaurants of each state. Like Arizona has around 25,000, Nevada has 16,000, etc., etc. Right? So you can run any SQL query that you want. And I just wrote some queries. I will share this with you. For example, you can actually write any type of query. So this one here says, I want to select the name, stars, review count, where the city is Las Vegas, order by stars in descending, review count descending, limit 5. Or let's do a show 10. Do we have a show 10? Yeah, only 5 are there, right? Total. Yeah. So the basic idea is to demonstrate that it is very easy to work with JSON data, especially when you're having Spark SQL, right? Google, download Yelp data, you will get first link. Okay. Is data frame BIS changed? No. What is a data frame behind the scene? A data frame is nothing but an RDD. So the original data frame never changes actually when you run a query, right? Anyway, you got the idea, right? It's very easy to play around even with nested JSON data if you have, and all you need to do is spark.read.json, and then you can work with JSON data. Can I save the table in Spark? Yes, you can. Okay, I will show you that in another example. Dealing with XML data. Okay, so let me see if I have the file available. So I just need to upload it only, HDFS -put. I will just upload the data, okay? Then I'll show you what I'm talking about. Training. So now the question is that what if I have an XML file to play around with, right? Well, you are not running Hive queries as such, you are running SQL queries, but you can integrate with Hive to read from Hive, right? But let's say you want to, read XML data. Well, couple of things you need to understand is that even though Spark SQL supports reading XML files, it may not work in every possible scenario. So I should also give you the real picture, right? In the sense like XML is probably more common than JSON, right? So there are many cases where you get XML files as the output, right? You go to all the ERPs, right? For example, I mean, simple examples I'm giving. Let's say you are using something like Tally. Tally is an ERP, right? So Tally has this TDL file, and if you read it, it will by default give you as an XML if you want to process it further, right? So XML files are very common, and Spark SQL has a way of reading XML files. Now you can try that. Let's say in your project, your requirement is that you have a bunch of XML files and you want to read it. Yes, please, you can try that. But in case if it doesn't work, the XML reader doesn't work, then you need to write your custom parser for reading. And we have done that in many cases, right? We had a client 24/7. So 24/7 is a BPO or a call center company. So basically they provide this customer services like call center, chat support, etc. to clients. So I was working with them in one of their project. So what they do, they have this call data. So let's say you're calling customer care, right? What happens? When you call, you will be redirected to this IVR, and the IVR will say that press 1 for English, 2 for this, 3 for that. So you do that, right? So that is recorded in something called a VXML or a voice XML. So basically that XML file will contain the metadata, the duration of the call, what the customer pressed, 1, 2, 3, and how long he took to press, etc. So this data, so they had like millions of records in this data because they had a lot of call center business. So every day what will happen, we will get this data, this VXML, right? And we were not able to convert it using Spark. So that's what I'm saying. In all the cases, the XML conversion will not work. And they wrote their own parser to convert the data. But just to show you an example of how to do this. So this is the XML file that I'm going to use. And this is a very simple XML file. It's not like very complicated or something. So an XML file normally has a root tag and a row tag. So this employees is called the root tag. That is like the outer tag. And then you have this employee, that is the inner, or we call it as the row tag. So when you want to read an XML file, you need to identify what is the root tag and what is the row tag. Once you identify that, well, directly Spark doesn't have any capability to read an XML file directly. So what you need to do, I will exit the shell. And again, search for Spark XML Databricks. So there is an XML data source for Apache Spark. and you can use it for reading the XML. So what you need to do, you need to say you want to start the Spark shell. Okay, so normally you will simply say Spark shell and that will start it. But now what you need to do, you have to say, I want to start the Spark shell hyphen packages, and you then give the name or the Maven coordinates of this Databricks Spark XML package. So if you are wondering from where I got this, it is from this website. So if you go here, it will be written how to start. See? So you have to simply say Spark shell and this command, right? This is the same command I'm typing here, right? So you just say Spark shell packages and then you just give this. And what will happen if you run this? It will download this XML dependency to your session. It is basically going to add this XML package or the XML parser to your Spark session. And then you will be able to read it. So I started the Spark shell. So what am I trying to do here? I'm saying spark.read.format. Okay, and then I'm gonna give the name of the reader, that is nothing but com Databricks Spark XML. What are the options? Infer schema true, because I don't want to mention the schema. Please find it automatically. What is the root tag? Employees. What is the row tag? Employee, and then load the data. So this will automatically read and convert your XML file into a data frame structure. But so if I look at the data frame, right, that we just got, what is its name? Employees df.show. The data frame looks nice, but the problem is that if you look at the first column, the address column is actually struct, I think. If I look at the schema, the address column is of a data type called a struct, which means within the address column, you have 3 more columns: city, country, pin code. That is how it will read. So if you want to run SQL queries and all, one thing you can do is that you can say address.city, address.country, like that you can say, right? But an easier way will be that, you can again expand it. So I can simply say where, I just want to select employee number, employee name, address dot city, address dot country, etc. So you see the new data frame. This has the expanded columns, meaning it's easy for you to work on the data, right? And now you can do what? You can register it as a view, start running your SQL queries. The same story follows after this, right? So the point is how to use this XML package. So what you need to do, start your Spark shell with the package option. And once you have it, read the data like this. You just need to give the name of the reader, what is your root tag, what is your row tag, and the file name, and then you will be able to work with it, right? How do you actually copy files from Linux to Hadoop in production environment? Well, if the file is already in Linux, we do the same thing. So let's say you already have a file in Linux, you want to put it in Hadoop. We do the same thing, HDFS, DFS put, but that situation is very rare. So normally we have data ingestion techniques. So if you have heard about Scoop, Flume, Kafka, Kinesis, so there are data ingestion tools which can ingest your data. Package option is same. Package argument is same, right? So right now I'm using this XML argument. Now there is a file format called Avro. Okay, so right now you may not have it, but I'm just saying, let me just show you. There is a file format called Avro. Okay, Avro is a serialization format, right? It is used to serialize your data, Avro files, right? Well, the representation is different. Like JSON is key value, Avro is not key value. Avro is proper serialization. right? JSON is not serialization. JSON is what? You are just representing your data as an object. Avro will actually allow you to compress the data, save some space if you want. Well, we are not going to discuss Avro, but my point is, if you get an Avro file, imagine. So let's say you are working, you got an Avro file. The file format is in Avro. Then you will be thinking, okay, now I want to read Avro. What will I do? So there is an Avro reader. So you can search for these things, right? So in fact, you can actually search in the GitHub Spark scikit-learn, that is for machine learning, Spark CSV, and Spark Avro. Probably there is a direct method now. There is a Spark Avro. See? So if I get an Avro file, you can read it. It is archived. I don't know why. So some of the things you will learn while you are working. So not everything can be taught also, right? Also, it doesn't make any sense. So I'm taking a class where I'm showing you how to read 100 different type of files. That's useless, I believe, right? It doesn't make any sense, right? Some of the common formats, yes, it makes sense. So even though you learn all this, probably when you start working in production, you will get a file which nobody is able to understand. Even nobody could have seen that format again. You need to figure out how to read it. If Spark is not able to read it, use a parser. You write your own custom code, convert it, and then read it, right? So those are some of the challenges we face actually. For XML, the option is same, but for other formats, so this is how you deal with XML data. We can use third-party library to load and implicitly infer XML schema in a data frame. We saw that already, right? And dealing with Parquet files, right? Parquet is a compression format. So it is nothing but compression. So when you're talking about compression techniques in big data, there are three major formats that we have. There is something called RC, then there is something called ORC, then we have something called Parquet. These are the three formats that we have for compression. What is the difference? Well, beyond the scope of our discussion, but I will tell you, ORC is the best compression format so far. ORC stands for Optimized Row Columnar Format. So far, the best compression format is ORC. No questions asked. Then the next one will be Parquet. Then the next one will be RC. In fact, RC is sort of like very old. So this is very old. I don't think much people are using it. This one. Mostly people prefer ORC or Parquet. Now again, there is this competition. If you are using Hortonworks, you will see ORC more. If you are using Cloudera, you will see Parquet more. So Hortonworks was originally, I think they were contributing a lot to the ORC project. So when you start working on a Hortonworks platform, right? Hortonworks will say that, you know what, if you want to compress your data, please use ORC format. And even Hive and all supports ORC extremely well. And ORC is the best, no questions asked. ORC can even do things like indexing internally. So it's one of the best formats ever created, no questions asked. But when you go to the Cloudera platform, Cloudera will say that, well, not use ORC, use Parquet. Well, you don't have to understand much about how this is happening. The only thing is Parquet files are compressed files, right? Heavily compressed, right? So I think Parquet will achieve around 50% compression. Like if I have a 100 GB file, it will compress to around 50 GB. And this is really, really important because you never want to store the data as it is on big data clusters, because that will consume a lot of space for you, right? So people are always searching for ways to reduce the total file size, right? And Parquet is what you have in your syllabus because you are learning Cloudera course, right? You are learning CCA 175. So, but yeah, ORC is very nice. I personally prefer ORC over Parquet in any situation. But Cloudera's official documentation says use Parquet. Cloudera likes Parquet. So we are going to learn Parquet for sure, right? So the point is that if you have a Parquet file, how do you read it, right? I think Spark has an ORC reader now. So if I say spark.read dot, you can read ORC or you can read Parquet. There is no RC reader, I guess. RC is no longer there. But let me show you a sample so that you understand how this Parquet files looks like. So people will be thinking like, what do you mean by a Parquet file? Do we have the file? There is a file called babynames.parquet. Can I upload it? Babynames.parquet to user training. Oh, it's already there. Babynames.parquet. So the point is, this is the file babynames.parquet. Okay, and you cannot read it normally. So if I try to read it, you cannot, because Parquet is a specific format, right? Using your normal text editor or anything, if you try to read it, you will never be able to read it as such, right? So that is why you can use the Parquet reader. So I can simply say val babydf equal to spark dot read dot Parquet babynames dot Parquet. Very easy. And if I do a baby names, well, this is how the data looks like. You have an year, the name of the baby, the probability, and the sex, boy or girl. Some sample data I have, but you got the idea anyway, right? So you will be using this reader for Parquet. That's my whole point, right? So I told you that Spark SQL has excellent connectivity options, to read the data from things like RDBMS, right? So how can you read the data from RDBMS? Let's have a look at it. Okay, so I will show you that. And then Hive is also there. We will look at Hive as well, don't worry, right? So Ravi is asking, generally NoSQL, what format they provide the data? It depends on the platform. Ravi, like MongoDB is JSON and BSON. Cassandra, if you read, it's like tables only. Cassandra has tables normally. So you can read it as in the proper structured format itself if you want, right? So we have a case study in dataset also. But where is this RDBMS thing? If you guys allow me. Okay, so we have it. I just need to search for a file, then I will tell you what we're talking about. MySQL-connector.java. MySQL-connector.java. Okay. Inside this .bin.jar file. Okay, so we got it. Right. So let's do one thing. Let us first verify whether MySQL is running on our Cloud Lab. So in the Cloud Lab, we already have the MySQL. And let me try to log into that. So I'm just going to type this command. Okay, so we have logged in. So we already have MySQL running, and let us see whether MySQL has some data. Show databases. Oh, very well. We have a lot of data actually. So there is a retail DB, and I can say use retail DB. Show tables. Customers orders. Select star from orders. Well, you got the idea. So I have a MySQL database, which is running on the Cloud Lab, right? And it has a database called a retail DB. Within that, there are some tables. So I just did a select star on one of the table called orders table. You can see there are around 68,000 rows, and there is an order ID, order date, the amount, and the order status, kind of like a schema. Now, what is our requirement? I want to read this table into Spark directly. Well, I want to read it. How can I do that? Now, if you want to do this, the first thing you need to understand is that you need the MySQL connector or MySQL driver. You understand that, right? Whenever you want to talk to any RDBMS, be it Oracle or MySQL, you need the JDBC or DBC driver. Then only you can talk. Point number one. So I'm going to verify whether I already have downloaded it or not. Let's quit from here. CP MySQL. There is a MySQL connector.jar. So I am assuming this guy should work. Okay, so 5118.jar. Where can you get it? You can go to Google, right? So you can just go to Google and do what? Download MySQL connector jar, and the first link that you get is the MySQL download page. That is from where you can download. I think you guys understand it. So I already have a MySQL connector Java 5118.jar. So this is already there, and let's see if we can use this. Now, how do you use it? First, exit from the Spark shell that you have, and you need to start the Spark shell with a couple of arguments. Let me show you what it is. So we will say Spark shell. Let me just copy paste it, okay? MySQL connector Java. What is the version we are using? 5118. 18.jar. .jar. Yeah. So what I'm going to do, I'm going to start my Spark shell with this argument. I'm going to say that start the Spark shell, the driver class path, and the connector jar file is this. So basically it will add the driver to the session. That is basically what is going to happen. Let's try that. Okay, started. But now the question is that how do I read the data, right? To do that, what you need to do is, see, you have to create something called, Java utilities properties object. So there is a Java util properties class. All you need to do is you instantiate this class and then you create an object. That object is called prop. It can be any name. Why are you creating this object? Because this object has some attributes. Using that, you can pass the RDBMS connection details like the database name, table name, etc. So first step is that you create this object and then you put things like username, password, and all. So what is the username, right? To connect with MySQL. I think it is here. Password is this. Driver class is this. URL. What is the URL to connect? So it will be localhost, right? Because it is running on the same machine. Localhost. Database is retail DB. Table name is orders, and then it should work. So let's try this first. No suitable driver. So I guess the driver we have used did not work the way we expected. Okay, so let me use a different driver, okay? And see if this all works. So there is a connector, this should work, I'm assuming. Too many folders are there actually. Okay, so now I have added the driver. I just need to restart the session. See what happens now. Now can you read? This is giving me driver error now. For sure. I will just upload one more sample driver I have and see if that works. If not, we will figure it out. Don't worry. Okay. So I will do a start. What is the name of the file? MySQL-connector-java- 5147. The driver version is correct. I have been using the same version for quite some time. The driver class is also correct as per me, because I had been running this for quite some time. So JDBC, now it is trying, it read. So it read, I mean, there is a warning, but it read. What was the error? I did not add this slash. So in the connection string, right? So how do you read it? So like I said, you have to put the username, password, the driver class, and the URI. And I read it as empdf. So if I do a empdf.show, that's it. This is your data from MySQL, right? But tell me one thing. Why do you want to do this? What is the practical scenario? Why do you want to read the data from, say, MySQL into something like Spark? Why? Why do you want to do this? So no, it's not for speed, right? See, MySQL in its own class is very fast, right? So you are using MySQL as an OLTP system, RDBMS, right? And it's really fast, faster than Spark for sure, right? So you are not reading this so that Spark will become faster or Spark will become better. That is not the idea. And also we do this if you want to do things like join operation, like you have a very large data set, like a data frame, and you have a small data that is already lying in MySQL. You want to do a join operation, this is what you do. Because that is the only situation. Otherwise, you don't really read a lot from RDBMS and then process the data, right? So one thing that people have been asking is that how do you actually connect with Hive? Okay, so the question is like, I have Hive, and how do you access Hive? So let me do one thing. Let me start Hive and check whether we have something. So Hive is here. If I do a show databases, okay, there are some databases, and let's see if I can use some of them. Use movie analysis, show tables. No tables. Intellipaat. Let's look at this. The only thing is that, okay, so there is this retail DB. I think probably we can use it. This should have. Hey. Select star from departments. Okay, so some data is there, I think, in departments. So the database name is what? Retail DB departments. So there has been a lot of confusion around integrating Spark SQL and Hive. So as per the slides, when you say you want to integrate Spark SQL with Hive, right? Well, one way to do this is that you install Spark and Hive everything in your setup. So let's say you are using a new setup, right? So you install Spark, you install Hive, right? And Hive has a configuration file called Hive site XML, right? So there is a file called Hive site XML, and let us look into that. Hive installed Hive/conf. So can you see there is the file called hive-site.xml file. So typically what people do is that if you are working in a big data infrastructure, this will be done by the administrator. What he will do, he will copy this Hive site XML file to the Spark folder. So if I go to Spark conf, it should be here. So here is the Hive site XML. So first thing you need to do is that you have to make sure that you copy the so-called Hive site XML file from the Hive configuration folder into the Spark configuration folder. And you don't have to really worry about this because see, when you are working in a company, this will be already done and set up by your administrator, Hadoop administrator or Spark administrator. Now let me see what we are going to do. So remember we have this Yahoo stocks example. So we are going to use the same thing in this example. So I'm going to just say Spark shell. Start the Spark shell. And remember we were creating the data frame by reading the RDD and then converting it. I guess you guys remember. So we are going to do the same thing. Then let's do this manually. sc.text file.
So you just read it and see what is there. The data is read. The Yahoo Stocks example is already there. So I'm just going to run this again. You read the data, you extract the header, right? And then you convert it. And then you're defining the case class. Remember this? And then you will convert this to a data frame called stock price. So till this, I think it is here. It is called Yahoo stock data frame, but we are calling it a stock price. That's also fine. Right. And you can register it as a table and then write queries. We have already seen that. That's not the problem. Yahoo stocks data frame. Just a processing engine. Right. And therefore, let's create a Hive table using Spark SQL and store the data into the Hive table. So if you want to connect from Spark to Hive, you need to create something called a Hive context. So I'm just going to say, we're going to say stock price dot show. Okay, we have the data. So first thing that you need to do is that you need to create something called a Hive context. So I'm going to my Hive context equal to, you will say new org Apache Spark SQL Hive dot Hive context, and you will pass the SC. Right. So you are creating an object called a Hive context object, and you are passing the Spark context in doing this. Now you may be wondering, why are you creating this object called Hive context? This will allow you to connect with Hive from your Spark SQL session, right? So first step is that you create this object, and now we will use this Hive context for operations on the Hive table. So if you want to create a Hive table, you can simply say my Hive context.sql, and then you can simply say create table, the Yahoo stocks table that you want, right? So let's say you can say my Hive context.sql, and you can simply say the create table statement, right? So I can say create table Yahoo stocks one. Yahoo stocks, let's call it as 100, okay? Because probably the table will already exist. String open, that is float, high, that is again float, L means low value, float, and there is adjustment, that is also M is integer, then there is adjustment, which is float. So this is your query. So what it says, create table should work, right? Not two things. Yes. Yes. So once you create a Hive context, using the Hive context, you can say dot SQL, and then if you run a create table command, this will be created in your Hive actually. And now if you want to load the data, let's say into the Hive table, you can again use the same set of commands. For example, you can say my Hive context.sql load data. So let's say my Hive context.sql, I can say load data in path
And where is the location? You can say user training Yahoo stocks.csv. Yahoo stock 100. Yahoo underscore stocks 100, right? Not stock. It is stocks 100. Yes. See? So now it is loaded the data, right, into Hive. And we can actually go to Hive and verify this. So what I can do, I can create one more session. And then log on to Hive. So let's start Hive. And then verify this. Okay. Show tables. Yes, here is the Yahoo stocks 100. Select star from Yahoo stocks 100. Here is the data. Well, my data format was wrong. That is why it is dumping it as null, but you got the idea, right? So we didn't mention the delimiter in the create table statement. That is why it is considering each line as a column. You should also say delimited by comma, right, in the create table. That is why it didn't understand, but you know the data is getting loaded. You got the idea, right, what to do. So this is one way to work with Spark and Hive. So what did we do? Let me show you this here again. You create something called a Hive context object. You can say new Spark SQL Hive context. And once you have the object from the Spark SQL command line itself, you can run all the Hive queries that you want actually. Okay. How can we read already existing table in Hive? I will show you. So the point is, this technique that I'm showing you, this creation of Hive context and all, is a bit old. Now, in your slide, actually, this is what we have. If I look at your slide, this is what we have. But this technique is a bit old. How do you know that it is old? I can actually prove it. When you're creating that Hive context, you will get a warning. So where was the time when we created it? See, let's say you're creating this Hive context, right? You will get a warning. Let me show you. See, warning. There was one deprecation warning, rerun with deprecation. So it is giving the warning saying that, you know, this creation of Hive context and accessing the Hive tables using this Hive context, these techniques are actually a bit old. In the latest versions of Spark, the Spark session itself supports all this. Let me show you that. So ideally what you should do, go to the Spark website, and then you have documentation. Let's pick up our version, that is 231. And in the documentation, if you scroll down, there is Spark SQL. In Spark SQL, you have run Parquet Hive tables. Very interesting. So this is what you should do ideally. And when I'm working, this is what I'm seeing. Most of the times people are using this technique. So Spark SQL also supports reading and writing data stored in Apache Hive, right? So that is what we are doing. Configuration is done by placing Hive site XML or core site XML in the Spark configuration. Now, how do you do this is very, very easy, actually. So you have to create a Spark session. Now, we already have the Spark session, so I don't have to worry about this, right? Now, if you want to read, all you need to do is this. So I can simply go here and I can simply say spark.sql and I can say select star from I think this should work. See, You don't have to do any of this, like creating Hive context and doing this, that, and all. If you want to read a Hive table, very simple. Simply say spark.sql and whatever query. So this will directly read from Hive. I'm reading from Hive because this Yahoo stocks table is in the Hive. Now, what if your table is inside a database? So let's read it, right? We had a table, right? Retail DB departments. So you want to read that? So very simple. If you want to read that, all you need to do is this. Select star from retail DB dot departments. So some Spark versions have a bit of warning, don't bother about it, but you are able to read it directly, right? So select star from DB name dot table name, and the data in the Hive table is now available as a data frame to you. So it is as simple as that, right? So look at this table. This it is able to read properly, right? You can get the department and the ID name, right? So in the Spark version 2, especially when you start with 2.2 and 2.3, what is the recommended way is that you can directly use the Spark session to read any table from Hive. So this is one thing you will be interested to know. The second thing you will be interested to know is that how can you save it back in Hive? I have a data frame. I want to save it back. So what was the name? Yahoo stocks, right? We created a data frame, right? Stock price. Okay, if we delete it, let me read it. We need some data to play around with, right? Let me just verify. What I'm going to do, val ret equal to spark.read.csv, and let me just give the data. Oh, very nice. I think there is a one column data, some data that we have. I just read it, right? So there is a retail sample data in Hadoop. I read it into Spark. I say spark.read.csv. I got the data. Now my intention is I want to save it in a Hive table. How can I do that? Right. It's actually very simple. Let me show you. Yes. So you can simply say ret dot save as table. RET table, something like this. Why it is saying, oh, we need to import probably save as table, right? So sometimes you need to save, import certain libraries. I will tell you when you need to import what, but let me just import these standard libraries. I will explain when to use what. Import org.apache.spark.sql. Save mode. Okay, now it should work. Hive records, read table. See, Hive records. It got saved as a table. This is the command I ran, right? The command I ran is this. So Hive records is the table name. So once you have a data frame, RET is my data frame. You can say write mode, okay, save mode override. So what is this? When you're saving a data frame in a Hive table, you can mention something called a save mode. And there are 3 save modes: append, overwrite, and replace. I think the third one is ignore, right? Because in Hive, when you are saving the data, either you can append the data, or you can overwrite the data, or you can ignore the data. So when you are saving a data frame, so right now I'm saying that I want to save this data frame called RET. The save mode is overwrite. So if there is a table already I want to overwrite, simply say save as table, it will save it in a Hive table. That's all you need to do. So my whole purpose in demonstrating this is that use the Spark session for Hive integration. If you want to read the data from a Hive table, you can simply say spark.sql and then anything that you want. Any table in Hive and any query in that table will use Spark engine to read the data. If you want to store the data, permanently in a Hive table, say write mode, overwrite, or append, save as table. That is how Hive integration works. Okay, so let's discuss a little bit about performance tuning, right? Well, performance tuning may not be something which can immediately have an impact on your learning, because see, things like performance tuning will come into picture when you start working and you work for an year or two, and then when you want to dig deeper, because performance tuning is done if now your program may run in any way, but later you want to improvise on your program, right? So for some workloads, it is possible to improve the performance by either caching data in memory or tuning on some experimental options. Now, remember we discussed this caching technique in Spark, in RDDs. The same thing you can use in Spark SQL. Meaning, you have a data frame, and let's say you are running a lot of queries on the data frame. You can simply say data frame dot cache. What will happen? The underlying RDD will get cached, right? So Spark SQL can cache tables using an in-memory columnar format by calling spark.cache table or data frame.cache. Any of this is fine. So when you cache a data frame, what will happen? The internal RDD, which it is related to, will get cached. And if most of your queries are on the same data frame, it will be ideally faster. That is what is going to happen. Then Spark SQL will scan only required columns and will automatically tune compression to minimize memory usage and GC pressure. Right. So caching is a good technique. You can call spark.uncache table to remove the table from memory. So if you are registering the data frame as a temporary table, then you can say spark.cache table, right? This can be used if you are registering as a temporary view, create or replace temp view, right? If you're done with it, you can say spark.uncache table. That is also possible. And when you're caching the data in memory, configuration of in-memory caching can be done using setConf method on Spark session or by running set something equal to something. So when you want to cache it, either you can say set Spark SQL in-memory columnar storage compressed true, right? So when you do this, what will happen? Spark SQL will automatically select a compression codec for each column based on the statistics of the data. This is really helpful because if your data is in the columnar format, right, row column format, each column will be different, right? For example, we have some compression codecs, like there is something called ELZO, Snappy. These are all compression codecs, and they will work really well if you know how the data is. For example, imagine there is a column called a gender. there is a gender column. Now the gender column can have what? Maximum 3 values, unique values, male, female, or you don't want to provide the information at all, right? So the compression that you use in the gender column compared to, let's say you are compressing on a transaction ID column. Transaction IDs are what? They are having millions of unique values, right? So depending on the data that you have in a Spark SQL data frame column, Spark SQL will automatically use the appropriate compression codec. To do that, you need to simply say Spark SQL in memory columnar storage compress true. If you do that, it's gonna cache it and compress it as well. That is one technique that you can use. You can also say Spark SQL in memory columnar storage batch size to a value something like 10,000. It controls the size of batches for columnar caching. Larger batch sizes can improve memory utilization and compression, but risk OOMs when caching the data. So what is this property? This is the batch size. So if you say 10,000, the batch size is 10,000. So it will start compressing 10,000 batches, right? So if the batch size is really big, you may get a out of memory error. Otherwise, this is also a good technique you can use. Following operations can also be used to tune the performance of query execution. What is it? Spark SQL files maximum partition bytes. The maximum number of bytes to pack into a single partition when reading files. So what happens is that partitioning is also applied to Spark SQL, right? So when you're saying that I'm reading a JSON file or I'm reading a Parquet file or a CSV file, what is the maximum partition? The default is 128 MB because by default the partition is set to 128 MB. Now you may be wondering why this partition and all are really important. It is really important. In Spark SQL, we have a shuffle. So I will discuss it, the last property. Partitions are really important. And what is the second property? Spark SQL files open costlin bytes. The estimated cost to open a file measured by the number of bytes could be scanned in the same time. This is used when putting multiple files into a partition. Right. So why this property is important? So if you're having a lot of small files, then this property is important. Otherwise, it is not really important. So what this property says, it gives you an estimated cost to open a file, right? So for example, I have 1,000 or 2,000 files, and I want to read them, all of them together. Right. So how much time should be allocated for opening and sampling and reading the file? That is this property. Spark SQL broadcast timeout in seconds for the broadcast wait time in broadcast joins. So there is a technique called a broadcast joins, okay, that we use in Spark SQL. Maybe not really important right now to you. So you can set a timeout period for that. That is this broadcast timeout period. And what is the Spark SQL auto broadcast join threshold? This configures maximum size in bytes for a table that will be broadcast to all nodes when performing a join. By setting this value to -1 can be disabled. Note that current statistics are only supported for Hive Metastore tables. So probably this broadcast join is important for you. So let's say you have two data sets. So there is a file 1.csv and there is a file 2.csv. And you are saying join and you read it as a data frame. Okay. So you said df1 equal to this. And here you said df2 equal to this. Right. Now you are saying that join df1 comma df2. You are writing a join operation. No problem. This file 1 CSV is, let's say around 20 GB. File to CSV is, let's say, 40 MB. Small file. So the point is that if I simply say join data frame comma data frame 2, the join operation will happen, no doubt about it. But if I want to make my join operation more efficient, I can do something called broadcast joins in Spark SQL. So you just need to use a keyword and then it will do something called a broadcast join. What is the advantage of doing a broadcast join is that when you do broadcast join, so this data frame 1 is 20 GB, right? Imagine data frame 1 is lying on 33 machines. Because it is a very big file, it is divided into what blocks, and let's say the data is lying on 33 machines. Data frame 2 will be normally lying on only one machine because it is a very small file. When you do a broadcast join, what will happen? It will take the smaller file, that is this data frame 2 file, and broadcast it to all the 33 machines where data frame 1 data is there. So your joins are faster. So basically the smaller file is taken and then it is broadcasted to all the machines wherever there is a part of the bigger file. So your join operations we have seen becomes 2 times, 3 times faster. This technique is called broadcast join. And what is this property? It is telling you what is the broadcast join threshold, right? So if you say 10 MB, the threshold, if your second table is less than 10 MB, it will be broadcasted. If it is more than 10 MB, it will not attempt broadcast join. So ideally, we can keep it less than 100 MB. So like 40 MB, 60 MB, the threshold, that will speed up your join. But if it is too big, that is also another problem. Like if your file is like 3 GB, you cannot broadcast to all the machines. That will again have a lot of performance issues. And this broadcast timeout is, you can set a timeout. And after that, if the join did not complete, it will abandon it. Actually, the last property is called Spark SQL Shuffle Partitions. This configures the number of partitions to use when shuffling data for joins or aggregations. And this is very important, right? It's very common that you have something called shuffle operations. Like you are going to join 2 tables, right? If both the tables are really big, and when the join operation happens, a lot of data shuffling will happen, right? And that is very common. During the join operation, it will happen. Now, this property set how many partitions maximum you should use for your shuffling and join operations. And ideally, the default number is 200. Sometimes we keep this number even more than 200. That is recommended actually. Right, because Spark SQL also has a small drawback. If the partition size is more than 2 GB, your shuffle operations will fail. We always see this error. So the problem is, let's say you have a 10 GB file. Okay, and let's say you created a data frame. You said df equal to spark road read.csv. And then you read the file.csv and you created it. Now, what is the size of the file? 10 GB. Imagine that you read it as 2 partitions. So what will happen? You will have partition 1, that is 5 GB. Then you will have partition 2, that is again 5 GB. Now, this is fine. I mean, you may think this is fine, but the problem is that when a shuffle operation or a join operation happen, it will throw an error and it will not work. Why? Because the partitions, if the partition size is more than 2 GB, it cannot support shuffle or join operations. Then what will you do? You can say repartition. There is a command called repartition. So already my data has 2 partitions. I can say repartitions 10. What will happen? Your data will get repartitioned to 10 partitions. So these are some of the things which will become very clear to you when you start working. Maybe not immediately you will understand this, but the size of the partition, the number of partitions to be used, these all have a very strong impact on your performance. Any questions on these properties? Anything that you don't understand, let me know. On these properties we were discussing. So this can be dynamic or static. These properties can be set in a static file, or from the command line also you can set it. But it is very rare that suddenly you receive a big file. It doesn't happen like that, right? These are all batches, right? So you know that how much data you are going to process, and accordingly. Now, see, if you were already getting 100 terabyte file, if it becomes 200 terabyte, you don't have to do anything special actually. Like once it crosses a certain limit, even though the file size becomes bigger, it's not a big deal. But if you were getting very smaller files and then all of a sudden you get a big file, then yeah, you might have to rewrite your code in that case for performance. So some of these properties, so the problem is that end of the day you will be compiling and running all this as jar files using SBT. So runtime you may not be able to make any changes here. So if you feel that your queries are running slow, probably you can change these properties, recompile your code, and then run it again. That is one way you can do it. Okay. So there are two options, right? One is through shell. One is the this thing, what SBT. You can also use the Eclipse. You can use Eclipse with Scala support, right? Remember we were learning Scala, right? In the first day, same Eclipse there also you can run the code. No problem. If you just want to test it, you can do that also. You can open Eclipse, write the code, run it, and see the output. That's also possible. So it depends on the company, right? Some companies use IntelliJ. Some companies, they use something called IntelliJ, not Eclipse. Somebody use Eclipse. Up to them to decide. Let's start with Kafka. Now, like I discussed, today we are going to have a look at Kafka. We will see what is Kafka, what are some of its features. And then what we will do, we will also do a small hands-on part with Kafka and then move to Spark streaming, right? So even before discussing what is Kafka, its architecture and all, let's try to answer what is the need of Kafka, right? Why somebody should be interested in Kafka, okay? So these are the problems that are faced by today's world, right? So one of the areas where we need a lot of expertise and a lot of tools is something called real-time data analytics. So far, if you look at Spark, we were playing with RDDs, we were using Spark SQL, all of that, or even if you talk about MapReduce or Hive or Pig, or all those tools are used to analyze batch data. Like you will get some data, you will store it in some place, and then you will analyze it. But today in the industry, what is happening is that we are looking at something called real-time data. For example, look at sensor data, right? So let's say we have a requirement where we need to collect the data from sensors and analyze the data in real time and then make a decision. For example, look at something like a thermal power plant. So you're collecting the data from a thermal power plant where you're looking at the temperature or humidity or something like that, right? Now, if the values cross a threshold consecutively, then probably there is a problem with the plant and you may have to take a decision to shut down or take a measure, right? So these kind of scenarios requires the data to be efficiently collected in real time, right? And another example is your typical stock market data, right? So a lot of trading that happens today is through real-time analysis of stock data. For example, we have something called HFT, high frequency trading, wherein what happens is that there is a company called Two Towers or Twin Towers, right? So what they do is they will take the data in real time from the stock market, and then they will help you to invest in real time. So, I mean, my point is that there is a huge need of collecting the data in real time. And organizations can have multiple front-end servers, right? So one organization may have a web server, another app server, and too many other servers. So the problem is that we need a very efficient way to collect the data. So look at this architecture. So you are having a front-end server, then let's say there is a chat server, there is an application 1, application 2. So that is your front end. So behind the scenes, you may have a database server, you may have a security system to understand your data, real-time monitoring systems, data warehouses. All of this is in the back end. Now the question is, how do you communicate between them? So let's take a simple example. You have a chat server. What is a chat server doing? It is storing all the records of the chats, right? Now, probably the chat server need to communicate with the database server. End of the day, probably the data is being pushed to some sort of a, let's say, NoSQL database or something. And probably the security system also want the data from the chat server, because the security system is probably analyzing the chat logs and then making sure that there are no threats in the chat or something like that. One of the investment banks, and what the bank does, there is something called inside trading, right? What do you mean by inside trading? Like you can call and then trade, right? You can call the person and then you can talk to him, you can chat with him, and then you can trade him. So this bank was actually analyzing the chat logs to understand whether there was any threats or if the trade is not happening properly, etc. Right? If I'm placing my order through chat, right, then what is the guarantee, right? It will happen. So the bank had an application which will collect this chat messages, analyze it for any discrepancies. So first thing, the chat server is communicating with, let's say, the database server. It is also communicating with the security system. Let's say there is a real-time monitoring system which is analyzing the chat messages and displaying things like, how many agents are active, so on and so forth. So that system also needs your chat data and other services. So you see, the problem is that the problem is not analyzing the data. That is what you need to understand. The problem is not analyzing the data. The problem is collecting the data. That is where Kafka comes into picture. So Kafka, many people believe that Kafka is something which can analyze your data, and that is incorrect. Okay, the Kafka framework is designed to efficiently collect real-time data. All it does is collecting your data. Well, you can see that, so this is the same points that we were discussing. The data pipelines are getting complex, and if you are adding more systems, then it will become more complex. Managing the data pipeline is also a challenge. And how does Kafka actually solve this problem? This is how it solves the problem. So basically, when you talk about Kafka, in production terms, we always say there is something called a Kafka cluster, meaning typically we will be using more than one machine for Kafka. So you can have any number of machines depending on the amount of data that you want to manage. Kafka is nothing but a message queue. So if you guys have already worked on some sort of a message queue, then you can easily understand Kafka, right? The only difference is that your traditional message queues like RabbitMQ and all, they usually work on small amount of data also in the traditional world. Kafka is designed to work on fairly large amount of data, and Kafka can be easily incorporated with any big data tool or framework. So basically what happens in Kafka is that there are producers and consumers. That's what you see in the picture. Producers are the applications which are sending the data. So producers send the data to the Kafka cluster. Consumers subscribe and receive the data from the Kafka cluster. So it is a typical publish subscribe message queue. And we will look at the details of this. So Kafka is an open source distributed publish subscribe messaging system, right? Which manages and maintains the real-time stream of data from different applications, right? So Kafka can do multiple things. I mean, most of the times people are interested in real-time data. In the sense, I am sending something and you should receive it in real time, then Kafka is a good choice. But Kafka can also store your messages for a configurable period of time. I will talk about it. So this was originally created at LinkedIn. LinkedIn was the company who sort of like invented Kafka way back in 2011. Later, they open sourced it. Kafka is written in Scala and Java. Right. Now let's look at the solution provided by Kafka. So the basic idea is to decouple your data pipeline, right? So rather than everybody sending the data to everybody, you send to a common guy, and whoever wants the data, ask that common guy. It is as simple as that, right? So one way is that I can send the data to everybody one by one, right? When Kafka comes into the picture, the difference is that whoever want to send the data, they send to Kafka. And whoever want to receive the data, they talk to Kafka. So Kafka becomes your central message queue, right? So the communication is very simple and manageable, right? We can establish asynchronous communication and send messages with the help of Kafka. Now, so it is very similar to a message queue, right? Now, Kafka, ideally, the original Kafka project cannot transform your data. So there is no way that Kafka can actually modify your data or transform your data. Like if you want to transform your data, you need a processing engine. Somebody should process your message, right? So let's say I'm sending 1 million sensor data every minute. So every minute I am sending 1 million sensor data. I am a producer, right? Now Kafka will just store this for me, this 1 million. And if somebody comes to Kafka, it will give it to them and let them process. That is the idea. So Kafka is not going to interfere in your processing part. But very recently, Kafka has come up with something called Kafka Streams. It's a very new project. Kafka Streams aims to add the processing capability to Kafka. But that is not a part of our discussion. And also, it's a very new product. I don't think anybody has tried it so far. So there's a company called Confluent. Confluent is the company who's promoting Kafka. 2017 end or something, they came up with this idea of Kafka Streams. Right. So let's understand the components of Kafka. This will make it more understandable. Right. Now, the first thing that you need to understand is that there is something called a broker. Right. So brokers in production setup, brokers are nothing but servers in which Kafka stores the data, right? So I told you the producer will send the data and the consumer will get the data. But where will your messages be stored? That is managed by this process called a broker. So normally when you install Kafka, let's say you are having a 100 node Kafka cluster, each server or each node will become a broker. So they manage and mediate the conversation between two different systems, right? And messages are what you send, and Kafka doesn't really care what you are sending. From the point of view of Kafka, message is nothing but a byte array, and you can store in any format like string or JSON or Avro. Kafka doesn't really care, right? So if I'm a developer, I can write my own producer. There is a producer API. So let's say you have an application and the application want to send data to Kafka, right? So you can write your own producer. There is a producer class. You can instantiate it and you can start sending the data from your application. Now, in what format you are sending the data, that is up to you. Kafka doesn't care. For Kafka, it is just byte array, set of bytes that is coming in. You can decide the format. It can be string, JSON, or many formats actually, right? And there is also the concept of topic. So in Kafka, all messages are maintained in what we call topics, right? So topics are very important. For example, if 3 producers are sending the data, right, you should identify the data, right? You cannot store everything in one place. So imagine you have 3 producers who are sending 3 separate data. So what we do is that we will create 3 topics. Topics are like queues, So once you create a topic, a producer can send the data to topic and the consumer can read the data from the topic. So they are used to, how do I say, distinguish the messages. Otherwise, all the data that all the producers are sending will be messed up, right? We don't want that. So normally when we start working in a Kafka cluster, the first thing that we do is that we will create a topic. And then when you have a producer, the producer will send the data to that topic and consumer will receive the data from the topic. And what is a cluster? We know that. So you have more than one a set of servers is called a cluster. Producers are the processes that publish the data to one or more topics. Producers are basically the source of data stream in Kafka. So what is an example of a producer? Anything can be a producer. A sensor system can be a producer. Apache Flume can be a producer. Amazon Kinesis can be a producer. Your Java program can be a producer. Anything can be a producer. There is no strict definition as to whoever who want to send the data, who is a producer. And consumers are the guys who will read and process your data, or who will read a list from the topic, right? So we will be learning something called Spark streaming. So the idea behind learning Kafka is that the next topic that we have is called Spark streaming. So Spark streaming is a consumer for Kafka, meaning if you look at the whole architecture, let's say a sensor is sending 1 million sensor data points every minute. So what is happening? Every minute, the sensor is sending 1 million data points. So sensor is your producer, and the data will land in Kafka. Now what I will do, what is my requirement? Every minute, I want to analyze this and then understand whether there are any values which are more than the threshold. Probably it is temperature data. So I want to analyze data every 1 minute and see if there are any values more than 30 degree, 40 degree, something. So that is the analysis part. Who will do that? Spark streaming. So Spark streaming is the real-time analytics engine. I mean, it can do analysis, but Spark streaming should get the data, right? So from where it will get the data? From Kafka. One of the sources is Kafka, right? So we will learn more about Spark streaming, and that At that time, I will talk more about it. So we have producers and consumers. Now, there is also the concept of partitions. Every broker holds few partitions, and each partition can be either a leader or a replica for a topic. All writes and reads to a topic go via leader, and leader is responsible for updating replica with new data. I will talk about partitions from the diagram, then only you will understand. Is topic different for different producers? Can be different, can be same. That's up to the producer to decide. Like if you have 3 producers, they can send the data to the same topic if they want, but ideally it is separate depending on the data, right? Yeah, Twitter can also be a producer for data. Can multiple sources be connected to a single producer, or it is one producer per source? Well, source and producer, well, I will not really call them like that. See, from the point of view of Kafka, there is only producer, right? There is only something called producer. There is nothing called source. Source is for us to understand, right? For example, let's say you are collecting the data from Twitter. Let's say you are collecting the data from Twitter, right? Now, the question is that how do I get the data from Twitter to Kafka, right? So there are multiple ways to get the data. We typically use a tool called Apache Flume. There is a tool called Apache Flume. What Flume can do, Flume, if you configure Flume, it can connect with the Twitter API and get the data and then send it to Kafka. So Flume is not going to hold your data. So in that example, Flume is your producer. Even though the data is coming from Twitter, we don't have a direct way to pull the data. So what we do is that we use a data collection tool called Flume. Flume will connect with Twitter and get the data for you. So Flume becomes our producer. So it depends on case to case. We will discuss it. So this is how the architecture looks like if you look at more deeper, right? So you have multiple producers and multiple consumers, and then there is a Kafka cluster. Now, what you need to understand is that, you know, there is only one topic, right? There is something called topic 1. Topic 1 is divided into 3 partitions. So normally when you create a topic, it is a good idea that you divide it into multiple partitions. Why? This is for scalability. So if I divide a topic to multiple partitions, each partitions will be on one broker and I can scale. For example, if you're getting huge amount of data, right? So when you say real-time data, the size of data can be really high, really big, right? So storing all the data on one broker may not be feasible. So if you say I want 3 partitions on my topic, typically what Kafka will do, it will divide your topic into 3 partitions and assign each partition to a broker. You see here, partition 0 is on broker 1, partition 1 is on broker 2, partition 2 is on broker 3. So actually, it's written broker 1, 1, 1. It's actually 1, 2, 3. There are 3 brokers actually. So each partition will go to one of the broker. And that is for scalability. And you can decide how many partitions you want. If you do not want a lot of partitions, you can reduce them as well. And in this example, you can also see that even though you are having, let's say, 2 producers, they are sending the data to the same topic. We have only one topic. That's called topic 1, right? And when the producer is sending the data, look at the arrow. It will send it equally to all 3 partitions. Look at the arrow from the producer, right? So that each machine will get filled in the same fashion. So there is a round robin algorithm by default in the producer API. What it does is that if it is sending the data, one record will go to topic 0, one record will go to partition 0, next to partition 1, next to partition 2, etc. Now, Zookeeper stores information about cluster status and consumer offsets. So there is a project called Zookeeper, right? Now, Zookeeper is used for multiple cases in this example. It stores information about cluster status and consumer offsets. So what are we talking about? Now, if you look at an inside view of the architecture, so let's say there is a producer A which is sending some data, right? That may send to partition 1, partition 2. Then there is a producer B, which you can configure a producer to send only to partition also. So in this example, you see producer B sending the data only to partition 3. That is also possible. I can configure the producer to send the data only to one partition. So producers send records to topics. Producers select the partition to send the message per topic. Producers can implement priority system, which is based on sending record to certain partition depending on the priority of the record. Producers send records to a partition based on the record's key. Producers don't wait for acknowledgement from the broker and send message as fast as the broker can handle. Now, there are multiple techniques that we use when you're having multiple partitions. One technique is called round robin, where what I do is that, let's say I am a producer, there is a topic, there are 3 partitions. I keep on sending to one by one. Partition 1, 2, 3, 1, 2, 3, I keep on sending it round robin. I can also configure a priority. So in the producer API, so basically all these messages are sent as key value pair. So there is a key and the value is the actual message you are sending. So I can configure sort of like a priority for a key. I can say that, you know, every key having this priority should go to partition 1 and this should go to partition 2. That is what you see in the picture. Producer B is always sending to partition 3. Why? Because it is configured in that fashion, right? So you can do that depending on your use case. A cluster typically consists of multiple brokers to maintain the load balance. A broker, on receiving message from the producer, assign offset to them and commit the message to storage on disk. Yeah, so this is very important. So once the data lands on the broker, every message or every record that you send will get something called an offset number, which is very important, right? And it gets stored on the hard disk. It serves consumers by responding to fetch request. So the consumer will connect and say that, hey, give me the data. One broker instance can handle thousands of reads, writes per second and terabyte of messages, right? Backup of topic partitions are present in multiple brokers. So you can also have replication. I will talk about it. There is the concept of replication in Kafka. If a broker goes down, one of the brokers containing the backup partition or replica will be elected as the leader. So messages are categorized into topics. Topics then further divided into partition. And when you write messages to Kafka, it's basically an append-only technique. So there is no modification. So when you want to read, you can either say, I want to read from beginning to end, or I can skip and start from a particular offset value, right? So the important point here is this offset ID, right? For example, let's say I am a consumer and I am reading the data, okay? So imagine I am a consumer, I am reading the data. So today I connected to the Kafka cluster. I probably read 100 messages and then I disconnected. So tomorrow when I come back, already 100 messages are read by me. I should get the message starting from 101. How do I do this? That is where this offset ID comes into picture. So each message has an offset ID. So if I'm reading 100 messages, my offset will be 100. And being a consumer, I should store this offset somewhere. So typically we use Zookeeper to store this. So what I will do is that I will store my metadata. For example, I will store saying that, say I have read 100 messages in Zookeeper. So tomorrow when I come back, I will check with Zookeeper, and Zookeeper will tell me that, okay, you have read 100 messages yesterday. Now you can start with 101. And I will connect with Kafka and say that, give me the data from this topic starting from 101, and then I can read actually. Okay, so that is how it is working. And this is the offset. See, so you have a topic. The topic is divided into 4 partitions. Data in each partition has an offset. 0, 1, 2, 3, 4. Can you see? That's the offset. Right. Now, when I want to read the data, I should tell Kafka from which topic I want to read the data, which partition I want to read the data, what offset I want to start with. Partition 1, offset 4. That is how I read. Right. So that is the metadata in Kafka actually. How do the producer know how the broker capacity to handle messages? Okay, producer doesn't really know the capacity at all. So that is the good part. So if you have a producer, the producer doesn't really have any clue about the Kafka cluster, right? It just keeps on sending the data. So in fact, the difficult part in Kafka is administration. In the sense, you should not run out of resources, right? So if the amount of data that is coming is really high, the Kafka cluster should be able to hold it. Now, talking about that, any data that you send to Kafka, it will retain for 1 week, 7 days. After 7 days, it will delete it. Default settings. Now, in the production clusters, it will be different. For example, imagine every day you are getting around 100 terabyte of data in Kafka every day. And let's say your cluster can hold a maximum of 500 terabyte. Every day, you get 100 terabyte. Your Kafka cluster capacity is 500 terabyte. So probably I will configure my retention period like 3 days. So after 3 days, I will have 300 terabyte of data in my cluster. Automatically, the first day's data will be deleted. So do not assume Kafka can store forever. No, it's a message queue. Get the data, read the data, delete the data. I mean, it will not delete if somebody is reading. It will delete based on the retention period. You can configure that actually. Zookeeper takes care of all coordination. Yes, right? So the messages are all in sequence. Sequence in the sense that depends on the producer. If the producer is sending the data in sequence, you will get the data in sequence. First in, first out. Like if the producer is sending from 1 to 100, you can start with 1, read all the way to 100, right? That is fine. I will show you. So the data can be anywhere. The data can be on any broker. So I got your question. Now the question is that how do you know where is the data, which partition, how do you read it, right? I will explain that. So one common concern is that how do you get the data? I am a producer, right? I can send to, let's say, the 100th machine. How the consumer will know that the data is there, right? I will answer that. Look at this picture. Probably this will clarify some more concepts in Kafka. Let's say we have a topic that is divided into 4 partitions. So topic is divided into 4 partitions, 0, 1, 2, 3. Now concentrate only on partition 1. Partition 1 is stored in broker 1, broker 3, broker 5. Why? You can have replication. So if you keep the replication as 3, what will happen? Each partition will be replicated 3 times to 3 machines, very much like Hadoop. So what happens in Hadoop? Your data is divided into blocks and replicated. Here it is divided into partitions and replicated. Same concept, right? But the point is, look at the last machine, broker 5. For each partition, Kafka will elect one broker as the leader, which means this guy is the leader. One machine will become leader for partition. So for partition 1, broker 5 is the leader. That means all the reads and writes will be handled by this guy. The other 2 are just like replicas, you cannot write and read to them. They will become active only if the primary copy fails. So replication works slightly different in Kafka because you can have 3 copies. That is fine. Even in Hadoop, you can have 3 copies. But the advantage of Hadoop, Hadoop is totally different. But I'm saying in Hadoop, what happens, if I have 3 copies, I can read from all 3 replica if I want. But in Kafka, if you have 3 replica, you can always read from only one. The 2 are just like dead. You cannot even touch it, right? So only when the primary copy fails, the next guy will be available. So that is like a hard replication, cold replication we call it, because it is not useful for reading or writing. So the leader is the broker which is holding the primary copy of your replica, right? Others are all kind of like, cold replicas, which means you cannot read or write to them. The consumer can subscribe to one or more topics and read messages in the order they were produced. The consumer keeps track of messages it has already consumed by keeping the track of the offset messages. Remember, so it is the responsibility of the consumer to remember till what point it has read. Consumer works as part of consumer group, which is one or more consumer. So typically we create something called a consumer group. That's like more than one consumers in a group. So this is how a consumer group will read from a topic. So let's say you have 3 consumers and you want to read from this topic. So the topic actually has 4 partitions, right? Consumer 0 is reading from partition 0. Consumer 1 is reading from partition 1 and 2. Consumer 2 is reading from partition 3. Right. So in this example, each consumer is reading from, let's say, one partition, and they are processing the data that is arriving in that partition. Right. So another example, so if I'm talking about my sensor example, right? So I'm talking about aggregation. For example, I want to collect all the data that was in 1 minute and process. I want to know whether the last 1 minute sensor data had any high temperature. Then I should process all 4 partitions by one consumer. That is not happening here, right? Here it is sort of like load balancing. One consumer is reading partition 0, another is reading partition 1 and 2, another is reading partition 3. That is also possible, right? So each consumer is storing the offset that it is reading. Consumer 0 has read only till 6. Consumer 1 has read till 5 and 7. Consumer 2 has read till 10. So this is how it is.
Now for this, I will buy server which is 6.3, CentOS 6.3 in West Coast. I wanted something that has decent RAM, so I'll go for 4 gigs of RAM. I think that's fair. Going for 8 would be too high, so I think 4 would be what I'm looking at. I'll go with the default security group, and this is my key value pair which is named Ravi, and I say bank. So my first machine is started. So while I do this, while this machine gets started, let me buy another machine. I need 3 machines, right? So I say, by the way, guys, I would request everyone to please open the PDF, and I'm doing exercise number 7. All right. So Oregon. Then I say I want a medium machine. Value pair, and I say bank. Machine number 2 is firing up, and I'll go buy third machine again. CentOS. Say this Oregon. All good, and I say all the 3 machines are successfully purchased. When I refresh, you will see a couple of them started, one of them starting. So one of them has started. I'll rename that as Mr. Name Node. All good. We'll soon have our other machine also getting started. Here you go. That's machine number 2. I call this as data node 1. Cool. Then I soon have third machines that will be starting. And that is my data node 3. Data node 2. Sorry. So these are 3 machines, all purchased, all done. We are good. Now, one quick question. So now you are running your computers, all good, all great. Now it's time for us to connect. Now I want to connect to my name node. So I say, Mr. Name node, I want to connect to you. So I say connect. What I do is I directly take the command which will be connecting to my machine, and I'll say copy, open it in terminal, and say connect. So you see, I'm logged in my first Amazon machine. All great. So I'm already logged in as root in this machine. All good. I want to connect to my second machine. Connect. I say, please help me connecting to my second machine. So I say open a new shell window. And I say, please help me connect. Say yes. So I am in my second machine. Now let's go and connect to my third machine. I say connect, get the command here. I say all right. Awesome. So I'm connected to my name node, data node 1 and data node 2. Now what you see is, well, this is my name node, this is my data node 2, and just lost sight of my data node 1, that is now I have 3 machines, and this is my name node. Last question. Yes, Amrish, everything is uploaded. Everything is uploaded, Amrish. So do you guys see one problem here, that I'll have to remember IP addresses of all the machines, which is not a good idea. Not at all a good idea. So let's change them to more meaningful names. So what I do is I say, this is my IP address. I say vi etc sysconfig network, and I say I want my host name to be name node. So I say my host name is name node. All good. Then I say vi etc host, and I say whenever somebody talks to you about IP address this, please translate it to name node. Similar here. So my name node is done. Then I have to look for what is data node 1 and what is data node 2. This is my data node 1. So my data node is my name node. So 10 dot. So this is my data node 1. So what I do is I say vi etc sysconfig network. I say this is my data node 1. And say I have config take this and I say vi etc host. Mhm. What I do is I say data node 1. This should have been data node 1, right? All good. Now we go to machine number. So this is my data node 2. So I say vi etc sysconfig network. And I say I want my machine to be named as data node 2. All good. So I'm done with my data node 1 and I'm done with my data node 2. I need to take the IF config for this machine, take this up, copy vi etc paste, and I say data node 2. Now let's see the magic. I have basically changed host names of all three. All I will do is I'll reboot all of them now. I'll restart all of them so that after this there are no confusions whatsoever. So I have shut down all of them and restarted all of them. Yes, it is possible, Arjun. You can very well. There is a browser client also. Instead of using putty, you can use a browser client. Amazon has that. All right. So all three machines have started. Now you see something interesting here. Okay. Let's go one by one. This is my first machine. I just say connect me to this. What do you see here? You see name node. I do the same thing here. And this guy tells you welcome to data node 1. I do same thing here. And this guy tells you welcome to data node number 2. So we all are done with the pain of basically remembering IP addresses now. All good? So now this is Mr. Name Node, Mr. Data Node 1. We don't have to again remember their IPs or something. And this is Mr. Data Node number 2. Now I'll wait for a minute and request everyone to confirm. Now let me tell you the steps. What we will do is session notes. First, we have purchased blank machines with absolutely nothing on them. So here are the steps. Install Java, install Hadoop and run exercise number 7. So is this clear, guys? See, we bought machines which are absolutely blank, absolutely nothing on them. All right. And what we are doing right now is so my step 1 is install Java on the virtual machines. These are blank machines with only operating system on them. And this recording will also serve you ahead in basically at your workplace, because you will know what to do exactly from ground zero. Just okay. So these are blank machines, and you will be seeing we'll first install Java. Then we will install Hadoop. And then we will install we will set up multi-node cluster. These are simple 3 steps. So let's get started. So my step 1 is install Java, where my first command is yum install wget. Yum install wget would basically, it's a utility that will let me download stuff from internet on my Linux box through command line. So it is yum install wget. So I'm doing nothing, just installing a package on Linux box, nothing else, no rocket science. So wget is installed. Now I'm downloading Java. So I'm doing nothing, just downloading Java from the internet, nothing else, just downloading Java from the internet. Java is getting downloaded from the internet, nothing else. Now when you install Java, there are certain files that are of not useful to us, and they are not present, so Java may complain, but that's okay. You have to ignore those warnings and go on with the installation. You say I am again doing nothing, just installing Java, nothing else. So now Mr. Java is installed. This is done right now, and I am pasting the commands for you guys. All right. So my step number 1. So my step number 1, downloading and installing Java is 100% done. Step number 1 is done. Let's talk about step 2. We'll just set up the download for Hadoop. So we are setting up a Cloudera repository. So we are right now installing a Cloudera repository. Okay, and we will install Hadoop right now in a minute. You will see that. Now comes the most important step. We have just set up Cloudera repository. Now we will install Hadoop. So we've just run a command and everything is happening automatically. So just run the command and you'll be done. So Hadoop is getting installed, looks like some Matrix movie, all those things are going up and down, up and down, up and down. You are installing it on 3 machines together. So this is on Amazon US server, that's why it's still taking less time. If you do this typically in India, it may take 2 hours. That is why if you see the virtual machine has already Hadoop installed for you guys. So Hadoop is 100% installed. All right. Now there are two most important questions. Correct. So very simple. Type Java on command prompt and you will come to know whether Java is installed or not. So this says Java is installed. If not, it would have said command not found. Correct. So that means Java is there. That's why you see this. Okay. So hope this is clear that how do you verify if Java is installed? This is how you just go about, man, why is it this opening every now and then? And here also it's the same. All good. Now let's move to the next question. Yes, there are other ways. Just say Java version. Sorry. So this tells you what Java version is installed. All right. So this answers your question of how do you verify if Java is set up. Now let's talk about the next question. No, you don't need to. Once you install, it's already set up for you. All right. So that is how you verify if Java is installed. Now, next very important question is, what exactly is Cloudera repository? Let me give you a small introduction to that, of a minute introduction to that. Okay, not required here. Let's put it simply. In Windows, agree? All right. Now, in Unix or Linux world, you mostly So in a nutshell, it is nothing more than a directory or a repository service where, or an address service where, oh, sure. I'll explain this. Yeah. In Windows world, you download something that is exe or MSI and double click uh, and everything gets installed. In Linux world, you mostly install stuff from command line. Now I'm not getting into details of it as to how exactly it works, but it's this. When you order the operating system that, hey, I want to install this particular software, the operating system goes to list of repositories and checks if this software is available with them. The repository basically just has the URL or address of where this installer can be found on the internet. And what really happens is when you say yum install Hadoop, it would go to the repository and say, do you know somebody called Hadoop? And typically you will not find an answer. They will say, we don't know who's Hadoop. But then if you set up Cloudera repository, Cloudera will know where is Hadoop. So then your operating system finds that and it basically downloads and installs that for you. So it's more like a reference structure where from your command line, the control goes to the repository locations and repositories will tell you whether they have this software or not. All right. So, yippee, step 2 is done. Now, is everything clear and is it making sense? Just to, if you want to verify if Hadoop is installed properly or not, all you need to do is say rpmql Hadoop 0.20 conf sudo. This tells you that yes, Hadoop is installed and this is the configuration of Hadoop. Now, this is already there in exercise number 2, step number 2. And it's clearly written that this is how you verify if Hadoop is installed or not. So that's kind of already there, yeah. So guys, this is an important logical step. And now we go to step 3, setting up multi-node cluster. Please have your PDFs open and be on exercise 7. All right. Now it's time for us to get started with the setup part. So Hadoop is installed and we are all set. Can you please open PDF and please go to exercise number 7? And I'm talking about step 2. So we've just installed Hadoop. We need not stop services because we haven't started any. Please go to step number 2 and I want to explain a few things. All right. I guess everybody is on step 2. Now I have one question. So let's understand what is alternatives. So guys, if you really go deep, what you see is every software has two things. You'll have many things, but there is the code, and the code basically runs on or points to certain configuration. So now, do we all agree that typically every software has some code and it points to certain configuration? Agree? All right. Now, this I would say is your software that has code and certainly follows certain configuration. Now, Mr. Alternatives framework lets you have multiple configurations and lets you point to any of them at a given point of time. Straight, nothing else. Mr. Alternatives framework is basically, it lets you have multiple configurations and lets you basically point to any one of them. What I mean to say is, you can very well have configuration number 1 and you can very well have configuration number 2. Okay, configuration, my configuration, now point to this, I can do that, I can point to this, I can do that, I can again point to this, I can do that. If my mind changes, I point to this and I just play. And this is possible through alternatives framework. Now let me show this to you and you tell me what do you make out of this. Okay, look at this carefully and tell me what is that you're understanding out of it. Tell me, what do you make out of this? This tells you that Hadoop has two configurations on this machine. It has 2 configurations on this machine. As of this very moment, conf.sudo.mr1 is the one which has higher priority, and as of this very moment, Hadoop is pointing to etc Hadoop conf.sudo.mr1. If there are two configurations, one is empty, other is the other one, because it has highest priority right now, Hadoop is pointing to. So current best version for Hadoop configuration is etc Hadoop conf sudo mr1. Does it make sense? Let's understand the concept. Everything else is just running a Linux command. It is matter of just, it's a cakewalk once you understand the concept. So just focus on the concept. Concept is this: one software can run on multiple configurations, and with alternatives framework facility, you can have them and you can point to any configuration. And the priority is based on your wish. What you decide is the priority. Now you will see that in 1 minute. Okay? You will see that in a minute. So you see, what I do now is, using an empty template of configurations, I am creating a new configuration. So what I say is, let's say sudo cp-r etc Hadoop conf.empty. Conf.empty is just a template, nothing else. Copy that to etc Hadoop conf, let's say conf.distributed. So I'm creating a new configuration called conf.distributed. As of this very moment, conf.distributed is empty. It is empty because I'm just copying a template. That's it, nothing else. It's conf.distributed. Now just focus on what I'm doing and you'll realize the whole thing. Now tell me, what do you see? Now, does it make sense? All I have done is I have created a new configuration which is as of this very moment empty. That's okay. And I have set a priority which is 99. And because I have the highest priority, my configuration is what Hadoop will run with. Is that clear? Awesome. Now let's do that on all three, because we want our configuration to be a distributed configuration as highest priority. What we do is we say then just to verify if all has gone well, what you see is you see that our configuration gets the biggest priority. So now we are done. Now our Hadoop is pointing to the configuration of our choice, but our configuration of our choice is empty. So we will now fill the configuration. But before that, the most important point is, you know what? It's a cluster. Cluster means the machines should be able to talk to each other and they should know each other. But do they know each other? Let's see. If I say ping data node 1, this guy says I don't even know data node 1. Yeah, we are in same Amazon network. We may know each other by IP, but we don't know each other by name. That's a problem. So let's first make sure that everybody knows each other by name. So I want to stop here and say as of this moment, our Hadoop is pointing to config of our choice. Okay, yeah, so far config of our choice is empty. Got it? All good? Exactly. So now after our config is correct, let's now make sure that the machines know each other by name. So simply putting it, what we'll do is I'll take ifconfig, which is this. I go and say vi etc host, and I'll say whenever I talk about data node 1, please translate it to this IP. Okay, and whenever I talk to you about data node 2, please translate to this IP. So now everybody knows everyone else. Now that they know each other, but we have to first also see, are they able to ping each other? So I say ping one. Now it is able to translate who it is, but it is still not able to ping it. Correct? It is able to translate. Now it knows that whenever data node 1 is there, I am talking about this IP. Okay, but it's not still not able to talk to it. So let's make sure that they talk each other on ping basically. So let's first copy these three values across the network so that so I go say vt vi etc host, okay. So that brings us to now they are still not pinging each other because the firewall doesn't allow them. So let's make sure that the firewall allows them. So if you see, let's see what security group they fall into. So when you see all three machines, they follow the default, which is 2012-79. So this is my security group. So I'll show you the security group. So all of them, they belong to this firewall rules. What I say is, please allow all ICMP. All ICMP ping works on ICMP protocol. I'm just adding a firewall rule and it has nothing to do with Hadoop whatsoever. Okay. All I'm saying is all ICMP communication should be enabled. This is a networking thing. Now I say, can you ping data node 1? It says surely I can ping it because ICMP is on now. Then I ask it, can you ping data node 2? Says fantastic, I'll do it. Does it? Say ping name node. Can you do that? Or name node, my spelling is wrong. It says 100%. I can talk to name node. I ask him, can you talk to name node? It says sure, I can. All right. So now, as of this moment, everyone knows each other by name. All right. can you look at the PDF, and I'm just following the PDF, you would see that our step 5 is now 100% done. So now if you see, everything is documented and we are done till exercise 7. Step number 5 is 100% done. Now exercise 7 step 5 is 100% done. Okay, now my machines are talking. My cluster or my whole cluster is now pointing to the right configurations. So far my configurations is empty, but okay, we all agree that my configurations are empty. We haven't done anything to the configuration. Agree? Our configurations are empty. Is everybody in sync with me? We've just taken a template of an empty configuration. I haven't done anything in the configuration whatsoever. All right. Now it's time to change the configurations. Okay. So if you see, I will explain you all the configurations. Don't worry about it. If you see, Hadoop typically has all its configs in XML and they are placed in etc Hadoop conf. Okay. So now let's modify those configs and let's so if you see, Hadoop has three most important configuration: HDFS, core site, and third one is MapReduce, which we'll create right now. Okay. Once we have all these configurations ready, we can certainly go ahead and set up the cluster. As of this very moment, my cluster is pointing to conf.distributed, but that is empty. So now I will fill those configurations. Once I fill those configurations, we'll go ahead with the next setup. Now we can type all the configurations one by one, but for now I have them in XML and I will directly copy them. Okay. And then I will explain you each and every configuration. So I say vi core site.xml. Right now this is empty. I say so in this particular configuration, all I am saying is the name of the configuration is fs default name. All I am trying to convey in this configuration is the name node of this cluster. The master of this cluster is a computer called name node and it works on port 8020. I'll do exactly the same thing here. I want to tell it that your manager is name node. All I'm saying is your name node or your manager is name node, which is this machine. And that is how it points to the master. cd etc hadoop conf vi core site.xml. So far what we've done is I have told all, so master needs to have its setting, but I have told both the guys, both the slaves, that he is the boss, he is the manager, nothing else. All right, now the next setting is vi hdfs site.xml. So first we'll do it on just remove the existing setting. What I'll do is I'll say hdfs site.xml. Okay, I'm sure everybody would need this XML files. Please don't worry, I'll pass them today with the session notes. Okay, so you'll have them, please don't worry about it. They are all yours. So if you see, there are three properties that I'm setting. See, if you see, HDFS is operating on top of your Linux file system. Okay, HDFS is operating on top of your Linux file system. So what's happening is I am telling that the name node will store its data, the metadata. When it writes to disk, it will store it in a folder called home disk1 dfs.nn and home disk1 dfs.nn. In real world, there will be two different volumes of the hard disk, or maybe two hard disks itself. Then I say the data node will write its data blocks in home disk1 dfs data node, home disk2 dfs data node. And the third thing I say is I want to access name node from port number 50070. These three are the configurations that I'm putting in the. Then I say go ahead, do the same thing here. All good. Okay, now the last file that I need to take care is MapReduce. These are the three most important files. The parameters of HDFS site. All right, so the first parameter is DFS name dir. That means where exactly will my name node write its data on the hard disk. Okay, see, name node writes all its metadata in RAM, and after that it flushes it. Now it flushes it to the disk. So where exactly will it write? That's point number one. Okay, then point number two is where will data node store the blocks on the disk. See, data node HDFS operates on top of Linux box. That means it will store something on the Linux drive only. Which folder will we allocate to data node? Home disk1 dfs.dn, home disk2 dfs.dn. And what is the web URL to access name node? This is my name node. And why am I having the data directory here? And this is my data node. Why am I having the name directory here? Because I'm not going to run name node here. The point is this: when you're talking about Hadoop, you're actually talking about a 50 node machine. And when you're talking about 50 node machine, you would not want to have different kind of setups on every machine. So just to maintain that standard, you put all the configurations everywhere and then choose which daemon or which Java processes will you start. So yes, on the name node, data directory setting is not required. On the data node name node directory setting is not required, but it is done from the standards perspective, just that it becomes easy for the administrator. Just a minute. All right. These disk1, disk2 that you see, these directories are going to be created by me after the configurations are done. I'll be creating them in the next step. Okay. So now HDFS site is done. HDFS site is done. And now we will talk about, we will do the MapRed site, basically the MapReduce configurations. Let's do that. MapRed, text edit. I say, let me do MapRed. What I do is I say vi MapRed site dot xml, and I just, okay, I'll have to paste the whole file because we are creating this as new one. Oops, did I close that? My bad. Desktop, XML files, XML files. I'll just copy the whole thing. And then what I say is I say paste this. I'll explain you the MapRed configs, no worries. All good. Now let's understand what is in. All right. Now the next important part is what exactly is in MapRed directories, MapRed site. If you see MapRed site, the first thing I say is who is the job tracker. The job tracker is running on the machine that is called name node, and it is running on port 8021. Second, where will MapReduce write its intermediate data? It will write it in home, disk1, MapRed, local. Third, what is the root directory for mapper? Basically, when you run a program, you are running it as, let's say, user training. So what is your current directory? It is /user username. So that is what you are doing for what you call MapReduce. Now, once these three configurations are ready, in this configurations, we have committed that we will create some directories. Now it's time for us to do that. See, these are local directories. See, MapReduce will store its data somewhere, right? While it is processing, that is the local directory. Staging root directory is when you run a particular job, where exactly do you want that intermediate data to store in staging? It will be in /user directory inside the staging directory. So these are MapReduce specific directories. One, where it will store the intermediate data. Second, it will store some information about the job. First location is certainly not HDFS, that is the local directory, but second one is HDFS. So if you look at it, so the second directory /user is the local directory, no, HDFS directory. The first one is local directory and second is HDFS directory. All right. Now it's time for us to create the directories that we had committed. All right, before I go ahead, can I explain you the use of staging conf directory? See, when a MapReduce job runs, okay, it has certain intermediate processing data, okay, and it's few locations where it writes some intermediate data while processing. It writes it in var lib hdfs cache MapRed staging directory, and
you want to have a history of what all jobs have run. All that is stored by username inside the HDFS directory. So what you're saying is, I want to write that particular data in staging's user directory. So basically all your job history is stored in that particular thing along with some intermediate processing basically. So tell me one thing. Now we've committed to certain directories, let's create them. So what we say is, we say sudo mkdir p disk1 dfs disk2 nn. Disk1 data node, disk1 mapred local. All right, the directories are created. Let's create them on both the other machines also. Same thing here. So directories are getting created. All right, now the directories are created and these directories are for HDFS to store its own data. Okay, that's why we need to give permissions to HDFS and MapReduce on these directories. Okay, so our goal is to now give permissions to these guys. What we do is we say sudo chown -r HDFS Hadoop home disk1 then I say for MapRed directories the owner should be MapRed. All done. Ownerships are now given to everyone. This all I'm doing is just creating those directories which are required and giving the permission, nothing else. No rocket science here. All right, same thing. Okay, I've done a mistake here. It should be MapRed local. Thank God. Else we would have got a permission issue. Okay. And here the same thing. So all the committed directories are created. let's pause here for a minute and let's see all the questions that have come. So the question is, what is mkdir-p? When you say -p, that means if the parent directory is not existing, please create that also. That's it. What does HDFS Hadoop means? So I guess we've discussed, okay, I'm not sure, okay. So when you install Hadoop, it creates two users, HDFS and MapReduce, and it creates one group called Hadoop. So in this command, what I'm trying to say is, please give ownership of this folder to a user called HDFS who belongs to a group called Hadoop. All right. So now all the directories that we committed are created right now. Now all the required directories and stuff is there. All we need to do now is start necessary processes. See the cluster. All right, guys. So we've created everything. Now we will just start name node on the name node machine, data node on the data node machine, and we will see everything working together. So now we've basically created all the directories that we had committed to. Now it's time to set up the cluster. What you do is just a minute, I'm opening the PDF. Now we are setting up the cluster and we will format the name node. So what I do is I say sudo new HDFS Hadoop name node format. So the name node is formatted now. All done. On the name node, I will start name node and secondary name node. That is etc initd Hadoop HDFS name node start. Yes, we will format name node only on the name node because only that there is only one master, right? So we'll format the master. Okay, I'll tell you what exactly heap size is. See, this heap size command is for our what you call classroom setup, where we do a multi-node setup on virtual machines where RAM is very less. Okay, so I'm not doing it here because I have full RAM. I don't have to worry about setting the heap size less than, let's say, 200 or something. We will do RAID, and we are actually doing RAID here, that we are writing name node data to 2 disks, correct? Now in real world you'll write it to 2 volumes. To simulate that, I'm writing to 2 different folders. That's it. So I'm already backing it up. Now our name node and secondary name node is up and running. Let's verify that. So we have this Java process status tool that tells us that name node is up and running and secondary node is up and running. We are all good. But we haven't verified if data node is able to talk to name node on port 8020. Right? We have to open the ports. We haven't opened the ports so far. Say yum install. Let's do a telnet and see. So now let's see if we are able to telnet to the name node. That is important. So I say telnet name node 22. 22 will work. That means port 22 is open. Now let's see if I am able to do that for port 8020, because that is my. So you see port 8020 is not open. That's a problem. Now if port 8020 is not open, you will have to talk to your network guy and open it. So what we'll do is we'll simply go ahead and say for now let's be liberal and say okay, open all the TCP. All right. So let's say you do all right. So yeah, it's already existing. So all TCP is open. But having said that, you will still not be able to do it because the reason is this. If you look at ps-ef grep 8020, what you see is that this particular thing has opened on this particular port. Along with that, it should have ideally been 0000. Now just a workaround. Now this machine is not able to reach. Okay, what we will do is for right now we will just disable the firewall. Okay, again this is a networking concept. We will just disable the firewall on Linux boxes so that they are able to talk to each other. In real world, your network guy will take care of the firewall. I am just disabling it for now. So I say service IP tables save stop. Chk config IP tables off. I am just disabling the firewall, but it's not a good idea in real world. Real world, you'll have to find a way to do it. Basically, not find a way to do it. It's straightforward. Your administrator on the network side will open the ports. It's no rocket science. All done. Now let's see if I'm able to do a telnet. Still not able to do it. Oops. Now it's tricky. I have turned off the firewall also. tables off, service IP table stop, save. This is strange because it works wonders. One minute. This is crazy. Works. This is amazingly crazy when everything is shut down on the firewall. Now, does everyone belong to 2012 group? Let me just check. What is that I'm missing? It's 2012. Yeah, they all belong to the very same security group. This one. No, I just don't recall. What else could be it? Okay, this works. Data node 2 works. Wow. Isn't that strange? Okay, even this works. I guess I was doing something wrong. Or maybe I just shut it down before. So anyways, so this works. 80/20 and this works. All right. So we have everybody pointing to the, and again this is a networking concept, so just relax out. It will be done on the firewall level on in your what you call company. Now my name node and secondary name node is up. Now I will bring up the data node. So what I do is, I start the data node. Just a minute, it's so I say etc initd Hadoop HDFS data node start. I say etc initd Hadoop DFS data node start. So what I do is I run the same command. So now data node is started and let's see where it points to. We'll see that. So I say so you see data node is started. You say data node is started. And here also you see data node has started. All right. All right, just a minute. Data node is started. Now, if you see on my master node, my name node and secondary name node is up. On my slave node, my data node is up. Are you clear with this fact? Great. Now let's see how HDFS would respond. Say Hadoop FS. I'll create a directory sudo u HDFS Hadoop FS mkdir. So I've created a directory called temp, and I will do chmod 1777. So I have run two commands on HDFS. Now let me show it from the cluster. I say Hadoop FS ls, show me the contents of root, show me the contents of the HDFS. Do you see this created? It was created from some other client, but now it's returned to the common HDFS, basically the distributed file system. That's why you're able to see it from everywhere. Hadoop FS ls root. Our multi-node cluster is running now. Our multi-node. Okay. Now let me create a file here. I say Hadoop FS mkdir user root sudo -u HDFS. Now I give ownership of root to myself. Now I put 3 files there. I'm putting 3 files from HDFS. I'm putting just 3 XMLs or 4 XMLs. Let me create another folder called input so that we alright. So what you see is created an input directory. Now I say Hadoop FS put 3 or 4 XML files, which I say so I am dumping 4 files from Linux file system to Hadoop file system. What you see here is do you guys see the files? FS ls input. It's a distributed file system and everybody can see that. Hadoop FS is a prefix to every command that you're running on Hadoop file system. You are creating a directory on a distributed file system. That means everybody can see everything. Okay, it's a distributed file system. Let me just show it to you. Hadoop FS mkdir test directory from data node. Hadoop FS LS. Do you see that? It's a distributed file system. So now you can safely say your HDFS or your multi-node setup is 100% ready and raring to go. Now let's get to the MapReduce part. Now in a multi-node cluster, we've already created temp, we've created our root directory, we've created input directory also. Now it's time for us to create a MapReduce directory, that's a system directory for us to run our program. What we do is we say Hadoop FS sudo HDFS Hadoop FS mkdir MapRed system. We give the ownership of that directory to MapRed user. So we say ch own MapRed Hadoop. So MapRed owns this particular directory. All right, all done. Now it's time for us to run a MapReduce program. So now we are all set to run our program. Let's do it. Say Hadoop jar user lib Hadoop Hadoop examples input grep input output. Wait, we've not started job tracker and task tracker. We've not started job tracker and task tracker. Let's start. etc NID Hadoop start. So I've started job tracker on the master. So what you see is name node, secondary name node, job tracker on the master. Here we will start the task tracker. All right. If I do a JPS, what you see is data node and task tracker is up here. If I do a JPS here, I see data node and task tracker is up here. Now our MapReduce is also started. Now it's time to really do the, what we say is we say Hadoop jar user lib Hadoop 0.20 Hadoop examples dot jar grep input output dfs z dot plus. So for guys who have already done the first hands-on, you guys easily. So now I am running the job. It's a multi-node setup and I'm running this job. I hope it runs. No, it doesn't. It says there are some issues. Let's see what. It says user root has no permissions to write on the temp directory. My mistake. Because when I was doing chmod on temp, I should have done -r. I did not give recursive permission. Oops. Now I'm running this here. Started. All right, job is done. I can verify from here also. If I see output, say Hadoop fs cat output. Got it? So in this case, there are only 4 variables which are having DFS.